Hello everyone. Yes, so let us begin. So today we had mentioned on LinkedIn about the questions that you want, and the reply that we got was that for the array topic, you guys want us to solve 3 questions. So let us start with those. Great. So we will be today solving 3 questions of arrays. The one that people told was largest number. The other question was maximum consecutive gap, and I think there was one more question that people told us to solve. So yes, let us start solving them one by one. So as you can see that I have done my today's streak already, but I haven't solved these questions in some time. So yep, they will be almost like new to me. The very first question was maximum consecutive gap. So we will be solving this today. The other was largest number. So we will be solving this. And the next one was maximum sum contiguous subarray. Great. So all these questions are quite popular and are asked at some great organizations. So it will be interesting solving them. Let us start with maximum sum contiguous subarray. Find the contiguous. So the question says that you have to find a contiguous subarray within an array. Okay. So we will be given an array A. Whose length will be n, and we have to find the contiguous subarray within an array which has the largest sum. Okay, so for example, that we are given this array A, and okay, so there might be there can be how many subarrays? So for an array of size n, there can be like n into n minus 1 by 2 subarrays. Okay, so out of those subarrays, we have to find the one that has the largest sum. Okay, for example, like this subarray has sum 2, this has sum 2 plus 3 5 plus 4 9, this has some 3 plus 4 7 minus 7 minus 10, which is minus 3. So one thing to note here is that the numbers can be negative. Okay, so I think the largest answer will be here 1 plus 2 plus 3 plus 4, which is 10. Okay, 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 so we have to just return the integer, which is basically the largest sum in this subarray. We don't have to put the indexes, we just have to return what is the largest sum. Okay, so let us take this example only 1 2 3 4 minus 10. One very brute force way that can come into my mind is that, hey, I can choose a start index. Basically, my algorithm can be choose a start index. Then I choose an end index. Then calculate sum of that subarray. And then basically have a global maximum, and answer will be equal to max of answer comma current sum. Something like that. So there, if we have to choose a start index, there can be n start indexes. Similarly, there can be n end indexes. Calculating sum can take order of n, but we can actually calculate it on the go. So it will be like, let us say we can do it in order of 1. So the time complexity will be something like order of n square, okay, where n is the length of the array A. As we are given that n can be 10 to the power 6, so solving something in n square will time limit, okay. Let us see, I mean, like, suppose my answer starts from index 1. I mean, like, suppose it starts from 2 3 4. Suppose my answer is 2 comma 3 comma 4, okay. As the number just before 2 was 1, which is positive, so it won't be, I mean, like, it will never be a bad thing that if I also include 1, right? I mean, like, it will only increase my answer, okay. So if somehow I can compute, I mean, like, if the sum before my current index is positive, and I can include that sum in my answer, so that will work, right? Okay. So suppose here I can say that, hey, my current sum will be 1. Okay, because my current sum is 1. If I include that sum that I have till now here, so it's only going to increase. So 1 plus 2 is definitely going to be 1 plus 2 is definitely going to be greater than only 2, right? Okay, so I can similarly 1 comma 2 comma 3 will always be greater than 2, which will always be greater than 1 comma 2, which will always be greater than only 2, okay, or even only 3. So what I can do is, hey, that I maintain a prefix sum answer. Okay, suppose my current sum is 0. Okay, then let me calculate the size of the array in a variable n. Okay, then I iterate over the array for int I equals to 0, I less than n plus plus I. Okay, what can happen? So if my current sum is positive, if my current sum from the left is positive, that means it is going to add some positive value to the answer. So definitely, I mean, like, if that positive value is included, that will give a larger sum, right? But if that current sum is negative, I should not include that. Okay. So I can change that current sum equals to max of 0 or current sum. Okay. So then when I have the current sum, now I have to include the current element, the element at current index to the current sum. So I can say that current sum plus equals to AI. Okay. So this should be my answer till now, but let me have a global variable here of answer, which initially can be the minimum answer possible, like int min. Okay. So here I compute answer equals to max of answer, comma current sum, and I can return the answer. This should work, but let us say what are the edge cases. Suppose the size of array is 0. In that case, what should I return? In that case, the answer should be 0, but we are given that the size of array is minimum 1. Okay. So suppose the size of array is 1. That means that array is only 1. I will say answer is equal to int min. This loop will go only to index 0. Current sum will remain 0. So current sum plus equals to 1 and the answer will be 1. I think this should work. Let us test over this case. 1, 2, 3, 4 and minus 10. Let me test over this custom input. An integer array first number is the size. Okay. 5, 1, 2, 3, 4 minus 10, right? So the answer here should come out to be 10, if I'm not wrong. Yes. Yes, the answer is correct. I don't have any global variables. This seems fine. Let us test it. Interesting. Okay, one more thing. Okay, I am storing my answer in what we say an integer. Okay, what is the maximum possible value of answer? Maximum possible value of answer will be when all the numbers are the maximum possible number, which is 10 to the power 3. And we are told that there are 10 to the power 6 numbers. So the maximum answer will be 10 to the power 9. So max will be 1e9. And this can easily come in an integer. So I think we are safe. We don't need to take a long int. And let us submit it. Okay, they have opened one hint for me for free. I can't see anything here. Yep. So we got 222 out of 225 points. We solved it very fast in like 7 minutes. So that's good. Cool. So that was the first question that we had to do. Maximum sum subarray. Awesome. Now, do you guys have any doubts? Anyone has any doubts for this? Jashan says, please sir, solve the number n by 3 repeat number. That is actually an interesting question. Let us take it tomorrow. I mean, like, okay, because today we have already selected the questions. Okay, let us start with the next question. So we have to take the maximum consecutive gap. This is actually an interesting question. When I had solved it the very first time, I was able to had very large number of edge cases. So you are told that you are given an unsorted array, find the maximum difference between the successive elements in its sorted form. Okay, try to solve it in linear time or space. Okay, so okay, also we are given a in a constant form, so that means we can't modify the array a. So that is one thing that we have to take in consideration, that we can't modify the array a. Okay, also we are told that if the array contains less than 2 elements, we can just return 0. I mean, like, yes, obviously if there is only one element, then there is no gap in the array. Okay, and you assume that all the elements in the array are non-negative integers and fit in the 32-bit. Okay, so all the numbers are 32-bit, but will the answer be also 32-bit? Yep. So you are saying that the difference will also not overflow, so the answer will fit in an integer. So had we been allowed to sort the array, I mean, like, had we been allowed to modify the array, we could have just sort the array A, and we could have just what we say, return the max of AI minus AI minus 1 for all I from 1 to n, right? Yep. From 1 to n minus 1, where n is the size of array A. Okay. If n is less than 2, just return 0. So yeah, but this will be of time complexity of order of n log n. Okay. So this is the time complexity of order of n log n, but we are told that we have to do in linear time or space. Let us take this array only 1, 10, 5. If I draw these numbers on, I mean, like if I take a number line, this will look something like 1. There will be a lot of empty spaces. Then it will come 5. Then 6 should have come here. 7 should have come here. 8 should have come here. 9 should have come here. 10 should have come here. So if I remember that, okay, so we had to sort the array, right? If I had to sort the array A, there are multiple ways to sort the array. Obviously, I would have used an inbuilt library function, but there is also a sorting method known as counting sort. So where what would I have done? I could have created like an array from 1 to 10, which would have like indexes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at each particular index, I could have had the count of number of elements equal to that particular index. So here I would have 1, then 0, 0, 1, 0, 0, 0, 0. So obviously, if the size of this array would have been like 10 to the power 5, something like that, then I would have been able to solve it in order of n. But we are not given anything about the size of the array here, so we can't assume that the range of the numbers will be 10 to the power 5. Okay. So what if I see here on line number 11 is that suppose this was not 5. I mean, like currently the answer is 5 minus 1, which is 4, and 10 minus 5, which is 5. So currently the answer is 5, right? Yep, the answer is 5. Okay, so, but if suppose it was 7, then I would have here, and I would have 7 here, right? So basically the gap between 7 and 1 is increasing, while the gap between 7 and 10 is decreasing. It kind of is like acting like a rubber band, that where you are squeezing the element 7 to left or right. Okay. What can be the worst case? I mean, like what should be the minimum answer here? I mean, like suppose this was the case, then this gap is 6 and this gap is 3. Okay. Suppose I would have taken 7 here, and then this would have been something like here. So suppose it would have been 6. So the answer would have been, this gap would have been 5, and this gap would have been 4. So I think, yep, if I take this one more here, then the answer would have been 4 comma 5. Yep. So okay, so what we can see is that basically pairs are happening, right? I mean, like if the element squeezes, then one thing is decreasing whereas the other thing is increasing. So the answer should be like n by 2 for each gap. I mean, like for 10, the answer should be something close to 5, which is 5. So I mean, like there definitely can't be an answer smaller than this. So this should be the minimum answer if there are 3 numbers at least. Okay. Okay, so if I know that minimum answer is 5, if I know that minimum answer is 5, so can I group all these numbers in range of 5? I mean, like suppose if my numbers would have been 1, 2, 3, and 5. So suppose I had one group where I had 1, 2, 3. Then I had another group which only had 5. Suppose we also had 9 here. So the other group would have all the numbers from 5 to 9. Then this group would have 10. Because the answer definitely is going to be 5. So there cannot be the answer within this group only, right? Because all the numbers within this group are less than 5 distance apart. Similarly, all the numbers in this group are less than 5, and all the numbers here. Okay. Minimum answer is going to be 5. Okay. And then I can calculate answer by maximum of this group. Sorry, minimum from this group minus maximum from the previous group, right? Cool. So let us see how can we first calculate what the minimum possible answer is going to be. Okay, suppose the numbers were 1, 5, and 10 as the example was given. then minimum came out to be 5. Minimum was 5, right? And we also had to group in the ranges of 5. So basically, we can see that there are two intervals here. That this is, I mean, like 1 to 5, suppose was there, this one. So then we would have one interval from 1 to 4. So this was one interval, then this was another interval, and then this was it. Okay, so basically, I have to divide all the numbers from here to here. In suppose there were, I mean, like how many? Suppose there were three numbers into two intervals, right? All the numbers in this part into two intervals. Okay, so I can have number of intervals equal to 2. And what is the range of numbers? That will be 10 minus 1. So I can first calculate maximum and minimum. And maximum equals to value at max element a dot begin or a dot end. And then I have minimum also as value at min element a dot begin and a dot end. Okay. So what can be, okay, then how many buckets will I have to make? So if I take this case, my number of intervals will come out to be 2, which should actually be n minus 1. So here n will be the size of array. Yep, n will be the size of array. Okay. So the number of intervals, this interval, I mean like all this will have to be divided into n minus 1 different parts if all the numbers are equal distant. Okay, so there will be n minus 1 parts, like 2 parts here. Okay, and I know the maximum minus minimum, then range can be maximum minus minimum. Yep. Okay, now how many intervals are there? So in this case, range will come out to be 9. So the number of intervals will be, and the number of intervals here are 3. Number of intervals here are 3, which is equal to basically 9 divided by 2, right? Which is almost equal to 9 divided by 2. Or is it not? I mean, like range is equal to 9 divided by 2, a ceiling plus 1. So this is my size of each interval, okay? Because obviously they have to be integers, so they will be ceil of this by 1, the ceiling of this by 1, okay? So that will be the minimum possible gap. And minimum possible gap will be equal to ceil of float of ceil of float, or can I say something like this? Ceil of float of range divided by number of intervals plus 1. Okay, I can do that. Can anything be 0 here? Can the number of intervals be 0? What is the value of n? Yep, n can be 1. So in that case, I should return 0, right? If n is less than 2, I should just directly return 0. If n is less than 2, return 0. So now my range is fine. Number of intervals is not going to be 0, right? Because it is n minus 1. So definitely there is not going to be any division error. Okay. So now, as I told, that I have to have a minimum and maximum of each interval, right? So let me create. Okay, but how many intervals will be there? So this is the minimum possible gap. So each interval will be of that size. Okay. So the number of in total intervals will be equal to range plus 1, right? Because I mean, like all these numbers, there are total of 10 minus 1 plus 1, which is 10 numbers in the range of 1 to 10. So I have to divide those 10 numbers in 10 plus 1 numbers, basically. Yes, or 10 numbers. Was if each number is 5 away, then I will get 1, comma 2, comma 3, comma 4 here. I will get 5, comma 6, comma 7, comma 8, comma 9 here, and 10 here, right? So this is the maximum, this is the minimum, and each interval is of size of 5. So each interval should be of size 5. So these will come here, 6, 7, 8, 9, and 10. They should suffice here. And the answer will be 5. It should work. So the total number of intervals will be range, which is maximum minus minimum plus 1. Okay. And then upon minimum possible gap, because all the numbers should have been at least at this range. Then I take a ceiling of this. First, let me convert this to float, and then let me take a ceiling of this. Okay, suppose I have this as total number of intervals, then I can create a maximum and minimum array of that thing, vector of int, max interval of size total intervals, and I can initialize it by int min. Then I can have min interval, size total intervals again, and initialize it by int max. Okay. Then do I see anything there? Okay. So all the numbers will be minimum and maximum. Okay. So then I iterate over all the numbers and assign it to a group. Okay. For auto numbers in my array A will be group of that number. Group of that number will be equal to numbers minus minimum. I mean like indexes. So suppose let us have the numbers as 0, 1, 2, 3, 4, maximum minus minimum 4 minus 0. Divided by it should be something like minimum possible gap, right? Because each interval is at a size of this. Understand? Okay, so if I get that, then I have to change the max interval of group to max of this common numbers. Common numbers. Actually, I have to change min interval of group to min of this and numbers. Okay, and when I have that, then I can just, I mean, like I have to do probably this thing only, that my answer will be minimum possible gap initially. Minimum possible gap. And I know total intervals are this, so I can say for int I equals to 1. I have to actually know the previous maximum as well, right? And then there can be another interval which has nothing. So I have to know the first previous maximum, okay? Let me say that previous maximum is max interval of 0 because that is of the 0th group. Okay, for int I equals to 1, I less than total intervals plus plus I. If there is nothing in that interval, then okay, there's possible that there's nothing in that interval. If there's nothing in that interval, then max interval of I will be int min. Max interval of I is equal to int min. In that case, sorry, I can say that if max interval of I is equal to int min, I don't have to consider that there's nothing here. I can just continue. Answer will be equal to max of answer comma min interval of this minus the previous max that we had, right? Yep. And then I will have to change the previous max to max interval of I. Yes, that should work. And I can return answer here. But is there something that I am missing probably or something like that? If n is less than 2, I have just returned the answer, so there can't be anything 0 here. Can total intervals be 0? Because if total intervals is 0, then max interval 0 won't exist, right? Total intervals will be 0 if minimum possible gap is greater than minimum possible gap is greater than range, right? Then range. When can this happen? This can happen in cases like if minimum possible gap is greater than range, then my total intervals will become 0, right? Okay, when will minimum possible gap be greater than range? Yes, when all the numbers are together, like something like 1, comma 1, comma 1, comma 1, that is one case. That means I can check here if maximum minus minimum equals to 0, where all the elements are same, I can just return 0. Obviously, there's not going to be any gap. Okay, this thing is clear. Minimum possible gap is clear. Total intervals is going to be this. Is there any other case, then this total intervals can become 0. If total intervals is 0, then will that happen? Minimum possible gap is greater than maximum minus minimum plus 1. That can't happen, right? Because all the max minus minimum all the numbers if are same, then this can happen. It can also happen in cases like this. All the numbers are 1, 1, 1, 1, 1, 2, where the minimum possible, okay, the minimum possible gap will then take care of this. I think they should go, because then minimum possible gap will already be, what do you say, minimum possible gap will be 1. In that case, the total intervals will get taken care of. Yes, so I think this should work. Let us see. So I have done one bad mistake. Let me actually try run it on my code first. This is going to be 110.5, 3, 110.5, 3, 110.5. Will this work? Oh, it's not working. Why is this not working? Because here my range will come out to be maximum minus minimum, which will be equal to 10 minus 1, range is 9 by 2, 4 plus 1, range is 5. So there will be 5 numbers in this thing. Then minimum possible gap will be float of range, which will be equal to 9 divided by number of intervals, and the number of intervals will be equal to, in this case, 2. 9 divided by 2 will be 4 plus 1, 5. So the minimum possible answer is not this, but it is only this. I should not have 1. Yeah. Cool. Will this work now? In this case, it should work. Let us see if it passes for the general case as well. Okay, it does pass. Let us see if it passes everything. Nope, it doesn't. What is the issue that we have? We have an issue that your function returns something like this, but it should return a lot larger value. Okay, so my function is returning this, where it should have been returning 70015978. Yep. So where is the issue? The answer is previous interval I am updating. If max interval is this, I am then intervaling changing this. Okay, answer is equal to minimum possible gap. Then what am I missing? Let me actually see on my copy what am I doing wrong. Let me take my copy for this, and I will have max interval of this as this, and total intervals will be coming out to this by minimum possible gap, right? Maximum minus minimum is actually not total interval, right? Should it be maximum minus minimum only? Because the very first number will actually come in the first interval, so it should be maximum minus minimum divided by float of minimum. This should be it, and this should work. I think. Let us try run for this case now. It should be 497510007. No. What is happening, guys? Can there be multiple things? This thing is fine. This thing is fine. Numbers minus minimum by cap should also be fine. Okay, so what should be the answer here? So I will have my total intervals equal to this. Maximum of this. Will there be only these many intervals? But if there are more than this interval, then I should be able to get somewhere, right? Maximum minus minimum by cap by number of intervals is n minus 1, which should be fine. And my range is maximum minus minimum, which should also be fine. Then what is the answer here? Because I'm not getting an off by 1 error, so this will also be fine. And if am I calculating this correctly? Numbers minus minimum. Is there anyone who can find the error? Where are we messing up? Or let us try to fix it up. If n is less than 2, we are fine. If the number of intervals is n minus 1, okay, these are going to be the number of intervals, or basically the number of numbers between this. So this should be fine. Then the answer will be gap by number of numbers, right? Okay, range is equal to maximum minus number. So range by number of intervals should be my answer. So, and I'm also converting them to my float. And max. Am I doing something wrong here? Seal of logs. This seems to be fine. Okay, so there should be actually one number here more, right? Or will it not be? My answer should be minimum possible index. Let me just think about it. N is equal to 8.5. If the value of n is less than 2, I can just return 0. The number of intervals are going to be n minus 1. The maximum is this. Minimum is this. All the numbers from max to minimum are going to be separated in groups of something like this, right? Okay. If there is no number, I mean, like all the numbers are same, then I can just return 0. This is the range of numbers, and then I will have to, I think I will have to do range plus 1, right? Might be range plus 1, because 9 divided by 2 is 4. Float of 4 is 4, and then okay, so my minimum possible gap here will come out to be float of range is like 9, okay, by number of intervals, which is 2. So this will turn out to be 4 of 9 by 2, which is 4.5, which will turn out to be 5. So this is going to be fine. Okay, total intervals is going to be seal of maximum minus minimum by minimum possible gap. And also I'm converting my minimum possible gap to the correct thing. So this should also work. My maximum number of intervals are going to be something like this, which is also fine. My okay, max is I'm setting to int min, my min I'm setting to this, which is also fine. Then I'm iterating over all the numbers in array A. People are saying that it can be overflow. Let us see if this is really overflow. I don't think this can be overflow, because we are told you may assume that the answer will not overflow. So definitely it can't be overflow, because so answer previous max is max interval of 0, right? If max interval I equal to int min, so the answer is definitely not overflow. I can say that number of intervals is going to be n minus 1, yes. And then I think total intervals should have something plus 1, right? Because what if the last number falls somewhere ahead? So basically, let us say if we have numbers of size 5, intervals of size 5, 3, 4 will go here, 5 will go here, then 6, 7, 8, 9, 10 will go here, and suppose there was also an 11, then 11 would have gone here. In this case, suppose the numbers were 1, 5, and 11. Suppose the numbers were 1, 5, 11. We see that range is going to be 10. Okay. In that case, range and number of intervals will be 2, right? Number of intervals will be 2. In this case, this answer will be 5, minimum possible gap, which is perfectly fine, which will be 5. Okay. Then my total intervals will come out to be maximum. Okay. But total number will be come out to be maximum minus minimum, which is 10, which is also range. So seal of range here, basically nothing else. Range by minimum possible gap, which will be 5. So range is 10 by 5, which is 2. Plus 1 should be there. Yes, definitely. Plus 1 should be here because there are 3 intervals in this case. But will that solve this problem? Let us see. Will this even solve this problem? It should not, because otherwise we would have gotten a... Oh, it does. We are getting the correct answer. But why did we not get the answer here? Because we never actually iterated over that interval. And max interval of group. Why did this not return an error? Let's try to submit it if the code is fine. I don't doubt it can be fine. Let it be fine. Oh, it is fine. So what was the error that we had actually? We had that our number of intervals was less by 1. We found that using this test case, when we run using this, we found that, okay, our total intervals was coming less than 1. And we created this array of size total intervals. Okay. What are we missing? Great. So suppose there was a number here that had to come in that particular interval. Its group would not exist even, right? Because the max interval of group should not exist in that case. Interesting. So if max interval of group won't exist, won't it lead to index out of bound errors? It doesn't. Interestingly, it doesn't. Why? Let us actually come back to it, this thing, why this code didn't work initially at the end of this stream. And let us first solve the third question that we were given, which is the largest number. But this is an interesting issue that we actually found today. So we have to solve the largest number. So we are told that we are given a list of non-negative integers, arrange them such that they form the largest number, okay? For example, given 3, 30, 34, 5, and 9, you have to arrange it in this way, okay? One thing that I can see is that, okay, if a number is bigger, I mean, like if its very first index is bigger, it should probably come earlier, right? Because obviously, if I have to form, suppose something like using this array, if I have to form something using this array, then obviously I would want 9 to come earlier because 9 has the largest digit. So more early the 9 is, the better it is for me. Then I would definitely want 5 to come earlier because that has a larger first unit. Then out of these three, what would I like to have actually? I would like to have more something like, okay, suppose I say that, okay, I like to have 34 first. But if I have 34 and then uh, 3 and then, okay, suppose, okay, 34, I can have it. And then if I have 30, then I can have 3, that is fine. But had this 3 been here, then the overall number would have been better, right? Because then the number would have come out to be 9, 5, 34. So basically, that 3 would have shifted somewhat here, 343, and then 30. Okay. And what if the 3 would have been even more there? 953. No, this would not, this would have been bad, right? 33430 would have been bad. Okay, so I kind of want that this number, the number that is formed by combining these two, should be greater. Okay. Okay, so basically I want my numbers, I want these numbers to be arranged in such way that I have to combine them in this order only, such that they form strings in the largest way, right? Okay, I mean, like suppose I would have after 3 I would have had 9, then that would have created 39. Whereas after 9 I would have had 3, so that would have created 93, and 93 is always better than 39. Okay, so basically I think that I'm kind of dealing something like with strings. Basically, if numbers were strings, I know. So because I have to concatenate the numbers, concatenate the digits, so I can first convert all my numbers here to string. So let me say vector of string numbers. Okay. Then for all numbers, okay, for auto numbers, I will say string numbers dot pushback. I have to convert those numbers to strings. So basically C++ has this function to string of numbers. This will work perfectly fine, but now this will just convert these to strings. So rather than 330, now they are strings, nothing more. Okay. Now I have to sort these numbers in such a way that, I mean, like they are in such a way that suppose 9 is earlier than 30, that means 930 should be greater than 39, 309, right? So, okay. So if I have to sort them in that way, then I would need to have my custom sorting function, definitely. So let me make a sorting function that will do exactly this thing. That will concatenate, that will arrange the numbers in such way that the string formed of consecutive numbers will be the larger than any other string forms. Okay. So I will have to have a custom sort function which will take strings, two strings. So constant string uh, A, and it will take constant string E. Okay, so what are the cases? So I want to arrange them in the increasing order, right? I want to arrange them in the increasing order. So I want this order. Okay. So this will happen, and custom sort will say custom sort has to return true if this is less. Okay. I mean, like custom sort, if custom sort function will return true, then A will be less than B. So I have to do the opposite. So I will say return A plus B is greater than B plus A, something like that. Yep. What it means is that if A plus B will be greater, then A will come before B in the final array. So I mean, like if this is true, then my array will have A here and then B here. And this is string concatenation, so this will work. Okay. Okay, so now I have to sort my string numbers in this way. Begin, comma, dot end, and I have to use this custom sort function. Okay, suppose I have this. Okay, by the way, can the numbers be negative? Because if numbers could become negative, then this will, okay, so it's not negative, so then the thing is fine. And so we have to return the answer as well as okay, cool. Okay, so let me make a string answer, which I will return. Initially, it will be an empty string. So because all the numbers are now arranged in the perfect order, so I will say for auto numbers in the string numbers array, answer plus equals to numbers. So this will return the answer. I mean, like I can return the answer. But what happens whenever whenever actually we convert a number to a string is that it might have initial leading zeros. So normally we should avoid leading zeros. So we need to check if this particular number would have had leading zeros. So normally I have encountered this particular edge case in this kind of question. So let me say that int first non-zero is equal to 0. Then I will run loop for first non-zero will be less than n. What will be n here? N will be string numbers dot size because these, okay, sorry, string, this will be answer dot size. I have to iterate over each digit of the answer and I have to find the first non-zero digit. So I will say n n is equal to answer dot size. Okay, then I less than n, then plus plus I. If this particular character, if answer I is not equal to 0, I'm like it's a non-zero number, I can just break. So basically I know that at all the numbers before this I were 0. So I have to remove those leading zeros. Okay, so if I was 0, I mean like the very first number itself was non-zero, so I can return the answer directly. I mean like that is fine. Okay, worst case I can be n. Okay, else if I equal to n. This means it was everything 0, right? If it was everything 0, then answer is 0, so I can just return 0. Okay, else I have to return the substring of answer from the ith digit, right? Yep. Else I will say return answer dot substring I, and the length of the substring will be n minus I. Okay, so this should work if I don't have any issues. So let us take 3, 30, 34, 5, 9. 3, 30, 34, 5, 9, and the size of this array is 5. 1, 2, 3, 4, 5. Let's see what the answer is. And I'm returning. I again have issues. What is the issue? No matching function for, okay. So what I have the vector of, great. So I have a vector of integer and I'm pushing strings to it. So that's a very bad mistake to do. Do I have any other errors? No. Let us test it. Okay, so this thing should be here. I'm doing very bad errors today. Influence of no practice since long. Here also this. Here also this. Now hopefully there doesn't seem to be any other error. Great. I should now start practicing again so that I can do it in the very first attempt. I'm doing a lot of bad mistakes today. Now this will be perfectly fine. Answer plus equals to nums. This is, I think, a wrong error, right? Yes, this is highlighted for this thing. Answer is correct. And number is correct. N is equal to answer dot size. Oh god, this time it should come out to be correct. Yep. The answer is 9534330. 9534330 seems fine. Let's test it. Yep, this is fine. Let us submit it. Did we miss any corner case today? Yep, we got it. Cool. So now we had one question left that we had not seen yet. Yes. So let us now try to solve why is the first thing not working. I mean, like why the previous code was not working. Let me see. Do you guys have any questions other than that? Sure. Let us then see why are you guys able to see my screen, right? Okay. Let me change my screen now. Yes, hopefully you guys are able to see the screen. Let us see that why our maximum consecutive gap did not lead to an error when the total number of intervals was less than 1. What would have happened? Did we not assess the last interval anytime? We are setting the max interval to this, we are setting the numbers to this, and this was fitting. This was fitting. Okay. If we have to go to the last index, what was the case where this actually failed? This failed when this was the size of the whole total number of intervals was one less. That means something was going to come in the very last interval. Okay, so when intervals of 5, this thing is all fine. But okay, by the way, I can just remove this else check here because we are anyways continuing, so that doesn't matter really. So what is this minimum possible gap going to be? If our total intervals was one larger, and then we are setting a max interval and min interval of that range, we are getting a wrong answer. Yes, we are getting a wrong answer because let us actually take the case where we were getting the wrong answer. Do we still have that in the custom input? No. Let us actually change it to wrong again. So we all know that it was wrong, right? And let us submit it. So we will get one case where it was breaking, and let us try to dissect what that particular case was. Okay, so we also got one other case where this was failing 1, 10, 21, 33, 45. Okay, and this was the only error we have. So if we have array like this, then our range is going to be 45 minus 1, which is 44. And our minimum possible gap is going to be 44. And the size is n is equal to 1, 2, 3, 4, 5, n is equal to 4. And then we see that minimum possible. So n is 1, 2, 3, 4, 5. So this is number of intervals. So our minimum gap in this case will be equal to 44 by 4, which will be 11. Okay. And our total intervals will be equal to 44 divided by minimum gap, which is 11, which is 4 if we do this case. And in the correct answer, they were 5. So we got the case again where this particular issue was happening. So definitely there should be one. But then why did our code not break? So then we would have created a maximum and minimum arrays of size 4. So we would have an array of size 4, 1, 1, 1, 1. Similarly, we would have this of 1, 1, 1. That's amazing. And then when I would have assessed the number 45, this would have been assigned to 45 minus 1, which is 44, divided by minimum possible gap, which is 11, to array 4. But array 4 doesn't even exist. So we should have gotten an array index out of bound. Yes, we would have gotten an index out of bound error because this index would not even exist. But do we really get that? 1, 10, 21, 33, 45. 5, 1, 10, 21, 33, 45. And do we get the array index out of bound, or we return a wrong answer? We return some wrong answer here. So that is what the issue was. We were not getting array index out of bound due to some reason, which I also don't know. I mean, sorry, the total number should have been this. Then we should have gotten an array index out of bound. Are we getting that? Yep. So basically, we see that the output we were getting was probably confused. We get an error here. Basically, we return nothing. So that is why the issue was actually there. I don't know why the submit returned something wrong, but yes, we are getting runtime error if we have such cases. But our code didn't return that at that particular time. Probably some issue with the code editor, but I think this should work now. Great.
Hello guys. Cool. So let's go to the programming section. Okay, so I have already solved one MCQ of time complexity, so I have already gained 100 points. But let's today solve a problem on maths. Now we need a question that is asked in Google. So here is a question: grid unique path, but I think that is supposed to be an easy problem. So let's leave that. Okay, greatest common divisor is just the GCD. You guys can do that yourself. Okay, let's solve this problem. Sum of pairwise Hamming distance. Okay, this was asked in Google, and the average time to solve the problem is around 1 hour. So it's going to be a pretty long session. Okay, so just be patient. The problem says that Hamming distance between two non-negative integers is defined as the number of positions at which corresponding bits are different. Okay. For example, Hamming distance between 2 and 7 is 2. How come is it 2? Because 2 can be represented as 0, 1, 0 in binary, and 7 can be represented as 1, 1, 1. So we can say that here there is a difference in the first bit, the least significant bit. Then the next bit is same in both 2 and 7, it's 1, but the most significant bit is again different. So there are two bits in 2 and 7 that are different, right? So the Hamming distance between 2 and 7 is 2. Okay, cool. So we got the concept of Hamming distance. Now let's see what the problem says next. It says that given an array of n non-negative integers, find the sum of Hamming distances of all pairs of integers in the array. Return the answer modulo 10. Okay, this big number. Yes. So I am given an array in this question, and I have to find the sum of all pairwise Hamming distances, right? So for example, if the array is 2, 4, 6, so there are these all are the pairs, right? So in the example, we can see that every number is also forming a pair with itself. Okay, then 2 and 4 is a pair. Okay, 2 and 6 is a pair. Then there are three pairs that are starting with 4. So 4 and 2 is again another pair. So we have already had 2 and 4 as a pair, and now 4 and 2 is a different pair. It's counted as a different pair. Okay, so for every number we have n total pairs. Okay, cool. So the problem in the first go looks pretty easy to me. Why? Because I just have to calculate the number of different bits in all the pairs of numbers, right? So first, let me change it to Java. Okay. So for example, if in this given example that we have, right? Here we have 2, 4, and 6, right? Now, if I want to get the number of different bits in 2 and 4, okay, between 2 and 4. So to get that, I can write 2 in binary, then I can write 4 in binary, and now I have to count how many digits are different in these two. Okay, cool. So if you guys remember that there is a bitwise operator XOR, right? What is the property of XOR? XOR says that XOR of two different bits, okay, XOR of two different bits, that means 1 and a 0, or 0 and a 1, is always going to be 1. So I can say that 1 XOR 0, this is always going to be 1, and 0 XOR 1, this is also going to be 1. On the other hand, the XOR of same bits, similar bits, 0 and 0, this is going to be 0, as well as 1 and 1, this is also going to be 0. Right? So I can see that if I take the XOR of these two numbers, in the result of that, all the bits that are set, okay, or all the bits that are different in the two numbers are going to be set. So the first thing that comes to my mind is take XOR of all pairs of numbers of this array and count the number of set bits in the results. Okay. So for example, in this case, I will take the XOR of all the pairs. I will take the XOR of 2 and 2, 2 and 4, 2 and 6, and 4, 2, 4, 4, 4, 6, and so on. And in the result of every XOR, I will count the number of set bits. Okay. So let's try to write a code for this. Okay. And before we write the code for this, let's also try to discuss what is going to be the time complexity of this approach. Okay. So what have I decided till now is that I will consider each and every pair. Okay. So I'm saying that for every pair, okay, let me write this in comment. For every pair that I have, okay, I'm going to calculate Hamming distance. Okay, Hamming distance for that pair. So to calculate every pair, I will actually have to run 2 loops, right? So calculating every pair is going to be an n square operation. Then to calculate how many bits are set there, that is going to be that is going to take the time equivalent to the length of the data type that we have. So in this case, we have integers are stored using 32 bits. So I can say that this operation requires only 32 amount of calculations, 32 operations. So we can assume this is going to be a constant operation for now. Okay, but to calculate each and every pair, this is going to cost me n square. Okay, now n square doesn't sound very optimal to me. Okay, but since there is no mention here in the code, why don't we code this and check, right? We already have scored 100 points for today using an MCQ. So we have the liberty to lose a little bit of score here, even if it doesn't get uploaded. Okay, so let's actually write a code for this brute force approach first, and let's see whether it passes the solution or it doesn't pass it. Okay, chances are that since this is an n square approach, it's not going to pass, right? Cool. So first of all, I need to have all the pairs, and then I will calculate the Hamming distance between all the pairs. Okay, so let me initialize an answer variable here. So I have to calculate the Hamming distance. So I will name my variable as Hamming distance sum. I'm initializing this with 0. Okay. Now I need to run 2 loops to calculate all the pairs. Okay. So one of the first loop runs from 0 to the length of this list, and then again I have another loop that is going to run from 0 to the length of this list. Okay. Now in all these pairs, I have to calculate the Hamming distance of all these pairs. So let's actually write a function for that. We should not have a messy code. Okay, the code should always be modular. So let's have a function that will calculate the Hamming distance between 2 numbers. Okay, as shown here, we will have a Hamming distance function that calculates the Hamming distance between 2 numbers. So I will just have to add this. And I will add in this variable, I am going to add Hamming distance of pair. Okay, and the pair is going to be A of I and A of J, right? This is going to be my pair. I'm going to add this to my Hamming distance variable, and let's after this is calculated, after the 2 loops, I will just return this value. Okay, so now let's write this method that calculates the Hamming distance between 2 numbers. Okay, so this is going to take 2 integers. Okay, now how to calculate the Hamming distance between 2 numbers? Again, I can say that I just have to take the XOR of these 2, and then I have to count the number of set bits in the XOR. So why not have another function to count the set bits? I will say number of count set bit in the number A's or B. Okay. So I have okay, I have this math. Now I just have to write a function that counts the set bit. So it's going to take an integer. Okay, how to count the number of set bits in a number? Okay, so let's say that this is my binary number in which I have to count the number of set bits. So there are multiple methods using which we can count. The most basic method that I find useful is that I can take the end of this number with 1. Okay, so this checks whether the bit in the least significant bit is 1 or not. If the answer of this is going to be greater than 0, that means that this bit was 1, because 1 in binary is going to be something like this, right? So after I check for this bit, now I have to check for the next bit. So either I can left shift the one by 1 bit, or I can right shift the number by 1 bit. Okay, so I in this case I will right shift the number. So the new number will become something like this. Again, I will take the end with 1 and I will check whether the answer is greater than 1 or not. Okay, so I will just say that let me declare an answer count. Okay, I will say while A is greater than 0, what do I have to do? I will check whether A and 1. Okay, if this number is greater than 0, in that case, this means that the least significant digit of this number is 1. So I can increase the number of count. Okay, and after I have checked for this, now what do I have to do? I have to right shift A by 1 place, right? So I can say A is equal to A right shifted by 1. Okay, so what will happen is, first I check for this position. Okay, now after I check for this position, I will right shift the number. So now the new number becomes this. So now I am checking for this position. Okay, again I will right shift and the new number becomes this. And finally, after all the digits are checked, A will become 0, right? So this loop will stop. Then I will return the count. Okay, so the code is ready. Yeah, I think that the code is ready. Let's try to test this code. Okay, whether this works or not. Okay, so we have written AJ. This should be A dot get J. Okay, so this is correct answer. So that means that it has passed the initial test cases. Now let's try to upload this code. Okay, guys, remember that the time complexity of this code, as we have already discussed, is n square. Why? Because we have this loop that runs from 0 to n. Then inside this we have another loop that runs from 0 to n, and we can assume for now that this is a constant operation. However, this is also going to be equal to the length of this A, right? The number of digits in A is going to be proportional to the time complexity of this operation. But let's assume that in this case the length is going to be only 32. So for now, let's call this as a constant operation. So we can say that this is a n square loop. Okay, so let's try to submit this. It's taking some time. Seems like a lot of people are programming on interview bit currently. Submission is queued. Okay, this says that the time limit has exceeded. Okay, we have got some partial marks. So as we had already predicted, that this is not going to be an optimal solution for this problem, because this is just a brute force solution. This runs in order n square. How can we solve this? So how can we optimize this? Okay, to optimize this, let's have some observations. Okay, so here we have this array and we are calculating all the pairs, right? So in this code also we are calculating all the pairs. We have a pair of 0, 0, then we have 0, 1 and so on. So we are calculating all the pairs as given in this example. But guys, tell me one thing. do we actually need to find the Hamming distance between 2 and 2? Okay. The Hamming distance, what is Hamming distance? If we see the definition, it's the differences of bits, right? Between two same numbers, there is not going to be a single bit that is going to be different, right? If I am calculating the Hamming distance between 2 and 2, both of them can be represented as 0, 1, 0. Both are same number. So none of the bits is going to be different. So I can easily say that this will always be 0. So Hamming distance between any number a and a is always going to be 0. Next thing that I can find out here is I'm calculating the Hamming distance between 2 and 4. Again, I'm calculating the Hamming distance between the same pair. Okay. So does the order matter here? Okay. Does the answer change if I change the order of 2 and 4? No, right? It's the number of bits that are different. Whether you compare 2 with 4 or 4 with 2, the answer is going to be same. So one very small optimization that I can do is I can start this loop from I plus 1. Okay, I don't actually need to consider for all the j's, I don't need to consider all the i's that have been considered. Okay, because this is not going to be counted for the next row. Even this is not going to be counted because I have already calculated this value here, right? So this is a small optimization that we can do, but the asymptotic time complexity still remains n square, right? We haven't reduced the time complexity. There are some calculations that we have avoided, but the time complexity still remains the same. So maybe we will now have to think something out of the box, okay? And remember that this question was asked in Google, right? This is asked in Google. So Google is not going to ask you a question that that you can solve using brute force, right? So okay, let's make some more observation and let's try to find out a better solution. Okay, so I'm writing writing down this test case here. Now if I need to find out the sum of Hamming distance between all the pairs here, maybe let's start with converting all of them to binary. Okay, and let's see if that gives us some hint or if we can draw some observation from there. Okay, so I can write 2 as 0, 1, 0, 4 can be written as 1, 0, 0, and then we have 6, that is 1, 1, 0. So currently what we are doing is we are calculating the Hamming distance between this number and all the other numbers. Okay, but if okay, so let's do this exercise. That let's try to first calculate the Hamming distance between 2 and 4. So if I calculate the Hamming distance between 2 and 4, in the least significant digit, I get a 0, right? Because they are not different. In the next next digit, I get a 1. Again, in the next digit, I get a 1. So total, there are 2 digits that are different. Okay. Similarly, if I calculate the Hamming distance of 2 and 6, okay, again I will compare this 0, which is at the least significant place, with this 0. Then I will compare this one with second one with this one, right? So guys, I am able to draw an observation here, and you guys should also be able to draw that if I need to calculate the Hamming distance of 2 with any of these numbers, I can say that when I'm comparing 2 with these numbers, this 0 that is placed at the least significant position in 2, this is being compared with the numbers or with the digits that are placed in the least significant place in the other respective number, right? I can say that this 0 is being compared with this 0 and this 0 in 4. In nowhere in my program, I am going to compare this 0 with any other digit present in the array. Okay, this is only going to be compared with the digits that are present in the least significant position. Similarly, this 1 that we have in the middle, this is going to be compared only with the 1 that is here in the middle of 6 and this 0 which is in the middle of 6. So I can say that let's actually put some space here, right? So all these three zeros are going to be compared with each other to calculate the Hamming distance, right? All these ones, 1 and 0, these this whole column is going to be compared with each other, and the most significant column of all the numbers, this is also going to be compared with each other. Okay, so can I say that this is equivalent to finding the pairwise Hamming distances in these three arrays? I have one array of 0, 0, 0, that is the array formed by the least significant digits. Then I have another array of 1, 1, 0. Then I have another array of 0, 1, 1, right? Can I say this? That finding the total sum of Hamming distance of all the pairs is equivalent to finding the sum-wise Hamming distance, pairwise Hamming distance sum in these three arrays. Because at the end, what am I doing? I am comparing this 0 only with these two 0. I'm not comparing this with these 1 0, or I'm not comparing it with these digits. Okay, so the position of digit is important. Any number, any bit at ith position is only going to be compared with the ith bits of the other numbers. Okay, so I have just separated them out logically, and now I can say that this contributes, this least significant digits, their contribution to the total sum-wise Hamming distance is going to be 0, because all of them are same. Okay, now let's see what is what is the contribution from here. So I can say that one pair I get between these two. These two are different, so definitely this is one Hamming distance. Then again, 0 and 1 is also different, right? So I will also have I will have a Hamming distance of 2 coming from the second bit. Second bit meaning the middle column that we have. From here, I am getting a contribution of 2 in my total Hamming distance, right? Similarly, this is also going to give me a contribution of 2. And since these are only these pairs, right? I'm only considering 2 and 4. I have not considered 4 and 2 till now. So I can definitely say that if I have to consider the reversed pair also, I can double my answer. Whatever I'm getting from here, I can double that, right? So I'm getting a total sum of Hamming distance as 4, because 2 plus 2 is 4. So I get 4. So I can say that 4 multiplied by 2 is going to be my answer, right? Which is true. 4 multiplied by 2 is the answer in this case. Okay, cool. So now my job is to find the pairwise Hamming distances in all these bit sets. Okay, I have a set, I have this list of all the bits in the least significant position, and then in the next position, and so on. Now the question is, again, I have to do this pairwise Hamming distance calculation. So again, calculating distance between all the pairs is going to cost me n square. So what is the advantage that we are having here? So guys, now let's focus here that in this array, in these array, I am only going to have 1 and 0. Okay. If I have, let's say, C1 number of ones, okay, the number of ones is C1 and the number of zeros in one of the arrays C0. Can I find the total number of different pairs using this count? Can I do this? Yes, no? Okay, let's say I have 2 zeros and I have 3 ones. Okay, let's actually index them for better understanding. So I'm indexing them starting from 1. Okay, so the 0 placed at the first index, this will form a pair with all these 3 ones. Okay, because currently I'm talking about the digits at only a given place. So you can assume that we have a 0 here and all ones here in the least significant bit column, right? So this 0 is going to form a pair with all these ones. Similarly, this 0 is also going to form a pair with all these ones. So how many pairs am I going to have? I am going to have 3 pairs for all the zeros. Okay, this 3 is nothing but the count of ones, C1, and I'm going to have C1 number of pairs corresponding to every 0 in this array, which means I am going to have in total C0 into C1 pairs. Okay, so if I just have the count of zeros and 1, I don't need to run 2 loops. I can just multiply them and get the count of different pairs, right? Okay. So now let's do this. Okay. Uh, Before actually writing the code, try to estimate the time complexity of this approach. Okay, so everyone is on the page. Is everyone agreeing that this approach is going to work? First of all, this will work, right? Because we have concluded that to calculate the total Hamming distance, we don't need to compare this 0 with any of the digits except the digits in the same position, kept in the same position, right? So I am calculating the pairs of this 0 with only the bits placed at that position in other numbers. Okay, so that's why I can say that this is going to work. I will calculate for all the different columns, and then I will add them up, right? Now to calculate them, I don't need to iterate over the array and calculate it for all the pairs. I can simply do count of 0 multiplied by count of 1, and I can get the different pairs. Okay. So first thing here is that I need to run a loop, because I now have to find the count of zeros and 1 for every ith position in every number of the array. Okay, are you getting this? I have to find count of zeros and ones for every ith position. Okay, so I can if I just write it in plain English, right? So I have to calculate the count of ones for every ith position. Okay, for every number in the array. Okay, cool. So this simplifies the thing to code, right? Because now I can say that I will be running a loop that runs for each and every position, that starts from the 0th position and goes till the highest position that we can have. And similarly, after this, we will have in a nested loop that will run over all the array elements, right? So first, I will be calculating the count of ones and zeros in the 0th position, that is the least significant bit position. For all the numbers, I will calculate the contribution of that column in the Hamming distance, and I will keep it. Then I will do the same thing for the next column. I will add it to my Hamming distance that was previously calculated, and so on. Finally, I will be getting the answer. Okay, cool. So now let's try to estimate the time complexity here. So this loop, this surely runs for order n, right? This is going to be an order n loop because this is running for all the array elements. Now, how many times am I going to initiate this loop? How many times is this going to be initiated? It's going to be initiated for every I position. What do we mean by position? Position is nothing but the length of our data type, right? If I'm talking about 2, if these numbers are stored using a data type that takes only 3 bits, so this is how the numbers would look like, right? This is how the numbers are going to be if the length of or if it's only taking 3 bits to be stored. If there are 4 bits, then numbers would look something like this. In case of integers, I hope you guys are already knowing this. The length here is 32. Okay, integer is stored using a 32 bits. Okay, any integer is stored using 32 bits. So this loop is going to run at max for 32 times for integers. If the data type is changed, if it is long or if it is long, maybe this might run for 64 or maybe for even long, right? But in this case, it's going to run for 32 times. Okay. So now I can say that I have done a huge improvement in the time complexity of this code that I have already written, right? Because this was definitely an n square code. Now I have reduced it to some constant multiplied by n, which is nothing but order n. Now I have reduced it to a linear time complexity. Okay. So now let's try to code it. Okay. So I'm going to comment all these functions that we wrote, although the code structure was good, but they are of no use to us. I'm also going to delete this. Okay, this can still be used because this is going to be the answer. Right, so as we have written, we need to run a loop for each and every position. Okay, so I will run a loop here for int I equals to 0, I less than. So in this case, we have said that integer is stored using 32 bits. So this loop will run only for 32 times. Okay. Now inside this loop, I have said that I need to count the number of set bits for all the array elements. Okay. So first of all, if I have to count them, I need to store them somewhere. I need to store the count somewhere, right? So I will declare two variables. Let's say set bit count at position I. Okay, so this will denote the count of ones at the ith position. Similarly, I can have unset bit count at position I. Okay, so guys, this is one tip from my side, that whenever you are writing a code, even if it is for your practice, or whether it's for your interview, or whether it's for your company work, always keep the variable names very descriptive. Okay, variable names should be self-explanatory. I don't need to write any comment. If someone reads this code, he will understand what this variable is doing. Instead of having count, flag, temp, right, a b c variables like this, always have descriptive variable names, self-explanatory variable names. Okay, cool. So now now what will I have to do? Now I need to run a loop for all the elements of the array. So I will just run a loop j less than a dot size. Okay, this loop is going to run for all the array elements, and now inside this, for all the array elements, right, for all of them, I need to check whether their ith bit is set or not. So currently I am iterating over all the array elements, but I am only concerned about the first bit, or the least significant bit. In the next iteration, I will be concerned about the next bit. Okay, so how can I check whether this ith bit is set or not? This is again a very trivial thing if you have learned bit manipulation, because checking if the ith bit is set or not. So let's say if I have this number, okay, represented in the binary form, if I need to check whether the whether the first bit or the least significant bit is 1 or not, I can just take an AND with 1, and I can check if this number comes out to be greater than 0, then I can surely say that this bit is set, right? But if I have to check whether this second bit is 1 or not, then I need a number something like this, right? I will have to take the AND with 2. If I need to check for the third bit, I need to check it with 4, right? Because if I'm checking for any ith bit, I need to have AND of that number with any number that has a 1 only at the ith bit, right? Then only I can say that this number has a set bit at ith position or not. Right? So what will I do here? I will simply say that if my array element a cat I, okay, if this is going to give me, if I take an end of this with 1 left shifted by I position. Okay, why left shifted by I position? Because in the first iteration, when I is equal to 0, I need to check only for the least significant bit. When I is 1, I need to check for this first bit, right? So in the next iteration, I can left shift 1 by 1 position, so I will be able to check for this number, for this digit, right? Then in the next iteration, I will be able to check for the next digit, and so on. So I can take an AND of this with 1 left shifted by I position, okay? And if this quantity, if whatever is the result of this, if this is greater than 0, then I can say that I have a 1 at the ith bit, okay? So in this case, I can just increment the count of set bit at ith position by 1. If it is not the case, that means if everything comes out to be 0, in that case, that means that the bit is not set. So I can say that the count of unset bit is incremented. Okay, I actually don't need to do this because we can actually count the number of unset bit just by subtracting the count of set bit by the size of the array. But just to keep it simple, I will count this also. Okay, cool. So after this loop ends, after my first for loop ends, I've got the number of set bits in the ith position. I've got the total count of set bits in the ith position. Now I have to add the contribution of this ith position to my Hamming distance, okay, to this Hamming distance sum. So for that, okay, let me see, where is my bracket, right? So after this loop, I have to increment the value of my Hamming distance sum by how much? By how much are we going to increment? We have seen, right, that contribution of any column is count of 0 multiplied by the count of ones. So I can say that this is nothing but this has to be incremented by the count of set bit at position I multiplied by the count of unset bit or count of zeros at position I. Okay. So I'm going to increment this, and okay, so here we didn't consider the reverse pair, right? If I also want to consider the reverse pair, then I will have to multiply it by 2. Why am I multiplying it by 2? Because I have currently only considered 2 and 4. I haven't considered the pair 4 and 2, but 4 and 2 is also a valid pair. So to get that also counted, I will multiply the total count by 2. Okay. So now I have I have the Hamming distance of the contribution of Hamming distance is added to the total sum. Okay, the contribution of this column has been added, and now I will do it. So for the next bit position, so this loop runs and it will automatically get added to the this Hamming distance sum variable. Okay. Finally, I will just return this. Okay. Cool. Okay, guys. So now this code looks good, right? This looks. Does this look that it will work? There are few issues with this code that I can see. There is a bug in this code, and a requirement that we have missed. Okay, so there are two things wrong with this current code. One is that there is a bug. Second is that there is one requirement that we are missing. So the requirement that we are missing, let's go back to the question. What does the question say? Question says that given the array of this Hamming distance for all pairs, return the answer modulo this. Right? So answer can also be very, very large. So we need to, what we need to do, we need to return the answer modulo by that number. Should I directly take the modulo here? Should I directly take the modulo while returning? No, right? I cannot do that, because chances are that since we are multiplying this thing here, chances are that this will overflow, right? We don't want that, because this is going to be an integer and we don't want an overflow. So we need to we need to actually do the mod operation here, right? So let me just copy this number. Okay, so what we can do is, since we are adding it here, let's add just simply the mod here. Okay, and let's add this equals to So it will now follow the basic modular arithmetic a plus b whole mod m, right? So that's what I have done, a mod m plus b mod n whole mod m, right? So that is what I've done here. Okay. So now the requirement is sorted. Okay, so now it will also work for large numbers. Now there is a bug in this code. Can anyone figure out what is the bug here? Anyone? Okay, let's recheck this code. Okay, because this is a kind of bug that is very common when you are implementing an algorithm. Okay, but when you give an interview, when you are giving an interview, you have to make sure that before you tell the interviewer that my code is ready, you actually have to recheck your code, and you have to test your code on some of the inputs. Okay, so if I test this code on some of the inputs, I will be able to find that here I am doing a dot get I. Okay, is this correct? This is not correct, right? Because this is not something that is relevant to this is not denoting the array index. This is denoting the position of bit of the number. J is denoting the array index. So this is a kind of bug which is very common during the implementation. Okay, because I am used to of taking I in my array, so that's why I wrote I here. But it should not happen, right? So it should be J. So always be conscious while you are writing the code. Okay, so J is the variable that is iterating over the array element, right? Okay. Now let's try to test this code. Okay, it says correct answer. Cool. Should we upload this, or is there anything else that we should take care of? Okay, so it worked fine for the smaller inputs, right? But I again can see a problem, and I'm able to see the problem because I have solved lots of problems, right? I have solved lots of problems where I have faced this kind of issue. See, here we are multiplying these two numbers, right? Given that the Hamming distance variable is an integer, okay? Now you guys can say that we are taking the modulo here, so this should not overflow, right? This is not going to overflow, but we are doing this multiplication first, and then we are taking the modulus. Okay, so try to understand this operation. We are doing here a into b, right? Whole mod sum m. Okay, this is what we have done here. But now if this a into b, if this overflows, right? If I am multiplying two large integers and if they are overflowing, then this is going to fail for large numbers. So I need to fix this. One thing that I can do is again use modular arithmetics, again apply mod for every number, or simply maybe I can just cast them as long. Okay, that might also work. So I will just cast them as long, so that whatever product that I get, that is going to be accommodated in a long variable, okay, in a long data type, and then I can take the mod, so then it will be converted to integer back. Okay, so this is again a very common type of a bug that we make while coding, right? Again, let's try to first test it, because if I upload it directly and there are some errors, then I will lose points, right? Cool. So now I think that this should work correctly. Let's try to submit it. Great. Now it says that, oh, great. Superman also fly, right? So we have solved this problem. Okay, we lost some points because we uploaded a brute force solution, but we have achieved the daily score goal. Okay, so congratulations to all of you. Okay, so guys, please try this problem on your own. Please try to solve it. This is a very interesting problem. It was asked in Google, and again, this is a pattern of problem. You will be finding a lot of problems based on this pattern. What is the pattern? Pattern says that don't compute Hamming distance of all the pairs. Instead, go column wise or go bit wise. Okay, so we observed this thing that the value of Hamming distance is not, it's independent of, it's only depending on the bit position. Okay, if I have a bit at ith position, that is only going to be compared with the bits, with the ith bits of other numbers, right? So this was the key observation in this problem. Using this observation, we built on the approach and we solved it in linear complexity. Now, also, one more thing, saying that this problem is solved in linear complexity is wrong. Okay, so we initially assume that this loop is going to run for only 32 times, right? Which is also visible here. So it literally runs for 32 times only. But this is only the case when we are having integers. If we are having longs, then this 32 will change, right? If we are having long, then that will further increase. So I can say that this is not a constant number. This is also depending on the type of input, right? Maybe not the size of the input array, but it is dependent on the size of the data type that we are using. So let's try to compute the correct time complexity here, right? Let's not call it a linear program. Okay, let's try to compute a correct time complexity here. So this loop definitely runs for n time, right? So I can say that this loop is going to cost me order n operations. Now this is the maximum length that the data type can have. Okay, so if you have, if you know how binary numbers actually works, right? Because at the end all the numbers are going to be stored as binary, right? How the binary numbers works. So if I say that if m, let's say, is the maximum number that I can have in the data type, okay, m being the maximum possible number of that data type, what should be the length of that data type? Can anyone tell me what should be the length of the data type if m is the maximum possible number that I can have? Correct. It's going to be of the order of log n, right? So I can say that this is not exactly a linear solution. This solution is going to run for n multiplied by log of n, log base to n, where n is the length of my array, m is the maximum possible number that I can have in the data type. In case of integer, this log m will give you 32. In case of a longer data type, it will give you 64. In case of another even longer data type, it will give you a larger number, right? So guys, always like note this point, that when you compute a time complexity is not for a code. Time complexity is always for the algorithm. Algorithm is, it's agnostic about the data types. Data types can differ from language to language, compiler to compiler, right? But algorithm remains the same. So time complexity always corresponds to the algorithm, not to the code. So the time complexity of this algo is going to be n log m, where n is the size of the array and m is the largest possible number in that data type. Okay.
Hello everyone. Today we were supposed to discuss binary search, right? So the questions that people had asked, the top commented questions were search in a sorted rotated array, painter partition problem, and median of two sorted arrays. Correct? Cool. So yep, I think that is the most recommended one. So we will start with those. So first, let us start with search in sorted rotated array. I think this is that question, right? So basically what the question says is that we are given an array which is in ascending order, and basically someone suppose rotated the area based upon a pivot point and the whole thing went right, thing like that. And so basically suppose 0 1 2 goes here, and this 4 5 6 7 was supposed to come after 2, but because it is a pivot, so what we say, it went at the back. Okay, so we will be given an element, so it's just like binary search, but the array has been modified. Okay, so we will given an array and we will be given the number we have to search. Okay, if it's not present, we just return minus. Numbers can be integer and the size of array can be 1 2 3 4 5 6, so 10 to the power 6. So something like order of n or order of n log n will only work. Nothing more than that will work. I mean, like, I don't know even n log n will work, but something like order n can work or order log n will be the best thing, right? Because it's in binary search. Okay. And all elements are distinct. Cool. So one thing that I can get from this thing is that if the array was, I mean, like, if the array was not modified, if the array was not rotated, we could have just applied binary search and we would have gotten an answer in log n. Okay. Now there are two ways. I mean, like, somehow if I'm able to find where the smallest element is in this array, then I can do two things. Either I can binary search in this part, binary search in this part. So basically apply two binary search and then what we say, return the answer. I mean, like, if any of those have the number, I will just return that. Okay. That is one way. Or if I say, suppose, let me copy this array 4567012, right? Okay, so suppose I copy this array. Okay. This. So if I write this indexes, it is 0, 1, 2, 3, 4, 5, and 6. Okay. And if the indexes were normal, I mean, like, then the normal array would have been this 0, 1, 2, 4, 5, 6, 7. And the indexes would be 0, 1, 2, 3, 4, 5, 6. Right. So if I see that the new index of 4, is 0, the index of 4 now is 0. Earlier, the index of 4 was 3. Okay. But 0 is equal to, what I get from 0 is that 0 is equal to 3 plus 5, 6, 7. So each number is put 4 ahead, right? So basically each number is put to right 4 times. So it is just new index is going to be 3 plus 4 mod 7. Okay. So even if I somehow know that what is the shift position, I mean, like, how many how many shifts to right have been done, I can just use modular arithmetic and apply the normal binary search. Okay. So now let me see how can I find, I mean, like, how many shifts have been done. What I get is, suppose, okay, I mean, like, if I have to do order of n to find that, okay, this is the smallest number in this array, then it defeats the purpose. I mean, in order n, I can just find if the number exists or not. So I will have to do it in better than order of n. So what I see is that, I mean, like, for all these numbers, 4, 5, 6, and 7, um, suppose this is something like that, right? So, okay, so as all the elements are distinct, what I can get is that, so this is going to be the smaller number, smallest number. This is increasing here, but I mean, like, all these numbers are going to be greater than what we say, this number, greater than the last number of the new array, of the rotated array, right? So I mean, like, even I can do binary search. If somehow, suppose my mid is this, I check against the end number of the array and say that, hey, as the number at the current mid is greater than the number at the back of the array, my smallest element lies to the right of the current mid, right? Yep. So I mean, like, how I can do is that, suppose I have to find the smallest index, smallest number index. Let me say I don't know it. It can exist anywhere in the array. So let me say the size of array is a row size. It can exist as anywhere in the array. So let me have two pointers for normal binary search. L is equal to 0 and R equals to n minus 1. Okay, then I will say while L is less than equal to R, n equals to L plus R minus L by 2. Okay, so now as I told above that, okay, for all these numbers, the number at the end of the array is going to be smaller than those numbers. And suppose if at the current mid, the number at the index at the end of the array is smaller, I can just go right. Okay, so I can say that if array mid is smaller than, what we say, sorry, array mid is greater than array of n minus 1, I will say L is equal to mid plus 1. Okay, else what will happen is that I am at any of these positions. Okay, suppose I am at 1. Okay, so if I'm at 1, the number at n minus 1 is greater. Okay, this can be the smallest index, or smallest index can be somewhere to left of 1. So I mean, like, it can even be 0. So I can say smallest index can be mid, or I still have to search. It might be somewhere to left as well, right? So I think they should at least get me the smallest index. Okay. So as we saw in this array that, okay, the new indexes of each number, suppose, okay, here the smallest indexes will come out to be 4. So as we see that new indexes of each number is just going to be previous index plus 4 mod 7. 7 basically is the size of array, so which is n. So I can just apply the normal binary search, but assume that I'm applying the binary search on the rotated array. So I mean, like, what I can do is that L will be equal to 0, R will be equal to n minus 1. So this is the normal binary search that we can apply, but I think we will have to do one modification. L by 2. Okay. Now, because suppose I'm assuming that the array A is sorted. Okay. But arrays A is not actually sorted. So what was supposed to come at mid index of completely sorted array A will now come at mid plus smallest index mod of n, right? So as I told above. Okay. So this will be the new index of that array. Then I can say, so then I will apply the normal binary search thing that if A new index is less than B, if this is less than B, so I will have to go right, L is equal to mid plus 1. Else if A new index is greater than B, then I go to left, else I just found it. Else I will just return the new index. Okay, so there's one case that obviously it is not found anywhere. In that case, I can just return minus 1, right? Array will never be 0 size, right? So at least even one element will be there. So we are fine. I mean, like, had there been no element, probably we would have some back element here. Actually, no, we would have still worked fine. Let us test it. What is this smallest number index? Cool. I think this should be fine. Or am I missing anything? I think this should be fine, right? So first I found the pivot, then I changed everything to it. This should be fine. Cool. We got it. Okay, so what was the next question? The next question was painter partition problem using discrete binary search. Cool. So it says that we are given two integers a and b, okay, and an array of integers c of size n. Okay. The element ci represents the length of ith board. Okay, so basically we are given a fence kind of thing, and each element of c represents the height of what we say fence at that particular index. And so now we have to paint all n boards. Okay, so basically we are given a painters and they have to paint those boards, and each of them takes p unit of time to paint one board. Okay, calculate and return minimum time required to paint all boards under the constraint that any painter will only paint contiguous sections of board. Awesome. Okay. Okay, and two painters cannot. So I mean, like, there can't be that, okay, half part of one board is painted by one painter, whereas the other part is painted by the other painter. So that is not allowed. Okay, and only contiguous boards. Okay, so I mean, like, the very first painter will paint from left hand side to somewhere, and after that the second painter will take the job and the first painter will go home, something like that. But they will paint in parallel, and I have to return answer not this time. The first write mode, because these errors are very common. So actually, this kind of problem is very similar to, I mean, like, many other, I mean, like, problems of binary search where we have to find the answer. Okay, so suppose we have to find the answer. One way is to do brute force. Okay, and binary search allows us to do kind of intelligent brute force. What I mean by that is, let us say that, okay, can we assume if a particular answer is possible or not? I mean, like, suppose I say that, hey, you are given 10 minutes of time. Can a painters paint all the fences in 10 minutes of time when they go parallel? Okay, If they can, so probably they can do even in 9 minutes of time. If they can't, let us give them 11 minutes of time, something like that. So what I mean by that is like, okay, first of all, okay, so suppose I say that, okay, I will allow each painter to only take 20 minutes of time. Then I start painting from here. I see that, okay, painter one is painting it and still he has taken only 2 minutes of time. Then I go right and say that, okay, now he has taken 7 minutes of time. Then I go here and I find that he has taken 11 minutes of time. So this thing, C2 can't be painted by the painter one. From here, I will start giving to painter two. So for this kind of problem, I normally have one kind of approach. But approach is basically is that, okay, I have to binary search upon answer, right? So first I try to find that what is the minimum and maximum value possible of answer. Minimum is 0. I mean, like, will it be 0 actually? Can it be 0? No, at least, because there is at least one fence, so at least minimum value will be 1. So I can say left side of my binary search is going to be 1. What is the maximum value possible? Maximum value is possible of time when one painter paints everything, right? Yes, when one painter paints everything, and if one painter is painting everything, he will take B into sum of all these. Yes, he will take B into sum of all these. Yes, and the value of C is each CI is 10 to the power 6. So the whole sum can become 10 to the power 6. And how many C's are there? 10 to the power 5. So 10 to the power 11 and 10 to the power 6 is the value of B. So the maximum value can become something like 10 to the power 70, which will be a long end, by the way. So I will have to change this to long. Uh, Let me initially make it 0. So as I told that, okay, we will have to sum everything. So I will say for auto length of C, R plus equals to length. And then finally, I multiply it by B. So worst case, the value is going to be 10 to the power 17. So it will fit well in long. Okay. 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 So now I will try to find, okay, while L is less than equal to R, I will get a value of mid. Okay. So now I will try to find if A painters, if A painters can paint these boards such that each painter paints only contiguous boards and no painter takes more than B units of time, right? So I will say if possible to paint for A painters, right? Uh, okay, I will have to have the value of B as well. Okay, this array C such that no painter takes more than mid units of time. Okay, if it will be possible, if this is possible, then probably something lesser is also possible. So I will change R is equal to mid minus 1. Okay, but answer can be this also, right? So long int answer will be here as well. Long int answer initially, let me make it minus 1. So answer will be equal to mid, and if this is possible, okay. If it is not possible, then I will have to search more time. I mean, like, I will have to give them more time. So L will be equal to mid plus 1, and here I will return answer. Okay. Okay, no. I will have to return answer percentage more. Okay. But now the issue is how will I make this possible to paint function, right? So this will be something like possible to paint. It is given an array A and A. It is given, what is this A? This is number of painters, right? Okay, and what is this B? This is time per unit. And what is this C? C is the length. And what is mid? Time per painter. So this is a long end. Time per painter. Make it something like this. Okay. So now I will have to see that, okay, less than number of painters can paint. Okay. So I mean, like, let me say int painters used initially. Let me say that I've used only one painter. Okay. Auto length of fence length. I will try to assign that particular fence to the painter that is currently being used. So for that, I will need to know how much length, how much time he has already taken. So int current time used initially is 0. Okay. Okay. I will have try to assign that current time used plus equals to fence lengths. Okay, then okay, if I have assigned this, so there is possible that current time used becomes greater than that, right? If current time used becomes greater than this time per painter, then I will assign it to a new painter plus painters used. Okay, okay. If I have assigned change this, so I will change current time used to what is just what the current thing just assigned. So this thing length is an integer, right? Length is an integer and time per unit is an integer, but this can become long. So let me actually change this to a long it just to avoid these overflow errors. Current time use is theta. Okay, and here finally I will return that okay, if return painters used should be less than or equal to number of painters. But what happens, I mean like if only a single fence is I mean like a length of a fence is so big that okay it even can't be painted. I mean like okay, so I can just say that okay, if lengths into I mean like one fence is so long that even can't be painted, so it's greater than time per painter, then I directly know that it's not possible. Let me try to test it. This should work, right? Answer percentage. This should work. Hopefully it should work for full case as well. Cool, we got it. So what was the third question? The third is median of two sorted arrays, right? So median of two sorted arrays. Where's the question? Is this that question? The question was median of two sorted arrays, right? I think this should be the question. There are two sorted. So, yep, this is the question. So, we are told that we are given two sorted arrays A and B of size M and N respectively. Find the median of the two sorted arrays. Yeah. Okay, I mean, like if we had merged both those arrays and sorted them, just find the middle element of that array. Okay. But the overall runtime complexity should be log of M plus N. If we had merged it, then it would have taken M plus N time already. So I mean like we can't merge those arrays. So we don't have to merge the if we don't have to merge those arrays, but we have to find the median. Okay. Okay, for example, will the size of arrays be odd? No. If the number of elements in the array is even, so just go okay, just find the average of the middle two elements. Okay, cool. Okay, for example, if the array is 1, 2, 3, 4, 5, the median is 2 plus 3 divided by 2.0. I mean, like we will find the two mid elements and then we will divide their sum by 2. But if it was odd, so I mean, like this array would have come out to be, mm, this array would have come out to be something like this. So this would have formed something like 1, comma 2, comma 3, comma 4, comma 5. So middle would have been 3, right, directly. So we could have just written 3 in that case. Good. Okay, so now we have to do this without merging those. Okay. And we have to do probably using binary search. I do recall one way of it which was using divide and conquer, but then that is exactly not binary search. So we somehow have to use binary search to do this then, right? Because otherwise it would not have been in binary search section. Yep. So how will we do that? Uh, so suppose I had these two arrays. Let me say I have these two arrays. 1 comma 4 comma 5 and then I have another array 2 comma 3. Okay, so let us say that for now it is the odd, I mean like total number of elements is odd, so I have to find element that has equal number of smaller and bigger elements than it. So that, yep, so that will be our median. Okay, so here I see that that median is 3. Okay, so all those numbers, I mean, like all these numbers will be what we say, all these numbers will be small on the left side. So I mean, like all these numbers are on the left side, right? So from array A, this is the only number that is to the left side. From array B, both these numbers are to the left side. Okay. Acha, suppose if I know that only one number of array A is going to be left side, okay, and I also know that total 3 numbers are going to be on the left side. So I know that 2 numbers of array B are going to be on the left side. Yes. Okay, so for this array, only this will be on the left side, and for this array, all these. So the answer will come out to be max of these two. I mean, like it would have been suppose 3.5, then the answer would be this. Then the answer would be 3.5, right? Yes. Okay. So I have to find a partition in A after which all the elements of A will come to the right hand side. Okay. Okay. So I can binary search on the partition, right? Okay. Suppose I say that partition is going to be after 4. Suppose the partition is going to be after 4. That means 2 elements of A are going to be on the left, but total 3 elements are going to be on the left. So 1 element of B is going to be on the left. So this will be 2. And the other side will be 5 from this and 3 from this, right? Hmm. But we can see that, okay, from this 4 and 3, I mean, like 4 is actually greater than 3. So probably this is not the correct choice to make. I mean, like because one thing has something greater. I mean, like suppose we would have just returned end point max of these two, the answer would have been 4, but it really should have been 3, which is now on the right side though. Okay, so if okay, so suppose either if the ending number of this is greater than this or the ending number of this is greater than this, probably we have made a bad choice. Yes. So we should change the. Okay, suppose we made this choice, then definitely we would not want to make this choice at least, because this would even worsen the situation. So I would want something like this choice, and 4 and 5 go here, but 2 numbers will come here, and this choice, right? Yes, and this satisfies both these things. But yes, now this thing is empty, so I will have to take care of those edge cases somehow. How will we do that? Okay, so one thing is clear that, okay, we have to find the partition in the array A after before which all the numbers will come on the left hand side. Okay, so where can we make the partition? We can make the partition either here before 1, after 1, after 4, or after 5, right? So suppose the size of array A is 3, so then we can make 4 partitions. Okay, so let me actually first try to binary search on the partition. Int n equals to A dot size, int m equals to B dot size. Okay. Okay, the partition can be anywhere. So let me say the partition is 0 is the left side, or right side is n, right? Let me number this thing as 0. Suppose this is 0, this is partition 1, this is partition 2, and this is partition 3. So R will be equal to n, right? N is the size of array, which is 3. Okay. Okay. Okay, now first thing I have to find that how many elements will there be on the left side combined. Okay, for odd, suppose this the size of this was 3, the size of this was 2, then number of elements on left was 3, right? Which is equal to 3 plus 2 plus 1 by 2. Okay, at least for odd numbers this is correct. So let me actually say this, for even we'll check later. in total on left is going to be n plus m plus 1 divided by 2. Okay. And so now I am binary searching on after how many, on which partition of array A is my answer going to be, right? So while L is less than equal to R, mid is going to be L plus R minus L by 2. Okay. So suppose I get that, okay, my mid is 1. Okay. So that means that 1 is going to be on the left side of the sorted array. Okay. Acha, one thing for how many numbers of array B will on be left. So uh, B left count is going to be total on left minus mid. Yes. Okay. Okay. So I have found for mid. Okay. So okay, for odd we told that the number is, suppose we get this thing only, that number is going to be 1, max of 1 and 3, right? But how did we decide? We decided, okay, that if it was greater than that, right? Okay, so we will say int a partition left, I mean like the element in A just before the partition is equal to, suppose the partition was 1, then it was A0. Suppose the partition was 2, then it was A1. Suppose the partition was 3, it was A2. So it is going to be A mid minus 1. Okay. But what if partition was 0? But if partition was 0, let me actually take a very smaller number, which is like int min. Okay. So let me actually change it to minus 1. So if mid equals to 0, C is equal to uh, int min. Okay. Else this thing is going to be A mid minus 1, right? Okay. Okay. So now I know what is the number on the left of A. On just on the left of the partition of A, right? Okay. Okay, so that I know now. So then I will have to find the number on the left side of partition for B as well. Okay, and we know that B left count is going to be 0. So B was, let me take a bigger B. Currently B was 2, 3. So let me make the B as 2, 3, 5, 2, 3, 6, 8, 9. Suppose. Okay, so suppose the B left count was 0. That means the partition is here. Suppose it was 1, then it, I mean like the same thing is holding true, right? Okay, so I can say b if b left count will be equal to 0, then b partition left will be equal to minus 1. Int min b partition left is equal to minus 1 and equals to int min. Okay. Else this is going to be b of mid minus b of b left count minus 1 minus 1. Okay. I just need to check. I mean, like, if what if this index doesn't exist? I will just check that later. Exist. I mean, like, because for A at least this will exist because left and right are correct, but it might not exist for B, right? Or will it? We will see it later. Okay, so we know about B, and okay, so we can just now we just have to compare. Okay, to compare, we also need to know the right. Okay, we also need to know the right. Okay, so I will need to know A partition right as well, and I will need to know a B partition right as well. So if mid equals to 0, A partition left is int min and A partition right will be A0, right? A partition right will be equal to just something ahead than it, so it will be A0. So basically A mid only. Here A partition right is going to be A mid. But this mid won't exist if R is n. Okay, else if mid less than n. Okay. Then else I can say a partition left is going to be a mid minus 1. This will work, but this is going to be out of the array. So let me take it very large number. Let us say int max. This should work, correct? And so if I found this, then I'm done with the A side. Then I will have to do the same thing for right as well. So if B left count, okay, else if uh, B left count is less than M, right? M is the B dot size, then B partition left, okay, B partition right. Right is going to be P0. Here B partition right will be equal to B left count. Okay, and the issue comes now when it is equal to N. B partition left is going to be Pm minus 1 or B left count minus 1, which is same actually. And B partition right is going to be int max. Okay, so at least these things are correct. Just one thing is left. I'm like if this will exist or not. Okay, so now just we say these things. If A partition left is greater than what we say B partition right, then I'm like I will have to reduce the partition size of A. I'm like suppose this case 1 4 and only 2 will come here. So then I will have to reduce this. So 2 only 1. So I will say R is equal to mid minus 1. Else if A partition left is less than B partition right. Oh, actually that is going to be fine, right? Yep, that is going to be fine. So in that case, okay, A partition left. Okay, it might happen that now B partition left is greater than A partition right, right? B partition B partition left is greater than A partition right. In that case, if B partition left is greater than that case, I have to increase the scope of A. So that means L is equal to mid plus 1. Else I have just found. I mean, like else both the things are fine. So else I can just return max of A partition left and B partition left. Max of A partition left, comma B partition left. Yes, this should hold true. And I'm like sometime, at least at some place, I will just end up here. I can just say return minus. I'm like return something here. -1, which should not ever happen actually. So at least for odd numbers, total number of odd elements, I think we are fine. But will this index exist or not? Okay. Let us say uh, in this case, B was 2, 3, and our mid comes out to be 0. If our mid is 0, that means B partition left will be 3, and this won't exist. Okay. Okay. Okay, so but okay, suppose if the size of array B is smaller, if the size of array A is smaller, then this thing won't ever happen, right? Because B size is larger and this thing will always work. So I mean like say that if so I always want the size of A to be smaller, right? Otherwise this thing might happen. So if N is greater than M, I will just return what we say P comma A. This thing should work. So then this thing can happen, but I mean like now it won't happen because we are always saying that the size of array A is smaller. So that particular index will always exist in B. But what about even number of elements? Suppose I say that A has 1, B and 5 on left and B has 2, 4 and 6 on left, and A has on the right 7, 9 and 11, and B has on the right 8, 10 and 11. Okay. So what is our answer going to be? Our answer is going to be middle element, right? So the middle element will come out. Suppose if I sort this, this will come out to be 1, 3, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle element will be 1, 2, 3, 4, right? 5 and 6, right? Yes. 4 element 1, 2, 3, 4, 5, 6, 7, 8. I have missed 9. Okay, and here it is 12. So I have missed 12 as well. So the middle element will be 5 will be here. 5 will be here. So it is 6 and 7. Okay. 6 is the max of these two. Max of these two will go ahead, right? And 7 is the min of these two. Okay. So then I can just return max of A partition left comma B partition left plus min of B partition left plus B partition right by 2, right? Else I can have two cases. If n plus m percentage 2 equals to 0, that means the size is even. I will say return max of these two plus min of A partition right and B partition right divided by 2.0, right? Divided by 2.0. Yes, this should work. Return max of these two divided by 2.0, and in that case it will work. Yes. Okay, I don't think I have missed anything. Let me test it first. I expected this thing to happen. Naming partition, this is right, so this thing is wrong. Now this seems to be fine. Now this seems to be fine. Did I miss out a comment? Great. Okay. So I'm missing the cases when any of the arrays can be empty. Okay. If any of those arrays is empty, so then what will happen is that even mid won't exist, right? Even mid won't exist. Correct. Okay. So and if something is empty, that is okay. So one thing can be both are empty. Is it allowed? I'm like nothing is written. So one that can happen. So the very first thing is if n equals to 0 and m equals to 0, which means both are empty. So I just return 0 in that case. Then can happen only one is empty. And as we are checking that the size of array A is always less than size of array B, so then only thing can happen that if n equals to 0, so then I just have to return the middle element of B, right? So I can say that if m percentage 2 equals to 0, that means it is even. Otherwise, I have to just return b of m by 2, right? Let us say, suppose b was 0, 1, 2, 3, 4. So m will be 5 and m by 2 will be 2. So this will return correct. Else, I will, if m percentage 2 equal to 0, I will have to return b of m by 2. So which case this is 5. So m by 2 will become, and m is equal to 6. So m by 2 will become 3, which is this, and m by 2 minus 1 plus b of m by 2 minus 1, the whole thing divided by 2. This thing should work. I mean, like if both are empty, definitely we're indexing out of the bound. So this should work, at least for this case. Let us see. Let's try to submit it. Cool, we got it. And one bad attempt as well. Hi everyone. Let us start with today's 21 days of code. Today we were supposed to do strings, right? So strings. And people had asked us to do 3 questions which were justify text, zigzag string, and one more. Which was that? Valid IP addresses, correct? So today we will be solving these three questions: justify text, zigzag string, and valid IP addresses. These questions seem to be like string parsing only, okay, not related to string algorithms, but cool. So these questions normally, as far as my experience has been, that they tend to have a lot of edge cases. So normally it becomes difficult to get them correct in the very first attempt. But let us see. Okay, so we start with the first question: justify text. So we are given an array of words and a length L. Format the text such that each line has exactly L characters and is fully justified. Okay, now it covers the complete width. You should pack your words in a greedy approach, that is, pack as many words as you can in each line. So whatever comes in that line, you just put there. Pad extra spaces when necessary so that each line has exactly L characters. Okay. Extra spaces between words should be distributed as evenly as possible. Okay, so basically the difference between the spaces between words should be minimized. If the number of spaces on a line do not divide evenly between words, the empty slots on the left will be assigned more spaces than the slots on the right. Okay. So if each space between any two pair of words is not equal for a line, the words on the left will have more space between them rather than those on the right. Okay. For the last line of text, it should be left justified and no extra spaces inserted between the words. Okay. And we should return a list of strings where each string represents a single line. So for example, here each line should be of width 16. That is, there should be 16 characters in each line. 16 non-space characters. Oh, sorry, 16 total characters. So if we see that this is 4 plus, okay, one space should be minimum there between each words. So 4 plus 2, 6 plus 2, 8. And if this would have come, this would have got out of this line. So we can just put this is and an in this. Okay, so suppose the line width should be 16 and the size of these three words combined is 4 plus 2, 6 plus 2, 8. So there should be 8 spaces, which is 1, 2, 3, 4, 5. Sorry, 4 and 4. Okay, so as there are 8 spaces, so and there are 2 blocks of spaces, so each block has 4 spaces. Cool. And the last, what we say, last line should be left oriented. Okay. So what we get from, I mean, like what I get a basic understanding in these kind of questions where you have to do more of what we say, uh, it's more of like development rather than an algorithmic approach. So we should first iterate over the array and try to find which all words can go in the current line. So suppose initially the current line is 0. So, and the size can be maximum 16. So we start going from here, this 4 characters, then there should be a space, which is 5 characters, plus 2, 7, then a space, 8, plus 2, 10. But if this word would have been included, then it would have gone out of 16. So only these 3 words can be put. Okay. But how they can be put, we are not concerned about it as of now. So let us first try to create a logic where we understand that, okay, what are the words that are put in the current line. Okay. Okay. And then I will have a different function that uses those words and basically prettifies them. I mean, like then they should be center aligned more or less. Okay, so let me first store the size of the array. Okay, so I would need to know that what is the current length of words that has been included, so as to decide if the next word can be included or not. Okay, so int current length, initially it is 0, and I will also need to know that what is the starting point of the current window that I'm considering. So initially start is equal to 0. Okay. Then I iterate over those words. How will I decide if a particular word cannot be included? Okay. Okay, so if there are 3 words, then minimum 2 spaces should be there, right? So I can say that if current length plus current length is, let us say, storing the lengths of each of the words. So suppose when this is the array that I'm considering, the value of current length should be 4 plus 2, 6 plus 2, 8. So, and then number of spaces will be number of words minus 1. So I minus start plus 1 is the number of words. I minus start plus 1 is the number of words, and the spaces will be number of words minus 1. Plus plus the length of the current word, ai dot size. If it is greater than current length, that means this word cannot go in the current line. Okay, so then I will have to prettify the line. I will write the code of this later. Okay, else I will say current length plus equals to ai dot size. Okay, so if I know this thing, then I will do prettify here. But okay, then whenever we run such kind of loop where we do the real operation inside the loop, so then there is always a case that you have missed the very last window, the window that is at the end. So I can just do prettify the remaining array here, the remaining suffix of array here. Okay, and my answer should be a vector of string. So vector of string answer, and I will return the answer here. Makes sense. So now the only thing I think that is left is how to prettify. Okay, suppose I write the prettify function, which will obviously be given the words uh, and also the length per length of line length. Then I also need to know that what is the window for which I'm rectifying. So then I will need to know the start and end of it. Okay, so I know the words, and then I need to know. So here it is given that it is the last line, then it should be left justified. Otherwise, it should be central justified. But I can find that out from start and end only, right? Here I also missed one thing. My start should change to I, and yeah, current length should also change to 0. Makes sense. Okay. I think I can make decision based upon that. Okay, I also need to pass this answer variable so that I can modify it. So suppose I am also pass this answer. Right. Let me zoom it. Okay, so I have been passed this. Then how will I justify it? First, okay. Suppose I know how many words are there. N number of words will be equal to start, n minus start plus 1. Okay. If number of words are this, okay, I also need to pass the length of words so that I can know the number of spaces that should be there in that line. Length words. Okay, so int remaining spaces will be equal to line length minus length of words. Length words. Okay. Now I should distribute those spaces equally, right? If I should distribute those spaces equally, then what should be, okay, how many spaces are there? Number of spaces will be equal to number of words minus 1. Right, okay. So there will be a space before every word other than the very first word of that line. Just let me take care of the edge case. Okay, if somehow end is greater, if start is greater than end, then it's return. That should not ever happen. Okay. Okay, so now then these are number of spaces, then int space each space length should be equal to remaining spaces by number of spaces. Remaining spaces by number of spaces. Okay. But if number of spaces are 0, that will happen if there is only one word, right? If there is only one word, actually I should do what? If number of words is equal to 1, I have to avoid the division by 0 error. If number of words equals to 1, then the current line will be equal to only that current word, correct? Because that will be the last word. Yes. Current line is equal to words of start. It's only one word. And then I will push that into answer and then return. I can say answer dot pushback current line, and I should be done. Hopefully. Okay, so I have taken care of the edge case. So now this won't be division by 0. That thing I'm 100% sure about. So now I also need to know if that line is the last line, right? Because for last line I have to do left justification. This last line, I can say that it will be last line if end equals to words dot size minus 1. Okay. If is last line, then I will do something else. But let us take care of if it is not the last line. Okay, if it is not the last line, then I will start making the current line. String current line will be equal to for initially empty. Then for end I equals to start, I less than equal to end plus plus I. Okay, sorry, current line should have the first word left justified, right? The first word should be absolutely left justified. So let me actually put the first word there. Current line plus equals to first word. So word start. Now before putting any word, I first put the spaces before it. Okay, so and then I will have to put from start plus 1. For int j equals to 1, j less than equal to number of spaces plus plus j. I put a space here. Empty string. Okay. Let me actually also make the number. I just also reduce the number of spaces because I have created a space. Minus number of spaces. Okay. So now at least I have put j spaces, but it might happen that this is the first one, right? But then I mean, like it might need more. I mean, like more number of spaces than what comes on the right. So one more space will be needed. How will I know if one more space will be needed? And future spaces will be equal to how many future spaces will be there? They will be equal to the number of words that are left, right? Suppose I am putting currently current word 1. Suppose I'm currently putting this is word 2. Suppose I'm putting the word 2, then word 3 and word 4 are left. So the number of spaces will be the number of words that are left, and in future, yep, future spaces will be number of words that are left, which is equal to end minus I, right? Because suppose I is currently this, then end will be 0, 1, 2, 3 minus 1. Yes, end minus I, end minus I. Yes. So these many spaces are left. Okay. So if future spaces into number of spaces are not equal to what we say remaining spaces. So I think I should have minus minus remaining spaces, right? Sorry, future spaces into each space length is not equal to remaining spaces. It's not equal, then that means I will have to add an extra space here. So I will just do this thing. Okay, so I have done this thing. Then I will push the word. So current line plus equals to that particular word. Words I. This should work. So now my current line should be correct ideally. Yes, and it has told that I have to pad extra spaces. They won't be there even, right? They will be there in the last line, but not in any other line at least. Okay. So this thing should be fine. And right. So this should be fine, and then I will do what? If I know this and I know this, then I just have to put that line in the answer. Answer dot pushback current line, right? Answer dot pushback current line. I think I will need to put this here. Right, at least this will work perfectly fine for the case of, this should work perfectly fine for the case of not the last line. But what if it is the last line? If it is the last line, then I only need to have left justified. That means no extra space. So then I just have to put those words, right? So then I will say string current line. It will be empty thing. And then I will say for end I equals to start. Then I will actually put first thing here because I don't need a space before the first one. So the word start. And I equals to start plus 1. I less than equal to end plus I. I say current line plus equals to an extra space, and then current line plus equals to word size, and I am done. Answer dot pushback current line. Answer dot pushback current line. This should work. Okay. Then I also have to pad those extra spaces by empty so that each line should have exactly 7 characters. Okay, so let me actually have a function to pad. I will pad the string in place. String current line and line length. I will say file current line dot size is not equal to line length. Current line plus equals to an empty space. That should work. So then I will pad here current line, and then I will have the length, so line length, and the same thing I will have to do at 2 more places, which will be here. I think here only it will be needed because the final line should ideally be padded by itself, right? Hmm. And then I have to call the function rectify a b start end. Why it has to be passed a b, start is start and end is I minus 1, right? Because current word can't come there. Then I will need answer and length of words. Answer I have to create, but length of words is current. Okay, answer I have also created, so this is answer. That is it, and then I have to prettify, call prettify here as well. Here start will still be start, end will be n minus 1, and answer and current length should be correct, right? Seems fine. My pad function is correct, while it is not equal to line length, it is just increasing the length by 1. If start is greater than end, I don't need to do anything there. This can happen when only I think A is empty, right? Words is empty. Can words be empty? I'm not able to scroll down here. Let us take a case. Then if words is empty, that means if A dot empty or A zero dot size is equal to 0, right? That means there is an empty word. A zero dot size equal to 0. That means I don't have to return anything. My answer is that's it. Yes. If my answer is nothing, so return just answer. That's also. I don't think this case should be there. Hmm. I have distributed the spaces equally. Current line is an empty line, and current line plus equals to start. Then I think it should work. Let us test it. I might have some variable issues. Oh, it worked. Let's try to submit it. Hmm. So we are doing some error here. What must this code is not? My code is returning something weird. Why? Let's take this case only. What is happening? You just see this 25 function. If start is greater than end, I return. Okay, if number of words is equal to end minus start plus 1, right? Yes. If number of words is 1, then I just current line equals to word start, and then I pad the current line and push it to the answer, and I'm done. Which is also fine. Line length minus the number of spaces is equal to number of words minus 1, and then it is divided. His last line is also correct. Oh, why I have current line as this? Current line should be empty, right? Hmm. In fact, current line can be just word start. Then I can do for end I equals to start plus 1, I just will current line plus plus space and all, right? So then I just have to pad it and I'm done. This thing is also fine. Then I put number of spaces and I reduce the remaining spaces. This is not remaining spaces. This is actually remaining spaces. Yes, and future spaces will be end minus I. So if future spaces number of spaces that are there into what we say uh, length of each space, they should be fine. Then I current line push and then answer out push by current line. Okay. Here answer, this thing seems fine. If current length plus, here am I doing something wrong? Current length I'm setting to 0. Current length I'm increasing also. I minus start plus 1 is the window size, right? Okay, this is the window size. That is the number of words that are there, minus 1 because I don't have to insert space for 1, plus AI dot size. Yep, this also is fine. Greater than current length, then I just do that's not equal to I and current length equals to 0. I think this should be working fine. To see what the issue is. Interesting, yeah. What must be shall be, and B is 12, A, B start and minus 1. Line length start is 0 and is n minus 1. Answer is this and length of words. Start should be fine. Then I'm changing the start to I whenever I'm prettifying it. So I am somehow prettifying it early, right? And in each line I'm prettifying it. Interesting. Why am I doing that? What plus must? What is happening here? So n is n size, current length is 0, start is 0, okay? If a dot empty or a0 dot size equals to 0, this won't come ever. For I equals, then I iterate over each of those words, then the current length should be what is the current length. When I will be 0, so this will be 0 minus 0 plus 1 minus 1, which is 0 plus 0. This is perfectly fine. It's greater than not current length, but it should be greater than it should be greater than B. Okay, so this is a very random error. I should have first run it on test. Or did I run it on submit? What must be shall be seems fine. Am I outputting something somewhere? No, I am not. This seems fine, and but the length of this is 1, 2, 3, 4, 5, 6, 7, 8. Why is B coming on this one? This should not. Let us see on the test cases. I think the test case is weak. Okay, but this is wrong. I am somehow printing what must twice. I equals to start plus 1. I'm only putting the word start here in the current line. Current line is word start, current line is empty, and current line here also I can make it word start only. Okay, start plus 1, I less than equal to line, current line plus equals to this, and minus minus remaining spaces seems fine. This should not be an issue. I prettify it, then let me see whenever this function is called. Let me try to debug what is happening. I can say cout start and end. Let's see what is happening here. So this is correct. What and must should be in the first line and they are. Then 3 and 4 should be in the first line and they are. But the next time the function should also be called with what we say only 5 and 5, right? Only 5 and 5, but that was never called. My answer is a vector or string, and I am pushing this to answer. I equals to 0, I less than n plus plus I. I'm not calling this prettify ever. Interesting. Prettify was okay. It was called 0, 1, 2, and 3 and 4. It was called perfectly fine. And B shall be must be in one line. B E space S H E L L space B. 2 plus 1, 2, 3, 4, 5. 2 plus 5, 7 plus 3, 10 plus 2, 12. This should be perfectly fitting. So B shall be must be in one line. Okay, right. This should be, but why is it not? Anyone able to find that out? At must I get there and then I change this. I'm calling this perfectly fine. I'm calling it from 3 to 4, so that is not an issue. And I'm also changing my current length to 0. So this is also fine. Minus 1 and then I'm adding the line length, which is also fine. Hmm. What is this output even means? When I'm calling from 3 to 4, this should be the end line. Then I will say this is the words start, and my words will be this, and start will, okay, line length and then start, right? Oh, interesting. This should be words A, B, start, and minus 1 also. Hmm. A, B, start, and minus 1 answer and current line. That is fine. So this is also called perfectly fine. It should be called from here. Then this thing will go here. String current line is equal to words length because this is the last line, right? So then I will put everything from start to end here, and then I will put only one space between them, which is also fine. Then I will pad current line and this, and this should work. Let me try to see out what is that current line. If the function even came there or not. If it came, then I think it might be that this compiler is having some issues. Or should not. Current line is only shell B, so that is an issue. B is somehow going here, which it should not. So I am having some issues here. But this actually at least came here. So shell B is coming from the second line of output. First, what must came, and then what must be came. Has it ever happened that I'm not changing my stuff? Mhm. So I'm only returning from two places, either from here or from here. And if I put here current line, what is that going to come out to be? And here this thing is coming out to be what? Hmm. So twice current line came out to be what must. So I'm not returning. Correct. So here I pushed out of answer, but I somehow didn't return. So in the case of 0 to 2, I actually made current line what must, and then I made line current line what must be. This should not happen. If it is last line, then I pushed back to answer, and I put current line. Let me say it is 1, and then this is current line 2. What is happening here today? This somehow came into this twice. Interesting. Hmm. It came here twice somehow. How? Okay, got it. This should be here. I should put it out of the for loop, and then it should work fine, right? I had this thing inside the for loop. And then I have only what must be and then only shall be. Which is also technically though wrong, but it is correct. 4 plus 5 plus 4, 9 plus 10 plus 11, 12. So what must be will come here and then shall be will come here. This is perfectly fine. So now we got this. Told it was a very bad error. Yes, I think let us just test with custom input and now we should be fine. Yep, seems fine. So what I did was I put this thing inside the for loop. Amazing. Okay, let us see if it works. This is working, but what is happening now? It is putting more than one space here. What am I doing? Point j equals to 1. Before each word, I put a space, and I'm putting only one space, right? Yes, I'm putting only one space. If future spaces into each space length is not equal to remaining spaces, then I push another space here and then I reduce this line. Okay, what is remaining spaces? Remaining spaces is the number of spaces that are there in this word, and this will be number of spaces into each space length. If future spaces will be n minus I, so all those words between current words. Yes. So if I is this and end is this, so 0, 1, 2, 3. So 3 minus 1, which will be 2, and 2 empty spaces will be there. And so it should not actually put this thing here. Here we are putting 3 spaces, 1, 2, 3, and then here we are putting 2, 3 spaces somehow. Okay, so the line length is 4 plus 4, 8 plus 2, 10, and the number of spaces should be 1. So each should be 1, right? So here current length will be 0, and number of spaces will come out to be, in this case, number of words minus 1, which will be 3, which will be 2. So number of spaces will be 2, and this will be 2. So this should be 2, this should be 2. Each space length should be 1. I think we are fine, and this will never happen, but it is happening. Somehow my each space length is coming out to be 3. It's coming out to be each space length. Let us see why is this happening. I should use shorter variable names next time. Each space length is 1, but I'm still somehow putting more than one spaces there. For j equals to 1, j less than equal to number of spaces, which is 1 plus j. I reduce the remaining spaces to 1, and then this is fine. The future spaces will come out to be, future words will come out to be 1. Then I would not ever execute this. Why is this even happening? Each space length is coming out to be more than this, right? In the word what must be, where each space length is 1. So between each word, I will put a space of number of spaces, right? Each space length. I should use better variable names the next time, and then this is fine. Interesting, got it. How many points will we still get from this? We're getting one exam, which is fine. Hopefully we get it. Cool, we got it. All the variable names issues. So let us do the next question that was for the day. That was zigzag string, right? Interesting. So we're given a string, PayPal is hiring. It is written in a zigzag pattern that P, then A, then Y, then P, then A, then L, I, S, H. Okay, so it's written like this. And then we are reading each row line by line. Okay, write the code that will take a string and make this conversion. Okay. Okay, so for A, B, C, D, if there are two rows, then first A will come in the first row, then B will come in the second row, then C will go above one. Okay. Okay. So whenever it happens that whenever a question comes that okay, your direction is changing. So what I normally do is I create a pointer. Okay, when is the direction changing? The direction will ever change only if the current row is 0 or if current row is n. Okay, if the current row is 0, the next row is always going to be +1. So the next direction increment will be +1. If the current row is n minus 1, then the direction pointer will be -1, so that the next row is reduced. Okay, so let me just say that. So what is the base case here? If A is empty, then I can just say that if A is empty, my answer will be nothing. I just have to return a string, so return an empty string. Then how many rows are there? The number of rows are equal to B, right? Okay, so let me actually create a vector, create a string vector where each row will be storing what is the string there, other than zeros. I mean, like it will only store the characters. So the 0th index will store P, A, H, N. The first index will store A, P, L, S, I, I, G, and so on. So the vector length should be of vector of string, and it should have a length of, which is answer, and it should have a length of P. Then I will have to iterate over this string. Then I will say for I equals to 0, I less than n plus plus I. Now I have to find that what is the current row in which that particular character should go. Initially, current row will be 0, right? And then as I told that, okay, I will maintain a direction that, hey, I mean, like if I come at 0, now I have to go down. So the next row will be +1 as it will be -1. So I will say current direction. Initially, I can make it 1. Okay. So if I know the current row and I know the current direction. Okay. So first of all, I have to put the current word in the yes, right? So first I will say that answer current row plus equals to AI. Then I will say if current row equals to 0, then current direction will be equal to +1. Else if current row equals to n minus 1, so then I have to go reverse. So my current direction will change to -1. Okay. Then I will change my current row for the next iteration to plus equals to basically current direction. But what happens if 0 is equal to n minus 1? If there is only, I mean, if value of b is 1, that will happen in only that case, right? If value of b is 1, I mean, like then there is only one row, then there is no sense of zigzag, so I can just return a, right? Now this condition won't ever happen that current row is also 0 as well as it is n minus 1. Yes, correct. So now I will have to create my string final answer. Then for each row in what we say answer, final answer plus equals to row, and I should return final answer because I have to return string. This should be fine, right? If A is empty, then I'm putting that. I'm using extra space to store what will go in that particular row. So let me test it. No, I have a runtime error. If A is empty, I return empty thing, so I don't return anything. If B is equal to 1, then also I'm fine. If B is equal to 1, then I'm fine. Will it happen that B is 0? No, it won't happen. If current row is equal to n minus 1, current row is equal to B minus 1. Because B is the, what we say, changing. Today I'm doing very bad with variable names. Cool, this seems fine. Then let us submit it. Cool, we got 298. So we did this much better, but still failed with variable names a bit. Let us actually move to the last question for the day, which is the valid IP addresses, right? So we are told that we are given a string containing only digits, okay? Restore it by returning all possible valid IP addresses. That is combination, okay? A valid IP address must be in the form of a.b. So as we know that all IP addresses can be from points 0.0.0.0 to 255.255.255.255. So yep, the number cannot be zero prefix unless, okay. So I mean, like, we are not allowed to have 011 dot something. Okay. And we also have to make sure that the return strings are sorted in order. Okay. Sure. Okay. I mean, like, even if the current number is smaller, I think it should be able to make it. Okay, so one thing is clear that, okay, each of those, I mean, like, the partition that comes before each dot can be of maximum 3 length, right? Before each full stop, the partition is of maximum 3 length. So I can, and suppose for a string like this, for each string, so as to say, for each string, I will have 3 partitions, right? First partition of the very first dot, the second of second, and the third of third. So I can say for int I equals to 0, I mean, like, after which index. Okay, so I can also actually change it like what should be the length of the first part of this. So it can be 1, 2, 3. Okay, so for int, the first length can be first length equals to 1, and it can be maximum 3, right? Okay. Similarly, the second length can also be this equals to 1 and less than equal to 3 plus plus second length. Similarly for the third length. Equal to 3 plus plus third length. Okay. Fourth length is basically the whole remaining part of the array. Okay, so I mean, like, the total size of this string can be worst case 12 because 3 into 4 is 12, and at minimum it should be 4. So I can say one more thing as well, that n equals to a dot size. If n is less than 4 or n is greater than 12, that means I can't return anything. I just return empty answer. Suppose this is the answer, then in that case, it's nothing is possible. So I can just return this answer. Okay, and okay, so now I know what each of these strings are. Okay, I also will need to see if the current string is valid. I mean, right? Because there is a case at first it should be 0 to 255. Then the second case says it should be, I mean, like if the first digit is 0, then it should only be 0, nothing else, unless they are 0, right? So let me actually make a bool is valid number, is valid part. It will be given a string, which is the part, and I will say, so when is this valid? First, if part 0 is equal to 0, if part 0 is equal to 0 and part dot size is greater than 1, that means it's something 0 plus something, so that means it's definitely not valid. Else, it will be valid only if string to integer of part is less than equal to 255, right? Yes. It is valid part if string to integer part will be equal to 255. I don't think I have to do greater than 0 because all are digits. Yes, so I think this will be valid in this case. If it is 0, then it works. If it is other things, then it will also work. And in S2I by default base is 10, so we are fine. And so then I will say, okay, 3 and the first partition should also be less than n, right? And first length should be less than or equal to n, because obviously if the length is greater than n, that then it won't work. Then string first part will be equal to a dot substring from 0 of length first length. Okay. If is valid part first part, then only I will go further here. Correct? Yeah. Okay, then similarly I will have to do this thing, and first length plus second length should be less than or equal to n. Yes. Then second part will be equal to a dot substring from the index first length of size second length. Then I will have same thing if is valid part if is valid part second part, then only I will go here. Okay, interesting. Then similarly I will have to do here, and first length plus second length plus third length will actually be less than n. Why? Because there is something that also has to come after this, because a fourth part should also come, so I can actually have less than n as well. Will improve the worst case only. Plus plus string length, and I will say string third part is equal to a dot substring first length plus second length, and it should be of size third length. Then I will have fourth. Let us actually put the fourth part as well. The fourth part will be equal to a dot substring from first length plus second length plus third length, and of size n minus whatever has happened. I think this will also work. This is the same thing. If we don't put anything here, this is going to be till n. Then I will say if is valid part third part and is valid part fourth part, then I have something as my answer. Then I can say answer dot pushback first part plus second part plus third part, and I can say fourth part. Okay, and that's it, and I can finally return my answer. Am I returning it? Yes. I hope this time my variable names are good. Part is here, part dot size is greater than 1. This is fine. S2I part should be less than equal to 255. That should also be fine. This should work. N is equal to a dot size. I'm never assessing anything outside the array, so this should be fine. Wait, right? Yes. Let's just test it. I hope I don't have any bad system. Return false. That's it. If part is and part is size, and then uh, I can return list. In this case, what I have done is that my answer is correct. 0.10. Here, my string is starting from 0.10.0.100. Why is this not the answer? Okay, my string is returning 0.100.10.0, which is fine. So this is returning. Then my string is returning 100.100. This should not be returned. 100.10.0.100. Yes, it should not happen. So one thing is coming correct, but one thing is not coming correct. Why is it not coming correct? It is not coming correct because my third part is 0, so this is this. But somehow my first part is still 100, right? 100.10.0. Oh my god. My first length is 1, first length less than equal to 3, and first length should also be less than n. First, I get the first part, which is fine. But somehow, when the length of the first part is 3, then I'm returning 100. It should not be happening, or it can happen. It should not happen. If part 0 equals to 0 and part dot size is greater than 1, because part 0 will be equal to 0 and part dot size will be greater than 1. So this thing will actually return false. So 0, 1, 0 won't ever come, right? And listen, what am I doing today? And first part will be so this, then is valid part first part. It will say the first part is coming out to be in this case it is coming out to be 100. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7. This can't even happen. Like, how is it even happening? 100.0.10. Somehow it is having 10 already with it. How? If n is less than 4 and n is greater than 12, I can just return empty. The first part is a dot substring of 0 from this thing, right? Yes. Then I'm always returning first part plus second part. Okay, so the issue is my first part is equal to the fourth part, so this should be FO part. So today I messed up with variable names badly. This is fourth part and this should be fourth part. Then I am correct. Right? Then I'm absolutely correct. Yes. Cool. And let's submit it. Cool. We got 241 points today, and the streak is completed, hopefully. Yep, we got 726 points today and 5 point streaks. Any questions, anyone? I have some moments we can answer those. Today, the only thing that I think that I messed up badly was variable names. Has been a long time since I practiced without code editor. So someone has asked, what is the time complexity of your code? Which code are you talking about? Let me just see. So the question that I had on what we say justified text, the time complexity will be something about I am processing each word once, and I'm not processing each word more than once. So the time complexity should come out to be order of n only. N is where n will be equal to the to the total size of all the words combined plus number of spaces. So that will be the time complexity, right? Because if I have processed anything, I'm not processing that particular part of the array A again. So I'm only processing a particular part of array A again, and to process that part, I need order of n. So I think I know why people are asking this question. This question might be asked because of this plus equals to thing. In C++, this is not going to make it order of n square, as far as I know. Okay, so you are asking the complexity of last question, valid IP address. Okay. This actually technically will be order of 1 only. Why? Because this is only going to a loop of size 3. So I'm processing all the strings of length 3. So it is 3 to the power 4 time complexity only. Order of 3 to the power 4. Yep. So your question was the last valid IP address, right? So here I'm processing this string, the very first 3 characters only once, but then, sorry, I actually can process this again. So this thing, let us say that is 3. It's order of 1 technically, but let us say that is 3 steps. Then this is also 3 steps. His valid part is also order of 3. So it's actually constant time, to be honest. This substring can, in worst case, this 3 can be n by 3. So let us say that each is n by 3. So then also this will be order of n and then order of n. This is technically constant. This is technically constant time only, because I always know that yes, this is technically order of 1 only, because I'm only processing strings of size 3, so I already know what the constants are. So yeah. Alok has asked, can you explain the zigzag algo once again? Sure. Zigzag string, right? Okay, so basically zigzag string question, in this question we had to actually know somehow that what are the characters that are going in a particular row. So what I basically did was I created a vector of strings of size that equal to number of rows. Okay, then I processed each character of this string from left to right, and then I try to find in which row should it go. How will I decide which row should it go? See, initially the first character that should go will be to the 0th index. Okay, now when we are at the 0th index, consider it in this way that, okay, suppose you are going on a mountain, so you are going, when you are at 0th index, so you are at the top of the mountain, the next thing should be +1 of what was previous. Okay, so current direction is storing what should be the increment of the next row from the previous row. Okay, so then from 0 it will become +1, then 2, then 3. Suppose there are only 3 rows. Okay, like in this case there are only 3 rows. So when the value of n will become 2, the next row should be 1 minus, I mean, like the current row minus 1. So what I basically do is I change the current direction to -1. This trick is actually also usable in the matrix, what we say, in the matrix questions as well, where at the edge, you change the current direction to a direction that takes you down in the matrix. So this is the similar logic. Okay. Akshat has asked, when will you discuss the questions asked in the scalar entity test? We will discuss it tomorrow. Okay. The one that was asked in the test yesterday, right? So we will discuss that tomorrow. Okay, cool. Any other doubts, or can we end? So today is the day 6 of the 21 days of code thing. So today, as we had discussed, that we will be starting with bit manipulation, and we will be covering 3 questions that you guys had requested. Let me just go over LinkedIn and see what are the 3 questions. One is reverse bits, the other one is single number 2, and the other one is minimum XOR value if done with try. Okay, I actually try is too much for, I mean, like what we say, that minimum XOR value question. And also someone had commented on YouTube that maximum XOR pair, right? Maximum XOR pair is also, there is a better way to do that. Let us see what numbers we will do today. So today we will be doing single number 2, reverse bits, and minimum XOR value. Okay, cool. Let us start with single number 2. So we are given an array of integers where every element appears thrice except for one which occurs once. Okay, find that element which does not appear thrice. Okay, the algorithm should have a linear time complexity, and we have to implement it without extra memory. Okay, every element appears thrice except for one which, so basically we are given an array of integers where each element is 3 times, but one element comes only one time. Okay, so let us say that, okay, the given array was 1 2 4 3 3 2 2 3 1 1. Okay, let us take this array only. Okay, so this array has only number 4 that appears one time. Okay, okay. So normally when something like this comes in a question, and it's a bit manipulation type of question, so we have to think in terms of a bit, right? If a number is coming thrice, what is the property of that number that will also come thrice? Uh, Basically, each set bit will also come thrice, right? For example, 1 is 001, 2 is 010. Uh, is there number 3 here as well? Yes, 3 is also here, 011, and 4 is also there. So 4 is 100. Okay. So now let us say that, okay, as the number 1 is coming 3 times, so basically this 0th bit will be set 3 times, right? So if we think in terms of each bit, we see that if a number is coming 3 times, then each of its set bit will also come multiple of 3 times. So if we say in this array, the 1 bit will be set by this number, by, I mean, like the 0th bit will be set by 1, by 3 as well. Uh, that's it. So basically, the 0th bit will be set. 0th bit will be set how many times? 6 times. Uh, 3 times by 1 and 3 times by 3. Great. Okay. Now, if we think of first bit, if we think of first bit is set in only number 2 and only number 3. Okay, so uh, as 2 is coming 3 times, also 3 is coming 3 times, so this bit will also be set 6 times, because 2 is setting it 3 times by 2 and 3 times by 3. Okay, but if we think of second bit, the second bit will be set by number 4 only. Okay, and as number 4 is only one time, so it will be only set one time, by only one time by 4. Okay, so what we see is that for those bits that are set not multiple of 3 times, for those bits that are set not multiple of 3 times, those bits are set in the number that appeared once, right? Because there is only one number that appeared once. And as all are integers, so basically the number of bits can be worst case 32. So it will be int bit count. Let us say bit count is of 32. Initially, let me set this bit count to 0. Actually, do I even need to store that bit count? Let me travel in terms of bit, right? Let me say that for int bit equals to 0, bit less than 31 plus bit, I will check in how many numbers is that bit set. Count set is equal to 0 for auto numbers in the array A. If that bit is set in the number, if numbers shifted by bit, if numbers shifted by bit and 1, shifted by bit and 1, that means that bit is set in that particular number. I will say plus count set. Okay. If at the end of this count set is a multiple of 3, okay, that means this bit was not set in the number that came once. So if count set percentage 3 equals to 0, that means this number is a multiple of 3. Then I don't have to do anything. If it is not equal to 0, that means this bit was set in the number that appeared only once. So let us say answer is equal to 0. I have to set this bit in the answer. So answer or equals to 1 to the uh, bit, right? Yes or not. I'm talking about 0th bit. 1 shifted by 0 will be equal to 0. Yes, 1. If the 0th bit is set, this will be set in by 0 and return answer. I think this should be it. Hopefully. Yep. The maximum number will be 5 lakh, right? 1, 2, 3. So yes, within 30 bits it should come. So this answer should be fine. Cool. We got it. So I mean, like those who didn't understand the approach was basically that, hey, for the number that is going to come 3 times, it is also going to increment the count of the bit. I mean, like how many times that particular bit was set. For those bits that was set in that number, those bits will be set multiple of 3 times, right? And if there is only one number that came once and all the other numbers came 3 times, so those bits that are not divisible by 3 are the set bits of the number that came once, and that's it, right? I hope it made sense. This was an easy question. And here the space complexity is order of 1, and the time complexity is order of number of bits into n. So basically it's order of 31 into n, which we can say to be order of n as well. But ideally it is actually order of log of maximum number, to be exact. Okay, so what was the next question that people had asked? The next question was so there's different bits some pairwise as well. There's different bits some pairwise as well, and reverse bits, right? Cool. So first of all, let us do different bits some pairwise. Okay. I think today we will take one more question because today the questions seem to be easy. Different bits some pairwise. Okay. We define a function f that takes two numbers. Okay. Okay, as number of different corresponding bits in binary. Okay. Okay. A function f takes two numbers and returns the number of bits that are different, number of corresponding bits that are different in those numbers. For example, if a particular number is 010 and the other number is 111, as 0 is here but 1 is here, so this is one difference. 1 is here, 1 is here, so this is not a difference. 0 is here and 1 is here, so this has two differences. Okay. So you are given an array of n positive integers, and we have to find the sum of all fi comma fj for all pairs I comma j. such that 1 is less than equal to I. I mean, like for all the pairs I comma j, even j can be lesser than I. I have to find the sum of this particular function. By the way, those who don't know what this particular function is, there is one interesting property as well about this function. This is known as Hamming distance of two numbers. Hamming distance of two numbers is known as the number of bits that are different in those two numbers. For those who don't know this thing, okay. Cool. Okay. So now we have to find what is the sum. Okay. What is the difference? Okay. So we are given an array. So a brute force solution will be an order of n square 1, where we take each number, where we take every pair of number and compute the value of this particular function for that pair. But as there can be n square numbers, so the time complexity will come out to be order of n square. So that is a brute force. Let us try to optimize over that. Okay. Here also, can I think about in terms of each bit? Okay, in this case also, the number of bits are not going to be more than 32, right? Because each of numbers is an integer. Okay. What I also see is that the value that is getting to answer is dependent upon what are the conditions at that particular index. For example, suppose let us take this case 1 comma 3 comma 5. Okay, let us take this case a is equal to 1 comma 3 comma 5. So here a is going to be 0 0 1, b sorry one number is going to be 0 0 1. Let us say the other number b is going to be 0 1 1, which is 3, and the third number c is 5, which is 1 0 1. Okay, so what we see from here is that, see, this zeroth bit is same in all the numbers. So I mean, like, zeroth bit is going to add nothing to my answer because zeroth bit is same in all the numbers. Okay. But if we see this first bit is 0 in two numbers, that is 1 and 5, and first bit is 1 in only one number, that is 3. Okay, so this is going to add to answer twice. Once when B and A is the pair, because this bit is set in one of those and unset in the other, and also once B and C are a pair. So this will add only when B comma A, also when B comma C. Also, I mean, like, as there is no distinction between those two things, I mean, like, A comma B can be in both sides, so there will also be A comma B and C comma B. So this will be 4. Okay. So basically, this will be equal to uh, number of numbers in which it is set multiplied by number of numbers in which it is not set, because that is how you will make a pair, because these are the numbers in which that particular bit is set. These are the numbers in which that particular bit is not set. So these will be the total number of pairs. But as the order matters, so then the answer will be twice of this. Okay. I think we can do this as well as in order of n, right? And order of one space. Similarly to the last question, so then we can have let us say numbers is equal to a dot size. So we have n numbers. Then we will say for n bit equals to 0 to bit less than 32. Let's say 31, because 31 should also work fine, mostly. Plus bit. So we will check in how many numbers was that particular bit set. Count set equals to 0. For auto numbers out of A, we will check if that particular bit is set in this number. How will we check? We'll check if numbers to the bit and 1, that means this is set. I will say plus count set. Okay. Then count of unset will be equals to n minus count of set. Okay. What can be the maximum value of count set? The maximum value of count set can be of order of total number of numbers, and that is not given how many numbers are there. So let us actually take them as long int, right? Int answer is equal to 0, const int mod equals to 1 in 9 plus 7, because we have to return the answer percentage mode. Then I will say long int current count. Current count is going to be count of set into count of unset into 2. So as to avoid overflow, let me change one of these to a long. Count set into count of unset into 2. Right, so this will be long. This can be an int, but this thing will not overflow. I will then take a mod of it. Current count percentage equals to mod. Then I will add this to answer. Answer plus equals to current count, and then I will take a mod of answer as well. And then I can return the answer. Should work because I'm taking the pairwise thing, right? Yes. Cool. I think this worked fine. Let us try to submit it as well. There should not be any overflow errors because I'm taking mode religiously. So hopefully it should be correct. Cool. We got 297 out of 300 points. So come in as well. What is one more question that you want us to solve today? Let me see what was the other question that people asked. Do you guys want any other? I mean, like those who are watching live, any question that you have that you want us to solve? Okay. Uh, Let us do the reverse bits question, okay? Because that is asked in a lot of companies according to our LinkedIn comment. So let us do reverse bits. Okay. In reverse bits, we are given a unsigned integer. Okay, unsigned integer basically means that the last bit will not represent the sign, but it will represent something. I mean, like it will multiply the answer by 2. So the numbers will always be positive, and the last bit, instead of representing the sign, is representing a value. That is what an unsigned means, and more or less. Okay, so we are given first and only argument of input contains an integer a. Okay, so we are only given an a, and we have to reverse those bits. Okay, so this output format is wrong, I think. Return a single unsigned integer denoting minimum XOR value. I don't know what this means. This is probably related to something else. So okay, so they are going to be 0 to 31 bits, right? So I can say I can have the left bit as 0 and I can have right bit as, sorry, left should be ulta asli mein, left should be 31st bit and right should be 0th bit. I will say while left is lesser than right, while left is lesser than right, while left is lesser than right, and finally I will have to increment left and decrement right. Okay, if left is less than right, then I need to check what is the bit set at left, is the left bit set, and is the right bit set. Okay, so I can say is left set, this is equal to a shifted by left and 1, right? Then tool is right set, this will be equal to a shifted by right and 1. Okay, if both are set or both are unset. If both are set or both are unset, then we don't need to do any swap. But if both are set and both are unset, that means the XOR of them will be 0, right? So that means if the XOR of is left set and is right set is 1, that means both the bits are different. Then only we need to do something. So I will say if is left set XOR is right set. This particular thing means that is left set and is right set are not equal, because if they both were equal, then the XOR would be 0. Okay. So okay, if they are not equal, then I have to swap those bits. Okay. Okay. I have to basically reverse those bits, right? And suppose I say if I XOR something with 1, so 0 XOR 1 is 1 and 1 XOR 1 is 0. So basically XORing with 1 reverses the bit. So I will say uh, A XOR equals to 1 to the left and A XOR equals to 1 to the right. So basically this will reverse those bits, and they need to be reversed because both are different. And here I don't need to return. I think I can return A. I think this should be correct. My function returned 3, but it should have returned 3 to 2. Why did this happen? Why left is less than right? Okay. I have left as 31. Okay. Sorry. I have to do ulta. Minus minus left and plus plus right. Then I have to test, because left is coming here. So this is 31, 30, 30, 30, 29 and so on. What is happening? Why left is less than right? This won't ever be true, right? Why left is greater than right? I am using opposite. Cool. And I think this should work. I think there can be one edge case here. I'm not really sure if that might be there or not. That will be there or not. Okay, it is correct. What I doubted was, suppose this right was 31, then the bit 1 will go to 31st index, but 1 is a signed number, but it worked. Okay, so because it is a bit, then it will work. Okay. And it is always going to be a positive. Cool. Okay, great. So we have solved how many questions till now? Today we have solved uh, 3 questions, I think. Let us solve one more question because we have ample time today. Okay, let us vote for the question that people want in YouTube comments. So let us solve this minimum XOR value, I think, right? Because that is the only question that I see that some people are asking. Shivansh has asked maximum subset XOR. Is that on interview bit? Because I don't see that here. Or if it is, we will take it at the end. I mean, like, let us say during the end of the series, we will open it for any topic question, and then you can probably ask that, because I don't see this question there. Otherwise, I would have taken it up. Okay. Vipul is asking, what is the time and space complexity? What is the time and space complexity for this challenge? Hopefully, you meant number of 1 bits, right? The number of 1 bits is order of 1. Oh, sorry, not this. I think you asked reverse bits. Did you ask about reverse bits? The complexity of that is order of 1, because this thing is only going for 32, because I'm like not even 32, this will go only for 15 iterations, 31 by 2, so it will be order of 1. That's a constant. Hope that's clear, right? Let us do one more question and then we will end it up. let us do the minimum XOR value question, right? Actually, this question requires one knowledge. That is why I didn't want to pick it up. I know the solution for that, but I will try to prove that knowledge to you. I mean, like, what is the trick that this question requires? Okay, let's take this up to, and I will I will explain you that how this is solved, and then try to explain you the reasoning behind that. Why is that true? Okay. Sure. So basically, this question says that we are given an array of integers of n integers. We have to find the pair of integers in the array which have the minimum XOR value. Okay. So basically, you are given an array. You can choose any two numbers of the array, and the XOR value of them should be minimum between all the pairs of the numbers. Okay, all the pairs of the numbers in this thing. Okay. So let me actually first tell you how this is solvable, and then I will prove it that why that is true, because the proof is very interesting for this particular question. Okay, this is solvable indirectly this way. Uh, okay, and that's it. There is a try solution of this as well, but we are not covering try today, so we won't be taking this up. But we will come to this later. What happened to this question? Specify answer the correct meaning of answer, comma AIX or AI minus 1, right? Is that not this question? Find the pair of the integers in the array which have the minimum XOR value. Report the minimum XOR value. So the minimum XOR is going to be this is actually true. I mean, like, this thing should be true, right or not? Okay, let me think over this question again. We are saying that we given an integer array A of n integers, and we have to find the pair of integers in the array which have the minimum XOR value. Okay, and we have to report the minimum XOR value. Okay. Okay. For this case of 15, 5. Okay, the array is not sorted. Okay, so first I have to sort the array. Sort A dot begin, comma A dot end. If the array is sorted, I claim that the minimum answer is going to be the minimum amongst all the consecutive pairs. That is what I claim. I will prove this claim after this, but this is what I claim, and let me show it to you that this claim is actually correct. And then we will go on proving this, okay? How many of you guys did actually know about this thing earlier? That, hey, this is a claim that is true. Is there anyone who knew about this thing earlier? Yep, we got 200 out of 200 points. I just wanted to get an idea. I mean, like, how many of you knew this thing? No one. Okay, cool. Let me actually tell you why this trick is actually true. Because I mean, like, how I know this is because I had solved this question a long time ago, and this requires a lot of observations and practice, obviously, that how you are able to get this technique. But let me actually show you why this is true. Okay. Vipul has one question. Vipul, yeah, please uh, put that in the comment and let me take that up. Then I will go on proving this. Can you send me your question so that after that I can move on to the proof? Yes, please put in the comments. Let me actually first then prove it, because I think you will take some time to get to put the question in the comment. Then I will take that at the end. Okay. Okay. So what what I claim is that, hey, if the array A is sorted, my answer is going to be the minimum of XOR between two consecutive elements. Okay. Yes, Vipul, we can use try to solve this thing as well. Okay. So your question was, can we use another way to solve this problem? Yes, we can use try to solve this problem, but that is too complex. But yes, that doesn't require this observation. Okay, but we will take that in some other, probably at the end of the course. Okay, cool. So how I say this is true is actually this. Let us say that we have consecutive numbers. What kind of consecutive numbers can be there? So consecutive numbers can be of two types. Like let us say that we are talking about 4, 5, and 6. Okay. For minimum of XOR, what will be the bits? I'm like bits should be aligned to the right or to the left. I'm like different bits should be to the left or different bits should be to the right for the XOR to be minimum. Suppose there is one number this 100001001. There is another number 0 and something whatever comes here. Let us say 0010. Okay, and there is another number that is 1. Okay, can you tell me anything about I mean like which of those numbers can have probably the least what we say XOR value? Definitely, because at very left of these two numbers, basically the very first two numbers, if we talk about these two numbers are different at very left, right? And the more left they are different, that means they are going to add a lot more value to the answer. So the very first thing that we would like will be that the numbers are different as much to the right as possible, not to the left. Because if those numbers are different to the left, they're going to add a lot of value to the answer, and that is definitely a bad thing for us. Okay. Okay. So now let us say, so that means we know that okay, this thing is not possible. I mean, like if we have the numbers sorted, they can be in this order only, right? uh, because I mean like if this bit is 0, this bit is 1, so definitely this number should be greater than the above number. Okay, okay. Now let us try to actually make a claim. My claim is that if there are three numbers A, B, and C such that A is less than B is less than C, answer is either what I say A XOR B or uh, A or B XOR C, but never A XOR C. Okay, that is what I will prove. If I'm able to prove that, that definitely that directly justifies that if there is a minimum answer, that is between two consecutive numbers. Okay. Now let us try to prove this. How will you prove that? Okay. Acha. Suppose we are coming from the left. Okay, and we say that ith is the first bit that is different from right. From right, by from right means 31 to 0th bit. Okay, if I say ith is the first bit that is different from right in A comma B comma C. Okay, so what is the possibility of that? The possibility of that is that AI is 0, BI is 1, and CI is 1. Or the other possibility is AI is 0, BI is 0, and CI is 1. Correct? Why? Because A is less than B. A is less than B. If A has to be less than B, then definitely AI can't be 1, right? Because then A will be greater than B. Okay. 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 So if we know this thing, now what do you think will be the minimum XOR? Can minimum XOR be A and B? A XOR B? I mean, like, let us say that this is the case 1, this is the case 2. Okay. Can the minimum XOR be case 1? I mean, like, in case 1, can minimum XOR be A XOR B? No, A XOR B will be something like 1 and then something, right? But if we talk about B XOR C, this will be equal to 0 and then anything can come here. right? And I'm talking about the ith bit. Okay. There is in case 2, A XOR B is going to be 0 and then anything can come because AI and BI is 0. So 0 XOR 0 is 0 and B XOR C is 1. Is 1 and then anything can come. In none of these two cases, it happened that A XOR C will actually be smaller. In the case 1, B XOR C is smaller. In the case 2, A XOR B is smaller. That proves the statement that there can't be any case where A XOR C is smaller. Try to run it over. Try to watch this proof a lot of the times and then it will get clear to you why this is actually true. Okay. But if you are able to prove this thing, then the whole solution becomes clear that as to why this thing is correct. Okay. Cool. So I think we solved 4 problems today, I guess. And today our streak has become of 6 days, and today we got 993 points. Okay. Any questions before we end this today's stream? Pooja has asked, can you please explain again the time complexity of the first question when you set log to be more precise? Sure. So today I solved this question. What I say? I solved which question? Reverse bits, right? Or single number two? Single number two. So in the single number two question, I told, the question says that you have to do it in order of n time, which is linear time complexity. If we see here, this is order of 31 into n. This is order of 31 into n, right? Which is equal to order of n. But now let us say if this is true because the numbers are integers. But let us say that the numbers were not integers. The numbers could be anything. Okay. They could be 2 to the power 128, 2 to the power 300, something like that. Then how many bits will there be in that number? How many bits will there be in the maximum number? In the maximum number, ceiling of log base 2 of max number bits will be there, right? Those will be the bits, those will be the total bits that are needed to represent that number. Okay, suppose we are representing this thing by, let us say, x. If we're representing this by x, then a loop will go from bit equals to 0 to bit less than x. Okay, so that is why this is actually a order of n into log of number of bit solution. Okay, I hope that is clear to you. Okay, cool. So people has asked one question, one critical question: how can we build a software that can predict the patient to solve if he or she is having coronavirus or not? But solutions we can build to make them, right steps to make them out. That's actually a good idea too. That's a good problem to solve. But you can use some of the data sets that are available. You can you can analyze those data and try to find something out. That will be more of like a data domain project, which you can do to predict if a patient has coronavirus or not. You can probably use some kind of data science and ML to do that. But then there can be multiple other ways rather than data analytics in which you can help coronavirus patients. That might be some kind of entertainment, that can be some kind of games or guidelines about how they can treat themselves or how they can. Not really sure, but that's actually a very good thing that you're working on. Do let me know if you build something good out of that.
Okay, so hi everyone, welcome to day 7 of 21 days of code. We are going to discuss problems based on two pointers, problems based on two pointers approach. And so also you can see that we have completed 6 days, right? We have completed our 6-day streak and it's the 7th day. So let's begin the problem solving. And I have randomly chosen 3 problems in the interview bit section for 2 pointers question, and the problems will be sorted by the companies in which they were asked for, and also the difficulty and the time asked to solve that problem. Okay, so let's begin by the question named as sort by color. Okay, so yeah. So you are given an array with n objects colored red, white, or blue. Sort them so that objects of the same color are adjacent with the colors in the color in the order red, white, and blue. Here are some integers 0, 1, and 2 to represent the color red, white, and blue respectively. And this means that if the input contains only three integers, which are 0, 1, and 2, and we have to modify the array so that it becomes kind of sorted, right? Because all the 0 appears first, then the 1, and then the 2, all the 2's, right? So pretty straightforward question, and a straightforward trivial answer is just sort the array, right? But here's a special note in the question that library sort function is not allowed. So yeah, that's fair enough, because sort function would have worked if the elements in the array would have been anything, right? From 1 to 10 raised by 9, it can be anything ranging from all the ranges, right? But here it's specifically mentioned that the elements are 0, 1, and 2, so it's quite possible that we could have uh, used a optimized approach rather than the n log n version. So, okay, so we have three elements here. So what else we can do? We can also use counting sort here, right? Counting sort is basically just count all the zeros, count all the ones, count all the twos, and yeah, and just create a new array where all the zeros would be placed first, then all the ones, then all the twos, and that's it. The question is solved, right? But again, this is a sorting technique. This would have worked on any element. So what specific can we do in the case when we are given only three unique integers, which is 0, 1, and 2? Yeah. Okay. So how can we start about thinking this? Okay. So in the input array, we have 0, 1, 2, 0, 1, 2, right? And we have to modify the array so that it becomes sorted. This means that if these three integers we can divide, we can kind of divide our answers into three regions, right? And these three regions would be the left region, which is all zeros, the mid region, which is all ones, and the rightmost region, which is all twos, right? So, which is all twos, right? So what we can do is that uh, we can have a start pointer, which points to the start of the array, and we can start filling the start of the array with all the zeros we encounter while traversing through the array, right? And we can also have an end pointer which points to the end of the array, and we can start filling the end pointer we can start filling the array from the end. Okay, and as we encounter 2 as we traverse through the array, and once we have filled the once we have filled the end, we will automatically have ones in between, right? So it seems like a good enough approach. So we can start coding the solution, right? So first of all, I will save the size of the array inside uh, a variable n, right? And uh, then I will have a point to the start of the array and a point to the end of the array. And please note here that we have to make all the changes in place. This which means that uh, we have to change the input array itself, as we cannot return the array, the final array, right? We cannot return the obtained array. So we have to place zeros at the start and two at the end, right? And we will also have a loop counter which will iterate over my array. So this means that I'll have a while loop here, right? And this I will basically go on till the end of the array, till e, because uh, for all the indexes after e, we would have filled the 2 already, right? So we don't need to change or we don't need to edit the 2's after it, right? So this means that right, so if a of I comes out to be 0, right? If a of I comes out to be 0, then what I can do easily is that I can swap AI and AS, which means that ith element is 0 and it should be placed at the start of the array. So I will quickly swap the ith element with the one that was placed at the start of the array, and then I will increment the start because I want all the indexes before S should have all the zeros inside it, right? Now, in the same way, if AI comes out to be 1, in the same way, if AI comes out to be 2, sorry, if AI comes out to be 2, then I will quickly swap this element with the end of the array, and I will decrement my E because I want that all the indexes after E should have 2 in it, right? And now this looks like a decent enough approach because since as soon as I encounter 0, I will swap AI with AS and I will increment S, and as soon as I encounter 2, I will swap AI with the end of the array and I will decrement the end of the array, right? So this seems to me like a decent enough approach, and let's try to test our solution. Okay, so our solution fails for some trivial test case. So this seems to be a big test case to debug. So let's see that. Let's try to see where our code will actually fail. So yeah, so I'm pretty sure that this if condition will place all the zeros before the index s, right? Okay, now let's look at this index, this if condition. So I'm saying that if I encounter 2, then I'll swap the end of the element with the element which by E with the 2 element itself, right? Okay, okay. But think of this test case, like think of this test case. So what will happen here is that what will happen here is that once I am at this index, once I am at 2, it will swap 0 with 2, right? Because E was pointing at 0. So it will swap 0 with 2, and then I will be incremented to this position, right? But this is not the required answer because I need to segregate all the zeros first, then 1, and then 2, right? So this means that it is quite possible that this A of E comes out to be 0, right? This is not a good approach. Yeah, you can change you just need to change a small bit of thing here, and that is that you don't need to increment I at this position because it is quite possible that it's being replaced by 0, right? So once this is done, yeah, so once this is done, so even if A was 0, right? Even if A was 0, then I would get 0, and we are not incrementing I here. So basically, this loop will again run for the same value of I, right? So we have passed the sample test case here. Let's try to submit the solution. And okay, so we have passed all the test case here. Yeah. We have passed all the test cases here. So yeah, it's a decent enough approach, Umang, because we are using 2 pointers, the start pointer and the end pointer, right? And the only thing was that the only catch was that it's quite possible that a of e comes out to be 0, and we wanted that it is swapped with we wanted that it should be swapped with 1, but it quite possible that it comes out to be 0. So the simple solution was the that we don't need to increment our I remains the same, right? So I guess that everyone has got the solution. Just quickly reply with yes or no. Oh yeah, so Umang got it. Everyone else? Mm, okay, so yeah. Yeah, so I can move on to the next question now, right? And the next question says that you are given n non-negative integers, which are a1, a2 up till an, okay, where each represents a point at the coordinate I comma ai. Okay, so there are n vertical lines, and they are drawn such that the two endpoints of line I is at I comma ai and I comma 0. Okay, so this means that there is a vertical line, and at each for each index ai there is a vertical line I comma ai. I is the x point, I is the x coordinate, and ai is the y coordinate, right? And okay, so I comma 0 is the start of the vertical line, and I comma ai is the end of the vertical line, or you can say the top of the vertical line. Cool. So we have to find two lines which together with the x-axis form a container such that the container contains the most water. Okay, so your program should return an integer which corresponds to the maximum area of the water that can be contained. The maximum area instead of the maximum value sounds weird, but this is 2D plane, so simplicity, you cannot slant the container. So vertical lines, right? You have a bunch of vertical lines placed at uh, I comma 0, and their height is a of I, right? Their height is a of I. So you have to find two vertical lines. Let's say that one is of this length, one is of this length. You have to find two vertical lines with the maximum area between them, so that he can so that he can we can save the maximum area of water inside it, right? Okay, so we have an input which is 1 comma 5 comma 4 comma 3. Okay, and the output is 6 here. Why? Let's see that why the output is 6 here. So 5 and 3 are two distant apart. Yeah, 5 is at, if we take zero based indexing, 5 is at 1 comma 0, and 3 is at uh, 3 comma 0, right? So they are two distant apart, and the size of the base is 2. So yes, the size of the base is 2, and the height of the container is minimum of 5 comma 3, which is 3 itself, right? So which means that if this is 5, let's say that this is 5, and let's say that this is 3, and there is a two unit distance between them. So what would be the height of the container? The height of the container would be the minimum of these two heights, right? And it would be 3. So basically the total area would be 3 times 2, and this comes out to be the maximum area here, right? And okay, so the only question that I am not able to understand here is that why aren't we considering this 4 here? We are not considering this 4 here because okay, we just need to find two lines. Okay, we just need to find two lines, and this does not involve the lines between them, right? We just need to find any two lines which together with the x-axis, right? which together with the x-axis only is able to have a container, form a container that contains the most water. Okay, so this means that we have to find two vertical lines such that the area between them is the maximum. So the problem boils down to this, right? So we can think of a straightforward brute force solution. Just take all the pairs I comma j, right, and find the maximum area that you can get. You can find the maximum of all the areas that you can get once you choose all the possible pairs I comma j, right? But this won't be enough. Like, this is an n square solution, so can I think of an optimized approach? Okay, so let's see. So basically you have to maximize the area of the container, right? So area of the container is given by the width of the base and the height of the container. Okay, so the area depends upon two things: the width of the base and the height of the container. So what we can do is that let's iterate upon one. Let's iterate upon the width and see what is the maximum height that we can get, so that we get the maximum area, right? So if you understood my approach, I am saying that let's say our width is 4. Okay, so if our width is 4, the only possible two vertical lines are 1 and 3. So the area possible is 1 times 4, right? Because min of 1 comma 3 is 1, right? So so now let the width be 3 itself. So if the width is 3, then the two possible vertical lines are 1 comma 4 or 5 comma 3, right? Sorry, width is, if the width was 3, then the possible vertical lines would be 1 comma 3. Sorry, because we are counting the difference between the indices. One is at 0 index and 3 is at 3 index, right? So the width would have been 3. Now let's see let's see the solution for width equals to 2. So for width equals to 2, we would have two possible vertical lines pair, and that would be 1 comma 4 and or 1 comma 4 will give a height of 2, because 2 times min of 1 comma 4, and 5 comma 3 would give an area of 6, because twice of min of 5 comma 3. Okay, so we up till now we have got an area of 6. So now let's again decrement the width. So width comes out, so now the width is 1 itself, and width being 1, okay, so if the width is 1, then 1 comma 5 will have an area of 5, right? 5 comma 4 will have an area of 1 comma 5 will have an area of 1, sorry. 5 comma 4 will have an area of 4, and 4 comma 3 will have an area of 3, right? So still the maximum area remains to be 6 itself. Okay, so yeah, so this is again an n square approach, but maybe thinking in this direction, we can optimize that approach, right? And how can we do that? Okay, so what further optimization that we can do is, so let's think about what let's think about the case when our width was 3. So when our width was 3, our only possible vertical line pair was 1 comma 3, right? Okay, so when our width became 2, our option became either 1 comma 4 or either 5 comma 3, right? Which means that if my 1 is start, if my 3 is end, right? And for width being 2, which is decreased from 3, I have two options: either take 1 comma 4, right? Ignore 3, either take 1 comma 4, or ignore 1 or take 5,3, right? So what would be my best option? So my best option would be what? My best option would be to remove 1 from the picture, right? And this is the case because out of 1 comma 3, 1 was responsible for being the smallest one, right? So it's so after removing the smallest one, it's quite possible then that the next element is it may be possible that the next element is greater than that element, right? So it's quite possible that my answer would be increased since my width has been decreased from 3 to 2, right? My width has been decreased from 3 to 2. So our next to in order to maximize the area, our goal is to increase the height, right? So if we have to increase the height, so here is the start, here is the end. So we have two options, either to decrement the end or to increment the start in order to obtain a vertical line pair for width equals to 2, right? So my choice would be that I would increment that thing which was responsible to be the smallest one in the previous case, right? So if I take the example here, and my example would be that let's say my start is at 1, my end is at 3. So in the next iteration, or I would say that when I will decrement my width to 2, so I will increment the start here because if I will increment the start, my min of these two will now change to 3, right? If I would have decremented my end, my minimum of these two would have remained the same, which was 1 earlier to, right? So there would not have been any improvement in my maximum height of the container, right? If I would have decremented the end. So what I can do is that I can increment the start here and my end remains the same. So for the width 2, I will have an area of 6, right? And for the next iteration, I will decrement the end. I will decrement the end. So now my minimum height becomes 4, but my area is 4 itself. So the maximum area would be 6. Yeah. So now that we have reached to a decent enough approach, where if if this is incorrect, let's see that where we can make some improvements. So let n be the size of the array, right? Let the start pointer be 0, and let the end pointer be n minus 1, right? Let the end pointer be n minus 1. So yeah, and we will initialize our max area with 0 because we would be go on updating the max area variable with the maximum area that we can obtain so far yet, right? So okay, so what we can do here is that while start is less than equals to end, our area the area that we can obtain obtain is e minus s, which is the width, right? Why width? Because width is the difference between the index, right? So this is e minus s, and now we will see the height of the vertical line. So height of the vertical line would be the minimum height of the start or end of the index, right? So once we have obtained the area, so we can once we have obtained the area, we can update our max area variable, right? Okay, now we have updated the max area variable. Now what we can do is that now we have to either increment or decrement the pointer. So this says that if the minimum of ASA was AS, right? If the minimum of AS comma A was AS itself, this means that I have to increment the start, right? Else or else means that the minimum of AS of AE was AE. This means that I have to decrement my n variable, right? And so in this way, I would have the maximum height possible for all the widths allowed, for all the possible widths allowed, and I would hence calculate and I would keep on updating the max area variable with the area obtained using this, right? So let's see that if it passes the sample test case. So not the answer, but the max area. Okay, so this solution passes the sample test case. Let's try to submit it. Okay, cool. So we have passed this solution and we have also maintained a 7-day streak. Congrats, just 14 more days to go. Okay, so as you can see that this question has a fairly simple code. This question has a fairly simple code, but it was decent enough, right? From logic point of view, you can say, right? And this question came in, was asked in Facebook, Google, Amazon, and Adobe. So this is quite an important question, right? Okay, so let's move on to some other question, and this seems like a difficult one. So let's pick this. Let's pick the let's pick this question. So any doubts up till here? Uh, Maybe we are moving a bit fast, but if you have any doubts, you can send me on chat. Meanwhile, I will go through this question. Okay, so you are given an array of ones and zeros, right? And you are given an integer m, which signifies the number of flips allowed. So find the position of zeros, which when flipped will produce the maximum continuous series of ones. For this problem, return the indices of maximum continuous series of ones in that order. Okay, so you are given an array of ones and you are given an integer m, which signifies the number of flips allowed. Okay, so you are allowed an at most m number of flips, and flips are from zeros to ones. Okay, so you have to find the position of zeros, which when flipped will produce the maximum continuous number of ones. For this problem, return the for this problem we have to return the indices of the maximum continuous series of ones in order. Okay, so with this means that if this is our array, this means that this is our array, and we have m equals to 1, so we can either uh, flip we can flip this or this or this, right? Since we are allowed to flip at most one bit, or you can say at most 1 0, right? And so we can flip this or this, or we can flip this. Okay, so the output is 0 1 2 3 4. Why? Because once we flip this, the maximum uh, continuous series of ones is this, and this has just a second, this has 5 elements, right, starting from 0 to 4. Okay, so the question also says that if there are multiple possible solutions, we have to return the sequence which has the minimum start index. Okay, so if there are if the maximum continuous series is of 5, and there are several indices where this continuous series can start with the length of 5, so we have to return the minimum start index. Okay, fair enough. So let's see that how can we start this problem. So basically a very brute force solution is key for all the possible 2 raised per m cases. 2 raised per I'm talking about 2 raised per m because pick all the zeros and either you will switch to 1 or you will flip them to 1 or you will not flip them to 0 and change the array according to that and hence find the maximum continuous series of 1. So that would be kind of a 2 raised per n or brute force approach. So that won't be acceptable, right? But let's think of how can we optimize it. Okay, so how can we optimize it? Okay, so let's start from the beginning of the array. So once we start from the beginning of the array and so if we encounter 1 we won't do anything, we will just increment our pointer, right? Because agar 1 ho to that's useful for us, we don't have to flip any bit. But if we encounter 0 then we have to flip the bit and decrement a n, right? So once we reach to an index such that we have exhausted all our m's, we are exhausted all our number of flips. So that is the maximum continuous series of ones that we can obtain from the start of the array. Okay, and so let's see that what happens after that. So once we have started from the beginning and we have exhausted all our possible flips, so we have if we have exhausted all our possible flips, so this entire array is actually uh, uh, my possible continuous series of ones. But after that what I can do is that let's say that next position is 0 and we up till this we have exhausted all our flips, right? So what I can do now is that I can start kind of incrementing, or I can start incrementing our start pointer from which is previously pointing at the start of the array. I can increment my start pointer such that up till that position that my or you can say that up till that position that my such that my number of possible flips get updated, or you can say that I will I will increment the start up till I get the first 0, and I would ignore that ignore that first 0 that I will not flip so that I can flip these zeros further possible, right? So my this is kind of a sliding window approach you can think of. Why sliding window approach? Because let's say this was my initial possible array and we have 0 here, uh, which we cannot flip, right? So what I will do is that I will decrease the size of the window up till uh, I reach to the first 0, so that I can increment my possible flip and I can use that flip to flip this bit, right? And once we have incremented the flip from by reducing the window, we can start increasing our size of the window, and again we will reach to that index up till which we have exhausted our zeros, exhausted our flips, right? So as we are increasing, decreasing, and changing the size of the window, we will maintain the start and end of the continuous series of ones that we have obtained up till now. Yeah, so fair enough. We have reached to a decent enough solution. So what we can do is that we can start to code this. So here n is the size of the array, okay, and my window will be represented by two variables, start variable and end variable. S equals to 0 and is equals to 0 initially, because initially my size of the window is 0. I will keep on increasing the size as I proceed with the solution, okay. And I will also have my answer begin and answer end, and answer begin and answer end will save the starting and the ending pointer of the maximum continuous series of ones possible. Okay, so I will iterate until my end reaches the end, until my e reaches the end of the array, because that will be the maximum that would be the end of the window that I can expand till, right? So okay, so now first is the time of window expansion, right? So we can do window expansion here. So how can we expand our window? Acha, I will also maintain the number of flips that I have done up till now. Okay. So how will I expand the window? So I will keep on incrementing the end variable, and I will do so until until flips are actually less than equals to b, right? Until flips are less than equals to b, because I don't want the flips to exceed b, right? And if our a is 0, what I can do is that I can increment the flip, because if it is possible to flip the uh, current index, then I will flip it, because I want to create a maximum chain of ones, right? And I will increment e, right? So this was window expansion, and then we will talk about window contraction. And window contraction would be that while start is less than e, right? While start is less than e, and flips are basically flips are greater than b, right? So while start is less than e, why? Because I want the start of the window to reach up till the end only, and flips is greater than b, because I want the flip to reach back to b again, right? So that I can flip the further bits. Okay. And if a of start, since we are reducing the size of the window, so if a of start equals to 0, then I can simply decrement by my b variable, and I can increment my s variable, because I need to contract my window, right? And okay, so we have done window expansion and we have done window contraction. So now what we can do is that we can write some few lines to maintain the answer. And what we can do is that if flips are less than equals to b, yeah, we want that flips would maximum be b. And also if e minus s is greater than answer n minus answer s, and minus I want the maximum length of the array, right? I want the maximum contiguous array. So e minus s is my current window, and answer e minus answer s is the maximum window that I have obtained up till now. So if e minus s is greater, then simply, and this should be answer begin. Sorry, this should be answer begin, and answer begin is start. Answer begin should be start, and answer end should be end itself, right? So this will keep on updating my answer as we try to expand our window. And now we will quickly save our answer. So I will have answer, I will start from answer begin. I will move up till answer end, and I will update this, and answer dot push back will be equals to I itself. So we have created our answer array, and I will return the answer. Yeah. So let's see that if this passes the solution. No, it does not. So let's see that how can we debug it. So looks like that we have missed one element. And the only reason for that is maybe that I am missing equals to here, because answer e denotes the end of my maximum contiguous array of ones. So let's see that if it gets submitted. Yes, it has passed the trivial test cases. So let's see that if the solution is correct, and the solution seems fine. Yeah, great. And Superman for me, thank you. Okay, so I guess we are done with our half an hour live stream, and we are done with our 3 problems based on 2 pointers. So any doubts up till now? After this, I end the stream. Just quickly tell me any doubts and any questions for me, basically. Reply. You can reply in chat. Umang, Priya, Pooja, any doubt? Hmm. Yeah, window compression. Yeah, sure. So, the window compression is something like this, that I will increment my start variable up till, I will increment my start variable only up till the end, right? I will increment my start variable only up till my end of the window, and I will increment it up till I will increment it up till my flips is greater than b, which means that up till I have not encountered any zero up till now, right? So after, just see to this. Let's say that after this loop is finished, it's pretty sure that my flips will come out to be greater than b, right? Because I have put a condition here that flips are less than equals to b, right? So if this loop gets broken, or if I am outside the loop, then either e is less than n, or uh, either e is greater than equals to n, or my flips become greater than b, right? uh, so in this case, while my flips become greater than b, I have to pull back my flips to to being equal to b, right? And how is it possible? It would be possible by window contraction, right? And while window contraction, we will continue it up till I get to the first zero while incrementing the s, right? Okay, so I will get to the first zero while incrementing my s, and as soon as I have incremented my s, I would decrement my flips variable, and I will increment my s, and I will be out of this loop, right? Okay, so Adil has got it. So this was his problem. Adil asked that, can you explain the window compression? So that's why I was going through it.
Hello everyone. We are going to solve linked list today. Okay, so many people are asking me to use Java. I actually have never done competitive programming myself in Java. I normally do always in C++. But what I can do is, I mean, from the next lecture, I can share you the codes that I did, their counterpart in Java as well. Will that work for you people? Because I personally do know Java, but I have never really coded in Java that much for competitive programming. So my hand is not, what do you say, completely stable with it. Okay. So which questions do you want us to solve today? Because I mean, like, linked list is a very basic topic. It looks like a basic topic. So I'm leaving it upon you. What are the questions that you want me to solve? So it's totally live stream, and how many questions you want, and today we will do it. Let us do one question from each of these topics. Will that work for you all? I mean, like, do a very big kind of, what do we say, session, and we do a lot of questions today. Is that working with you? Cool. So we will start with the very first bucket. So what I have decided that from each bucket, I will be doing one question. Okay. So let us start. Let us do the very first question from each of the buckets. Okay. Let us start with the palindrome list. So the question says that we are given a singly linked list and we have to determine if it is a palindrome or not. If it is a palindrome, return 1, or basically if you do Boolean, it is true for 1. And if it is not a palindrome, we return a 0. So I mean, like in Boolean, false represents 0 and true represents 1. So basically we have to return true or false if we talk in parallel sense of a Boolean variable rather than an integer. Okay. ठीक है. So and the solution that is expected is linear in time and constant in space. Okay. So now let us assume that hey, this time we are given a linked list. Okay. So suppose you were given an array 1, 2, 3, 4, 3, 2, 1. This is a palindrome, right? How can we find if it is a palindrome? We can start a pointer from the left side and similarly a pointer from the right side going towards left and the pointer from left side going towards right. At each index, we check. So for example, at the very first stage, left will be this, wait a moment, and right will be this. Is the pointer at left equals to the pointer at right? Yes, it is equal. So now that means it satisfies the property. We increment a left and we decrement r. Is the new left and right equal? Yes, they also are equal. So we again increment L and we again decrement r. They are also equal. Then we increment L and we decrement r. This time L will be equal to r. So I mean like L and r both will be together. Okay, so at this stage we can stop because this is a central point. Okay, so if it had been an array, we could have done something like this: int L equals to 0, int R equals to n minus 1, while L less than R. If AL not equal to AR, return false. Else we do plus plus L minus minus R, and when we are out of the loop, we can just return true. That means that the array was sorted. But this thing doesn't work well for a linked list. Why doesn't this work well for a linked list? Because in a linked list, we don't have random access. We can't directly access this number and this number. Similarly, a singly linked list doesn't allow you to go backward side. It only allows you to go the next side. Okay, so this is why we can't use exact same approach for the linked list. Okay, but now let us see this. That let us say this was a linked list. Okay, if we also reverse this linked list, what will happen? If we reverse this linked list as well, then the reverse of this linked list will also be 1, 2, 3, 4, 3, 2, 1, right? So we can see that for a palindrome, the linked list and the reverse of the linked list is equal. Okay, so I mean like if we are somehow able to reverse a linked list, we can find if a linked list is palindrome or not. Okay, now the question comes, how will we find if, how will we reverse a linked list? Okay, let us see how we can reverse a linked list. Okay, so linked list is something like this: 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, which is pointing to 3, which is pointing to 2, and finally this is pointing to 1. Okay, now suppose at every iteration we are maintaining 3 pointers. This is the previous pointer. Wait a moment. This is the previous pointer. This is the now pointer, and this is the next pointer. Now, what we see that in the reverse of the linked list, now next will be what was previous element, and next, so basically now next will be the previous element. Okay, okay. Now let us do exact same thing. Let us try to use this approach to reverse the linked list. Okay. So Gaurav has asked how to open this particular page. Gaurav, you can click on this link. I will post some comments. Okay. This is the practice section on interview page. Okay, cool. Okay. So now, if we somehow are able to reverse the linked list, and how to reverse the linked list we already know, then we will be able to, what we say, then we will be able to find if a linked list is palindrome or not. Okay. Now, from what index should we reverse? Actually, we should reverse only this part of the linked list, right? Because when we reverse this part of the linked list will become 3, 2, 1, and whatever comes after this doesn't really matter to us. Sorry, if we reverse this part of the linked list, this will change to 1, 2, 3, and whatever that comes after this doesn't matter to us. We will keep on comparing each element. So 1 is equal to 1, okay, 2 is equal to 2, and 3 is equal to 3, and we are done. Okay. So we will reverse the part of the linked list that comes after the middle element. Okay, let us do that. So the first question comes out is, first we have to find the middle element. Okay, then the second thing is reverse the list after the middle element. Okay, and then we have to compare corresponding elements in the first half and reverse of second half. Okay, now let us do this step one by one. So how will we find the middle element? So I mean, like, if you have not heard of this approach, this is known as hare and tortoise approach. Okay, what a hare and tortoise approach is that we maintain 2 pointers on the linked list. Initially, the first pointer is here as well as the second pointer is here. One pointer moves faster, actually at the double speed of the second pointer. Okay, so at the next step, the first pointer will go here, the second pointer will be here. Then in the third step, first pointer will be here, second pointer will be here. Then first pointer will be here and second pointer will be here. So as soon as one of the pointers reaches the end of the linked list, that means the other pointer will be at the halved position of the linked list. Okay. So I mean, like, you can read about this after this session if you are hearing this approach for the very first time. But let us do that. So we say list node value at tortoise. I mean, you should actually not take these variable names. You should say slow, which is initially A. Then you should also say fast, which is equal to A. Okay. So while fast not equals to null and fast next not equal to null, so we move the slow pointer by one step. Slow is equal to slow next. But we move fast pointer by two steps. Fast is equal to fast next next. Okay. Now, when the fast will be null, so when the fast will be null, that will be a situation like this. Let us say this is a linked list. So in this case, initially slow will be here and fast will be here. Then fast will go here and slow will go here. Then fast will go here and slow will be here. So when the fast is null, at that time, slow is pointing to the first element of the second half of the linked list, right? Okay. But let us take a case when the linked list is of odd size, 1, 2, 3, 4, 5. In this case, initially slow is here, fast is here, then fast goes here, slow goes here, then fast goes here, and slow is here. At this point, slow is pointing to the exactly middle element. Okay, and we have to reverse the second part. I'm like just after the middle element. Okay, so we will say if fast not equal to null, slow is equal to slow next. Now we are sure that the element slow is pointing to the very first element of the what we say linked at the very first element of the second half of the linked list. Okay, awesome. But anyways, we will have to do, wait a second. So if first not, okay, and if first not equal to null, second is equal to second next. Okay, that's it. And always we have to set this slow next equals to null. Now we reverse the two linked list. Sorry, now we reverse the linked list that starts at second. Okay, how will we do that? We say list not. So this is also a very good technique that you should use whenever you are solving a linked list problem. While solving a linked list problem, you maintain a dummy head. Okay, which is a node that contains only 0. So initially, the previous will be dummy. The current will be the very first node, which is A, and next will be nothing. So we will say while now not equal to null, okay, next is equal to now next, okay, then now next is what? Now next is the node that was the just previous node, okay. So actually we can actually initially take previous as null, so that will also work for this, okay. Now next is equal to previous, and now what is the previous? Now previous is equal to now. Clear? Okay. So now we have done this. At the end, the previous node will represent the head of the new list, because at the end, previous will point to the node 4, which is the new start of the list that comes at the second half. Okay. Okay. So now we know this. So we will say while your first pointer is at A and the second pointer is at previous, we will say while first pointer not equal to null and second pointer not equal to null, if first pointer key value uh, yes is not equal to second pointer key value, return false, and we say pointer equals to first pointer ka next and second pointer equals to second pointer ka next. Finally, if we are out, that means we can return true. That means the whole list was a palindrome. Does this seem correct? Let us test it. Okay, so actually we did a time limit exceeded. So basically we entered in some kind of a loop, right? Let us see where we did wrong. Initially the slow is A and fast is also A. We say while, okay, fast is equal to fast next, okay. Second is equal to slow, and we say slow next is equal to null. Okay, so we should do this here, because otherwise we always have something like this, right? Let us see if we can test it. So we are saying while if fast not equals to null, second is equal to second ka next, okay, and we are setting the slow ka next to null. Slow is the previous element, okay. So in this case, in the very first case, we saw that when fast was null, slow was pointed to the first element. So we also need to know actually the previous. So we also need to know the previous slow, which will be initially null, and we will say previous slow is equal to slow. Okay. So okay, in this case, when the array size is even, initially slow will be here and fast will be here. Okay. Then slow goes here, fast goes here, slow goes here, fast goes here. In this case, previous slow ka next should be null. Okay. Else, else previous slow ka next should be equal to null, and second is nothing but slow. Okay, great. But in the case of odd, slow will point to the very first element. So second is equal to slow per next. Okay, second is equal to slow per next, and we set slow per next equals to null. Okay, now does this look cool? This looks good. And so here we are breaking the list basically into two parts, and then let us see that if we can actually test it. First, let us test in custom input. Interesting, what is happening? So we are saying that list node value at A is okay, we point slow here with previous is okay, while fast not equals to null and fast connects not equal to null. Previous row is the current value of slow, perfect. We say slow is equal to slow connects, okay. Fast is equal to fast connects, okay. Okay, so in this case fast will be null, okay, and we start sorting from here, okay. We say while now not equal to null. Are we ending here? Because we are entering into a loop, right? So we are saying while now is not equal to null, currently now is A, next is equal to, okay, we are not changing now to next, right? Previous is now, but now is also next. So we have to do this, okay, and now this will work. Yep. So, but this case it should return 1, right? So in the case of 1 to 1, slow will be here and fast will be here. Then fast goes here and slow comes here. So in this case, what is the start of the next? This is 1. So we will say that we have to reverse the list that starts at second. So we have to reverse this thing, right? While now is not equal to null. Now is actually not A. We are reversing the first list. Now is second. Okay, so now this should work. Yep. Now this is working. Yes, and let us submit it. Are we missing an edge case? I think yes, we probably are missing the edge case where all the elements are null. So one advice for any kind of linked list question, make sure that you never end up assessing a null element. That is actually a very big mistake that many people do. Okay, always ensure that the pointer that you are assessing in a linked list is not null. So that is one of the biggest mistakes I've seen many people doing that in linked list questions. Okay, cool. So we're done with the very first question. So here we learned two techniques. The one was the hare and tortoise approach, and the second thing was how to reverse a linked list. So basically, this is a combination of two questions. Let us do a question in this pointer now. So let us say that we are doing swap list nodes in pairs, okay? Because K reverse linked list is just same as the normal linked list question, normal reverse the list question, okay? Let us say that we are solving this question that is swap list nodes in pair. Okay, so we are given a basically linked list and we have to swap 1 and 2. Then we have to swap 3 and 4. So basically 1 and 2 will become 2 and 1. Then we are done with this particular part. Now we are taking the care of the part 3 and 4. We again the swap it, which becomes 4 and 3. Okay. And we are asked that, hey, we have to use only constant extra space. So basically, we can't create a new linked list. But what is meant by a constant extra space question is normally that what we mean by a constant extra space in linked list is that you don't have to create a duplicate node. You have to use the nodes that were given in the initial question itself. Okay. Yes, Tosif, I think in the previous question, P slow was not required. At the end of this video, I will again go back to the question and then we will try to improve it, okay? Because I think I kind of messed some parts of it. We will go back after we are done with today's video, okay? Sure, Gaurav, I will summarize it at the end, okay? I mean, like after I'm done with 2 more questions and then we will shift. Reorder list. I think you're talking about what the next question we should do, right? I will see that. Okay, anyways, let us try to see how we can do this. So basically, linked list is nothing but a game of pointers. How you are able to mingle pointers is how you will win the game. So let us say that we have 1, 2, 3, and 4. Okay. Okay. So now suppose I have to reverse this linked list. Here, actually, you will. So I told that in the previous question as well that dummy head is a very common and helpful technique in solving any kind of linked list question. Okay. So, for example, here what I will say, I will assume that there is a dummy node here, after which it is 1, after which it is 2, and 3, and 4. Okay. So now see, suppose I am reversing the pair of 4 and 3. Okay. Suppose I am reversing the pair of 4 and 3. I at least need the pointer to 4 and also the pointer to 3. Okay. But I also need the pointer to 2. Why? Because when I have reversed these two, I have to make sure that 2 ka next points to 4. Okay. So we at least need 3 pointers. Okay. Okay. So let me first create a dummy node. Okay. Okay. Let me name this pointer. Let us say that when we were swapping 3 and 4, let me name the variable 2, the variable that stores the node 2 as the previous pair end. Okay. So let me say list node value at previous pair end. Initially, it will be dummy, right? Because this is the end of the first pair. So as assumption, this is our assumption. Okay. So this will be dummy. Okay. This will be equal to the current pair start. Okay. So this is current pair start. Okay. Which is in the case of in the first case, this will be the node A itself. Okay. Awesome. Okay. So while I will say that while the start of current pair is not null, start not equal to null. Okay. So I will say current pair second is equal to okay. I let me also assume that current pair start ka next is also not equal to null. Is not equal to null. Okay. So current pair start ka next. So basically, both the nodes of the current pair exist. Okay. If there is only one node, we don't need to do any swap, right? So I will say current pair second is equal to current pair start ka next. Okay. Okay. I also know the previous pair end. At the end of the current iteration, what will be the previous pair end? Previous pair end at the end of current iteration will be the starting node of the current pair. Because at this time, let us say this was the start and this was the end. Okay. So after this will change to 4 and 3. So basically, this will be the previous pair end. So which is the current start node. Okay. Okay. And we also have to make sure that current pair ka second, so basically previous pair end ka next is equal to current pair second. Why? Now has to point to 4. Okay. And current pair second ka next is current pair start. So now we have made sure that 2 points to 4, 4 points to 3. Okay. And finally, we have to make sure that 3 points to this. Okay. So current point start, current pair start का next should be equal to what is currently the current pair second का next. Okay. Finally, we can change the current pair second next, and this is previous pair end. Okay. And finally, I can just return dummy का next. Okay, because dummy was just a node that we assumed. Okay, so now in this case, dummy ka next will become, so the pointers will change like this, right? And 1 will now point to 3, and dummy ka next will point to 2. So dummy ka next will actually be 2, which is the start of the next list. Let us see if that is correct or not. We might have done some errors, but let us see. Hopefully not. What did I do? Oh, I didn't comment here. What are we doing here? So we are saying that initially we actually made sure that dummy ka next should be equal to A. Okay, because dummy is going to point to 1, right? That I told earlier. I will like initially dummy should point to 1 and 1 should point to 2. So I didn't point it dummy to first one. Now let us test this. Loss 0. Okay, and I say first pointer previous pair end is dummy. Okay, and current pair start is A. Okay, while current pair start is not equal to null and current pair start ka next is not equal to null. Okay, both are not equal to null. So then current pair second is current pair start ka next. Okay, we change the previous pair end ka next to current pair second. Okay, so now dummy node is starting to point to 2. Then we make sure we point 2 ka next equals to, sorry, 1 ka next equals to 3. Okay, so now dummy node is pointing to 2 and 1 is pointing to 3. Okay, now we should point 2 to 1. So current pair second ka next, that is 2, is now going to point to 1. Okay, and previous pair end will be equal to 1. That is fine. So this thing is fine. And what will be current pair start? Okay, so now we have not changed current pair start. If previous pointer end not equal to null, current pair start is equal to previous pointer x next. Else current pair start is equal to null. Similarly, if current pair start is not equal to null, then okay, so we don't have to do that. So we only need current pair start and we are done. So now 2834 is changed to 3428. 4874 is changed to 7448. Similarly, 4249 is changed to 4942, and we are doing well. Let us see if we have any issues. Great. So we got this as well. So what thing we learned from this thing, the takeaway should be that, hey, for any linked list question, first try to find what are the pointers that you need to know to reorder the list in any way. Suppose it is swapping pair, what are the elements you need to know so that you can change their pointers to something else? That is the very first thing you need to know. And the second thing is, again, I tell you to know, is this dummy thing. This is very important in a lot of linked list questions. I will do one more question after this that will use this thing. And the third thing is, make sure that you are never assessing null. Okay, so here also I do a check of null. Make sure you are never assessing something that is null. Okay, cool. Let us do one more question. So Akash has asked, can we do the reorder list question, right? Let us see that. Okay, So the question is, we are given a singly linked list L0, L1, Ln minus 1 to Ln. Okay. And we have to reorder this to L0, Ln. Okay. So the very first node from the start and the very first node from the end. Then the very second node from the start and the second node from the end. Third node from the start, third node from the end, and so on. Okay. And we must do this in place without altering the nodes values. So what in place means is that you don't have to change their values. I mean, like, you can dangle some pointers, but that will work. Okay, you just don't have to change the node values or create a duplicate of those nodes. That is the only requirement. Okay. Okay. So one thing that I find from here is that, hey, if we somehow, let us say that this was our list. Okay, our list was 1, 2, 3, 4, 5, and 6. We have to change this to 1, 6, 2, 5, 3, and 4, right? Suppose I know the first half of the list. I also know the second half of the list, which is 4, 5, 6. Okay. Now I reverse the second part of the list. This is 6, 5, 4. Now what I do, I keep on merging this. First, this is 1, so I will put this one. Then I put this 6. Okay. Then I put this 2. Okay. Then I put 5, and so on, right? Okay. So how can we do that is, first split the list in two halves. Okay. Then reverse the second half. Okay. And finally merge two lists. This is something that you do. This is something very similar to that you do in a question like merge sort, right? In merge sort, the merge step is something like this. Okay. Okay. Let us do these steps one by one. In the previous question, we had discussed an approach to split the list in two halves and reverse the second half, right? We had discussed that in the very first question for the day. Okay. So let us do that. So how did we do that? We do this question by using two pointers, the slow and the start. Okay. So initially the slow pointer is equal to A and the fast pointer is also equal to A. Then we do while fast not equal to null and fast next not equal to null. Slow is equal to slow next and fast is equal to fast next. So now there were two cases. The first case was if fast not equal to null. When did that case happen? Let me redraw it again. That case happened when the linked list was of odd size 1, 2, 3, 4, 5. So in this case, slow will be here and fast will be here. Slow changes to this, fast changes to this, slow changes to this, fast changes to this. In this case, fast is not equal to null, right? Okay. In this case, we can reverse this whole linked list. So this will change to 1, 2 will remain as it is, and this will change to 5, 4, 3. Suppose we are able to do that, then we can do the merging, right? Or not? Yes, you can do that. So it will be equal, yes. Okay. Okay. If the size of the linked list is even, then it will be 1, 2, 3, and 4. Then slow will be here and fast will be here. Then slow goes this, fast goes this, slow goes this, and fast goes this. Then also we can reverse the linked list that starts at start. So that we could do even in the previous question. I missed this thing. So we can reverse the linked list that just starts at the slow pointer. Okay. So suppose we reverse this part of the linked list, then we are cool. Let us see how we will do that. So also we have to make sure that the pointer of 2 is now the next of 2 is null, so that these two lists break off, right? Else anything can happen. So we will say list node value at previous low is equal to null, and previous slow will be equal to slow. So finally, we can say previous slow next is null. So at this point, we have broken the list into two halves such that slow points to head of second half. Okay, great. Okay. So now let us reverse the linked list that starts at the slow pointer. Okay, so basically reverse this 345 to 543. So we will say list node value at previous is null, list node value at current is equal to slow, and list node value at next, this variable we will need. We will say that while current is not equal to null, that means there is still a node there. Okay? So while current is not equal to null, I will say next is equal to current ka next. Then I set current ka next is equal to previous. Finally, I change previous equals to current. And what is the next current? The next current is the node that was currently stored in the variable next. Okay, great. So now this has reversed the linked list part 345 to 543. At the end, the node 5 will be the previous node. So we can say that list node value at second head is equal to previous. Now we do have to just merge both the linked list, right? So we will say while a not equal to null, sorry, yes, for this also we will need a dummy node. Okay, then we will need a pointer to the current index in the dummy in the answer. So list node value at dummy pointer, initially it will be equal to dummy. Okay, we also need a pointer which will be initially a, and we also need the pointer to the second half, right? So this will be second head, right? So we say that while a pointer not equal to null and second pointer not equal to null, okay, so while both of these are not null, we first append the second thing to this. I mean, like, then we append, but we say we have to first append the node at a pointer, right? So we say dummy pointer ka next is equal to a pointer. Okay, then dummy pointer equals to dummy pointer ka next. Finally, dummy pointer ka next, okay, and a pointer is also equal to a pointer ka next. Then dummy pointer also moves to one step ahead. We change dummy pointer ka next is equal to b pointer, or the node that b pointer points to. Okay, and then we say b pointer is equal to b pointer ka next. Okay, great. So now what will we be having is, suppose for the nodes of size, sorry, suppose for a linked list of odd size, we will be having something like this: 1, 5, 2, 4. Okay, but at this time, the pointer to the second pointer will not be null, but the first pointer will be null. So we say if second pointer, or if second pointer, there should be second pointer, right? If second pointer is not equal to null, that meant that the total number of nodes were odd. So we will say dp, again we have to make sure, okay, dp next is equal to what we say, the second pointer. Okay. Okay, so TP connects is the second pointer, and finally we have reached the end, so we don't need to do anything. We can so yep, we are done. Now, where is the answer? The answer is the dummy head ka next, right? Because dummy head ka next is storing the very first node in the answer. So we can just do return dummy pointer ka next. Sorry, dummy head ka next. Like this. Dummy ka next. Let us see if this works. What is this happening? This is returning dummy pointer connects. What is the dummy pointer connects initially? This is the first pointer, but the first pointer is null. Initially, the second pointer is also A. So the second pointer will still point to this. So second pointer will not be equal to null. So this should be correct, right? So let us see why this particular case is having issues. So for the list of size 1, only a single node, slow will be 1 and fast will be 1, and previous slow will be equal to null. Okay, so in this case we won't ever go here. So if we don't ever go here, that means that there was only one node, right? That will happen only if there was less than 2 nodes. So we can say if previous slow is equal to null, we can just return the original linked list. Why? Because this thing will happen. I mean, like previous slow will be equal to null only if there are 0 nodes or 1 node. In that case, we don't need to do anything and we can just return the original linked list itself. So now this should work. Yep. Are there any other cases that you are missing? No. So happy. Yes, and let us submit it. Great. So yes, in this thing we missed checking for null one time and we again ended up with an issue. So that is why I was saying that never get to a situation where you are not checking for nulls. Okay. And also again you saw that what is the use of dummy pointer. Dummy pointer allows us to improve the code quality by not checking for nulls in the initial previous. Okay, so use this technique as well. Let us do one more question for the day and then we will end. I think we already have completed the today's streak probably. Yes, but let us do one more question. Okay. What question do you guys want me to solve? Anyone from the linked list section? Anyone? Let us do this list cycle question because this is a very this also requires knowing a technique that many people might not know. So let us do this. Okay. Okay. So we are saying is told that we are given a linked list. We have to return the node where the cycle begins. Okay, the linked list might or might not have a cycle, but if there is a cycle, we have to return the node, the first node from the start where the cycle actually started. So for example, if we start traversing this linked list like this, the node 3 is the very first node where the cycle began, right? So we have to return the node 3. Okay, great. So let us see how we will do that. So see, we once found a middle of the linked list, right? We were once able to find the middle of a linked list using the previous approach, right? So some people are suggesting the hash approach, but if you see the hash approach has a space complexity of order of n, right? So we have to do something that has space complexity of order of 1, but time complexity of order of n. Let us do that. Okay. So we remember that hey, we were able to find the middle of a linked list using the hare and tortoise approach. But if the linked list has a cycle, will we ever be able to find the middle? No, right? Because fast will never be equal to null. So if we start growing from 1, 2, 3, 4, then we will keep on coming back to 3, 4, 3, 4. So if we were suppose finding this thing, value at slow is a, fast is also a. We say while fast is not equal to null and fast connects not equal to null. Fast is equal to fast connects and slow is equal to slow connects. Okay, but when there is a cycle in the linked list, this loop will never end. Okay, because it will again going on circle around. So let us say what will happen. Okay, suppose the loop is circling around and currently, let us say this is the case. So this is a linked list 1, 2, 3, 4. Okay. Okay. And suppose all these nodes are in a cycle. Suppose all these nodes are in a cycle. Okay. It might happen that currently fast is here and slow is here. Okay. That means in the next iteration, fast will go, what we say, at this place. And where will slow go? Slow will also come at this place. Okay. So, okay, that is the case one. The case two is, let us say fast and slow are very much behind. Okay. Let us say initially the fast was here and slow was here. Okay. Then what is going to happen in the next iteration is, in the next iteration, fast is going to come here and slow is going to go here. Now this condition is again same as this condition, right? The condition that we had here. So we can say that if fast and slow pointers are in a cycle, that means they are definitely going to meet at some time. Okay. So we can say while fast not equal to null and fast connects not equal to null, okay, if fast is equal to null, this means that there is a cycle, right? This means there is a cycle. So we can break. Okay. So here we can say that if fast is not equal to null, or and fast connects not equal to null, or fast connects not equal to null, what do we have to do? Okay, so let me say that I pool cycle is equal to false. If we enter in this loop, we say that cycle is equal to true. That means there is a cycle in this current thing. Okay, so if there is a cycle, now the question comes, how will we find the start of the cycle? But let us solve the case if there is no cycle. If there is a no cycle, we can just return null, right? Now let us see how we will find the start of the cycle. Okay, so let us say our cycle is like this. So there are nodes 1, 2, 3, 4, 5, 6, 7, and this 7 is pointing to, let us say 4. Okay, so 7 is pointing to 4. Something like this. Okay. So suppose 7 is pointing to 4. Okay. That means this is a cycle. Okay. Great. So now how will we find that 4 is the start of the cycle? How will we be able to do that? Let us see. Suppose, assume that this size, the size of the linked list before the start of cycle was A. Okay. Okay. Suppose this size of the linked list before the start of cycle was A. Okay. And currently, both the slow and fast pointers will be traversing 4, 5, 6, 7, again 4, 5, 6, 7, and so on, right? Is that clear? Okay. So now we know that this is, so now somewhere inside this linked list will both these nodes meet. Suppose both the fast and slow meet at this particular place. Okay, and let us assume that from the node start, this distance was b. Okay, so a was the distance of start of cycle from head, and b was the distance of meeting from the current node. Distance of meeting uh, from the start of cycle. Okay, okay. And let us say we also have a variable c, which is the start of cycle, which is the size of cycle. Okay, okay. Now, can there be any formula between a, b, and c? Is there any relationship between a, b, and c? Any guesses? Yes, Joseph, that is true. That fast will not become null when there is a cycle that we have assumed. So basically, that is why at this particular position, if fast, uh, wait a second, if fast is equal to slow. Sorry, thanks for pointing that out. If fast is equal to slow, we are saying that there is a cycle. Okay, is that clear? Okay. So now let us try to see of one more thing. We say that hey, this size was a. Okay, this size, suppose the nodes met at node 5, this was this size was b, and this size is c. Can there be a relationship between a, b, and c? Hmm? Let us say in this way. Suppose the fast and slow pointer had traveled this node x times, this cycle x times, when they were inside the cycle, because they will keep on circling around, right? Okay, suppose they had traveled x times, so the total distance traveled by slow will be equal to this, which is a, plus the number of times they travels this cycle. What will be the number of times? Let us say they traveled this n times, and what is the size of this they traveled? The size of cycle is c, so plus n times c, and they met at this. Okay, so what is this distance? This is b. So this will be the distance covered by the slow node, correct? Okay, and what will be the distance covered by fast node? The distance covered by fast node is nothing but 2 times the distance covered by slow node, right? Okay, but how many iterations would it have done? How many iterations would the fast pointer would have done? Suppose fast pointer did y iterations. Okay, slow pointer had done x iterations, and let us say fast pointer had done y iterations. So the distance covered by the fast pointer is going to be a plus hmm, a plus okay, so this is n, let us say this is m. Okay, so a plus m into c plus b, right? That means a plus m into c plus b is equal to 2 times a plus n into c plus b. Is that clear? Okay. From these two equations, we can find that we'll be able to find that what will be the equation that will come out to be? The equation will come out to be that hey, what is the distance from a plus b? Okay. Okay. So if we try to expand this equation, this will become a plus m into c. So let us try to expand the right hand side first. This is equal to 2 into a plus 2 into n into c plus 2 into b. Okay. If we take b to the left side, so this will become a minus 2 into b. Okay. And also bring this a to minus 2 into a plus b, right? So okay, so this is going to be equal to 2 into n into c minus m into c, right? Okay, so what we get from this is that this is nothing but equal to minus of, this is equal to minus a minus b, and the right hand side is equal to uh, c into 2 into n minus m, right? Okay, but what we find from this, this means a plus b, a negative, is equal to uh, c times something. Okay, but what is c? We see that c is the size of cycle. So basically we find that hey, the distance from a to b, so basically this distance is actually going to be a multiple of the size of cycle, right? So if we again start a pointer from this particular position, and we again, so basically till this time this goes till here, the pointer that will be at this place will actually come to 4 again. Why? Because it will go from 5 to 6 to 7 to again 4, and by the time the another pointer, if we start from 1, will also reach to 4, and 4 is going to be the start of cycle. Okay, so what we can do is we can start, we can again put slow is equal to what we say a, and we say while slow is not equal to fast, this time we will move both the pointers by only one movement. Okay, so we will say slow is equal to slow connects and fast is equal to fast connects. Okay, now that means, wait a moment. Okay, that means now where they have met, that is nothing but the start of the linked list, start of the cycle, so we can just return slow. Okay, so in this thing should work, I think. What happened? I'm saying if fast equal to slow, while fast is not equal to null and fast connects is not equal to null, if fast equals to slow. Okay, so we will actually have to start with okay, so this thing will be actually initially true, so we actually have to start with this, because at least we have to move fast and slow ones, because they will otherwise always be true. Great.
Hey everyone, as you can see here that we have already maintained the 8-day streak and we just have 2 hours left and we need to maintain a streak. So in today's class, in today's thing, we will solve some of the questions of stack and queues. Let's proceed at that level. Let's solve some questions. Okay, let's solve the very first question. The question is, let's say all 3 questions of this clever stack. Okay, let's start the question. We have been given an array, and in that array, we need to find the nearest smaller element gi for every element ai in the array, such that the element has an index smaller than I. Okay, let's say we have more boundary. Gi is the element aj is greater than I. Okay, the basic question is for each particular element in the array, we need to figure out the nearest smaller element for that particular element in the array. Okay, let's say this is our array, and for 4, as we can see that no element is less than 4 in the left side, so we have g1 is equal to -1. So for 5, as we can see that the minimum most element for 5 in the left side is 4, so our answer will be 4 for this case. Now if I can see for 2,
Okay, both 4 and 5 are greater than 2. So for 2 as well, I can see that there is no minimum element in the left hand side. So -1 will be for this as well. Now I can see that. Okay, similarly, okay, now let's try to solve this question. Okay, how I can solve this question? Let's first think. Okay, for each element, if I do in a brute force way, what I need to do, I will just iterate over all the elements in the left hand side, and I just figured out whether there is an element which is lesser than that particular element. If I figure out that element, then I found the answer. In that way, I can proceed. Let's first copy this example. Okay. Okay. Now what we can do, how we can solve this question, let's see. Okay. Let's say, let's start from the end. Fine. Okay. Let's say in the initially, we have an element 8 only. Okay. Now, as I move ahead, I just found an element 10. And I know that that element is greater than that element. So I haven't find the answer for 8 as well as 10 yet. So what I can do? Okay, now I just figured out 2. Okay, one thing that is clear to me that 2 is smaller than 8 as well as 10. So, okay, so one thing for sure that I'm saying can say that 2 will be the answer for both 8 and 10. Okay, so what I can do, I can update my answers and I just need this data point only because I already figured out the answer for this. So I just need to maintain 2 only. Now let's say I just go into the other element. I have 5. Okay, if I found 5, when I have 2 to which I need to figure out the answer. For 2, I know that 5 won't be the answer. So I haven't found the answer for 2 as well as 5. Now I figured out 4. Now I figured out 4. I can say that, okay, 4 is lesser than 5. So for 5, 4 definitely will be the answer. For sure. But for 2, it won't be the answer. So after then, I need to store these 2 points. Isn't it? So the way if I will do in that way, I will figure out the answer. So what I just think, okay, I am appending the elements, and as I'm appending the elements, I am checking. And if I need to check the element, what I am doing, I am just first checking for the last element and then the second last element, and I am doing in that way, and I'm able to solve this question. If I'm able to do in that way, then it's easy to solve. So I need some sort of data structure which helps me to maintain this information. And that data structure should be something like where I can add the element in the end such that I can also remove the element which I just added in the end. So it should be last in, last out. And we know that stack is that data structure which provides that sort of thing. So I can use stack here and just try to solve in that way. I am able to achieve, because what I am doing, I am adding an element in the stack, and when I just found an element which is lesser, what I am doing, I am just checking with all the elements in this stack, and if I figured out an element which is greater than that element, I'm just removing it to the stack. So only I am adding an element one time into this stack, and I also am removing from this stack only one time. So that means it's kind of order of an algorithm that we just achieved. Okay, let's try to think how we can write code for this question. Okay, let's write the code. Okay, let's try think what are the constraints that we have been given. Okay, we have not been given any constraint, and the thing is, if we haven't find an answer for any element, we need to return -1 for that particular case. Okay, let me first, what I can do, let me first figure out the size. Okay, let me create my answer, which is of size n, and let me have the default value as -1 for each particular element in that particular array, because we haven't find the answer, and we will follow the algorithm as I discussed here, so that we will be able to achieve our solution in order of n time. Okay, let's try to think. Okay, how I can do that? I just need to iterate. In the last element, I need to move till the first element. In that way, I need a stack data structure to maintain the information, as I just discussed. Why? Okay, so now what I can do if I need to pose a question. Okay, one thing I need to be sure that, but what will be the edge case? If my stack is empty, or if I have my element which is at the top of my stack, okay, if I figured out an element, okay, which is greater than my top, then that means I haven't found the answer for both of the elements. So I need this data. So I need to push that element into my stack. If that is the case, if that is greater than, that is element is greater than or equal to my that element, so I need to push that element into my stack, isn't it? Okay, now I'm done here. So I can continue. Okay, if there is other case, if the element at my top is greater than AI, if that is the case, then I need to check for how many elements I have found the answer. So let's first just check the edge case, whether my stack is empty or not. While my stack is not empty and my top element in the stack is greater than AI, in that case, what I can do, I know that answer for stack dot top will be equal to AI for sure. And I can safely remove that element. Because I just figured out the answer for the topmost element in this stack. Now I need not need this data in the future. So I can safely remove it. By the time this thing gets ended, I can say that, okay, now I'm done. Now I can safely add a ith element because I haven't found the answer for ith element yet. And in the end, what I can do, I can return my answer. And let's check once again whether I'm doing in the right direction or not. I am maintaining my answer, and I just created an empty stack, and I'm checking if my stack is empty or if it is greater. So then I need to push that element into this because it's of no use. Otherwise, I need to check if my element is lesser. So that means for that topmost element, I just figured out the answer. So what I need to do, okay, in that way, if I just do in that fashion, I can solve. Okay, that seems like a good approach. Let me test. Okay, it's giving me correct answer. So let's submit. It's taking time. Oh, nice. Nice. We have solved this question. Now let's move to the next question. Okay. What will be my next question? Okay, now the next question is, I need to figure out the largest rectangle in the histogram. Okay, that is my question. Let me think. Okay, let me first read the question. We have been given an array of integers a of size n, where a represents a histogram. That is, ai denotes height of ith histogram bar, and width of each bar is 1. Okay, let's say we have been given this histogram, and where the height of first bar is 2, and the height of second bar is 1, and height of third bar is 5, and fourth bar is 6, and so on. And above is histogram, and width of each bar is 1. And we have been given heights like that, and we need to figure out the largest rectangle in that histogram. Okay, let me think how we can figure out that thing. Okay, if that is the case, this will be my answer. Okay, they are saying this is my answer, and the answer will be 5 as my height and 2 as my width. So my answer for this will be 10. Okay, so let me just copy this thing. Let's try to think how I can solve this question. Okay, one thing that is coming to my mind, uh, the way we can solve this question is, okay, let's the brute force approach that is coming to my mind, that we, okay, okay, Jaskirat, hey Jaskirat, okay, I don't have an access for the paper at this time. Okay, which part is not clear to you, Jaskirat? Could you please write here? Hey Jaskirat. Okay, let me do one thing. Okay, one thing can be done if I want to do this in that way. Okay. Hmm. Okay. Wait, just Kiran, wait for a minute. I'll do something. I'm. Is it visible to you? Just Kiran, is it fine now? Okay. So the question was, we have been given an histogram where the values are 2, 1, 5, 6, 2, 3. Okay, and we have been given histogram like that. Okay, okay, this is 2. Okay, let me first draw the histogram on the paper and then it's more suitable. Okay, 1, 5. Okay, it will be 5 and then 6 and then 2 and then something 3. Fine. So this will be my answer in this case. So what I can think is, what can be the brute force way to solve this question? One thing is coming to my mind. I can solve it in a way that, okay, let me take all the contiguous segment to solve this question. Okay, and I can take all the contiguous segment of length 1, then length 2, and just try to find the answer for that contiguous segment. Let's say I just take this contiguous segment of first 3 element, which is 2, 1, and 5. What will be my answer for this contiguous segment? Okay, I know that the width will be equal to 3. But what will be my height in this case? Okay, I can surely say that if I want to build a rectangle, then the height will be the minimum height histogram available in that contiguous length, isn't it? So I can say that the height will be 1. If I do in that way, then I can solve this question. That is fine. Okay. So if I just take in a brute force way, so how much time it will take to me? I need to iterate over every contiguous segment, and to iterate over each contiguous segment, I need to I need to take two variables L and R. So it will take order of n square time. And for each contiguous segment, I need to find the minimum most element. So the complexity will go up to n cube. So it doesn't sound me a good solution to solve this question. Can I think something else to make my algorithm better? Okay, let's think what I can do. Okay, let's think. Let's say I have an example, something like this. Okay, let's say this is my example. If I build a histogram, I have 7 here and I have 8. I have something 6. I have again 8. And I have something again like 7. Okay, if I am just considering all the contiguous segment, I will consider this segment as well. And I will consider this segment as well. I will consider this segment as well. I will definitely consider all the segments. If that is the case, that means, but I know that for all these segments, if there in that segment 6 is the part of that segment, then my minimum value will always be 6. Okay, can I use this idea to achieve something? Okay, why I am just iterating over all the contiguous segment? Why not that maximum contiguous segment for 6, which will give me the answer? Because in any way, other contiguous segments are waste for me. That's the waste of computation time. If somehow I just figured out for that particular 6, what will be the maximum contiguous segment if I just consider this element? So one thing I can surely say that, okay, if I just consider this element, how much elements I need to take in the right hand side that I need to consider. Okay, I can consider 8, I can consider 7, but if I have something 5 here, I can't consider that element. Okay, this gives me the idea that what I can do, I can just take the nearest minimum element for a particular element in the right side. Fine, because such that all the elements in between will be greater than 6, and I can consider those elements for this element. And likewise, I can extend my similar approach in the left side as well. So this gives me some idea. If I do in that way, I can solve my problem. Okay, so this gives me the idea what I need to do for each element. For each element, I need to figure out the nearest minimum element in the right hand side as well as in the left hand side. Because I can surely say that this will be the maximum contiguous length for that particular element, which will give me the answers. And if I take any smaller contiguous length for that particular element, they are of no use. And in the previous question, we just solved how to figure out the nearest minimum element for any particular element. And we know that we can solve this using stack in order of n time. We just solved it. Okay, I can use that approach here as well, and I can solve this. And I can solve similar for the right hand side and for the left hand side, and I'm done. That sounds like a good solution. Let's write the code for this now. Okay, let's write the code for this question. Now let's say this is the case. Let's first try to dry run this. Okay, now for 2, I know that the nearest minimum element for 2 in the right hand side is 1, and in the left hand side I don't have any element. Fine, and so I just end up with the contiguous segment of 1 element only for 2. So that means for 2 my answer will be just 2. Now if I take 1, now for 1 I can see that for 1 5 is greater, 6 is greater, 2 is greater, 3 is greater. So I can pick all the elements for 1 in the right hand side. That is good. And in the left hand side as well, I can pick all the elements. That sounds like a good thing. So I can do like that. If I do in that way, so for 1, length available will be equal to n. So which is 1, 2, 3, 4, 5, 6 in this case. So my answer will be 6. Now for 5, if I do in similar way, I can see that for 5, the minimum length available, 6 is greater than 5. And okay, I found element 2 which is less than 5. So I can only consider these two elements for 5. Now, if I just think of an element in the left hand side, I can see that 1 is the minimum element for 5. So I can consider only these set two elements for 5. So I have a length of 2. Length of 2 for 5. I have a length of 5. So my answer will be 10 if I take 5 as a length. Okay, now if I take 6 as a length, then my area to consider for 6 will be, I can't take this element because this is smaller than 6, and I can't even take this element. So because these two elements are the nearest minimum element for 6. So I just have a one length for 6. So my answer will be equal to 6 only. Okay, now I consider for 2. If I want to consider for 2, okay, 3 is greater than 2, so I can consider that element. Now if I move into the left hand side, I can see that 6 is greater than 2. Okay, nice. And 5 is also greater than 2. Nice. But 1 is smaller than 2. So the nearest minimum element in the left side for 2 will be 1. So I can consider only these two elements for 2. Fine. So the total elements I can consider for 2 will be these 4 elements. So my length will be 4. So my answer for this case will be 8. Now for 3, let's consider what will my length. Okay, for 3, I can say that for 3, there are no elements available in the right hand side, but let's see what are the elements available to me in the left hand side. Okay, 2 is the nearest minimum element for 3 in the left hand side. So that means I have just of length 1 for 3, and answer will be equal to 3. Okay, I have considered all the elements by using that analogy, and I can see that if I want to consider that element, so I can just get the maximum length of 5, maximum length of 2 for 5. So that means it's okay to do like that, and in the end what I can do, I can found the maximum answer out of them, which is 10. So 10 will be my answer. Nice. If I do in that way, I can figure out the answer. Nice. And I can see that 10 is the answer for this question. Nice. So let's try to write a code for this. But with the simplest code to write the solution for this will be, let's first have a size. Okay, I need two informations for every particular element. What will be the nearest smaller element? For that element in the right hand side, I also need the information, but with the nearest smaller element for that particular element in the left hand side. So I need both the information for any particular element. So let's say I created two vectors. The one of them is storing the smaller in right side, and I need that information for all the elements. So I just initialize. I just need the size of n, and what should be the default value? Okay, I know that if for that element I haven't found any element which is lesser than that element in the right hand side, so I can say that, okay, let's just say that, okay, so in that case I may end up end of my list, so I can safely mark it as n. Okay, because that seems like a good thing. Okay, now I need one more information which is smaller in the left side. I need that information as well. Okay, if I need that information, so I need this information an element, and in similarly I know that if I move into the left side, I haven't found any element which is lesser than this particular element, so I end up with an index of -1, because something like it goes beyond 0 in the left hand side. So I can pick the default value as -1, which seems like a good thing to me. Okay, now let's fill both of these arrays. How we can fill? So this is quite simple. We need a stack for this, because what we need to do, we need to figure out the nearest most element in the right hand side as well as the left hand side. As we discussed in the previous question, we can easily do this by using stack. And let's say I created a stack. Now let's first solve it for the right side. And let's say I need to iterate. Okay, now how we can do that thing? Let's say I consider the edge case. Let's say my stack is empty. Or the value available at this top of my stack is actually less than or equal to my current element. If that is the case, so I haven't found the answer for my current element yet, as well as for any element which are at this stack, because I just found an element which is greater than the element present at the top of the stack. So I need this information. So I need to push that element into the stack. So that's the only thing that I can do. So I am done here. So I can continue. Now, if that is not the case, that means this means that I am at the top. Okay, I need to first write the edge case. I need to iterate up till my stack is not empty. And my stack top is, if it is greater than AI, that means the ith element, it's basically lesser than the topmost element. So I can say that for the topmost element, ith element will be my answer. So as I'm moving into the right side, so I can update the answer for smaller right side, stack dot. So I can safely update it as I. Now I need not need the information for that particular element, so I can easily safely pop that element from my stack. Nice. So if I do in continue that way, I haven't figured out the answer for I yet, so I need this information. So I need to push that element into the stack. Let's say I just push that element in my stack. Fine. If I do similar way for my left side to populate this array, okay, I just need to apply the similar algorithm for this case as well. So what I can do, I just move into the left side now, and my algorithm will be something like this only. So I can just copy the same algorithm. Okay, so if that is the case, so but instead of left side, now I'm populating my left array for each element. Now by doing these two operations, we just populated both of my arrays. We now have that information that for each particular element, what will be the nearest smaller element in the right side, as well as we have that information what will be the nearest smaller element for a particular element in the left side. We have both the information. Now let's calculate the answer. Let's say initialize my answer as 0, because obviously my answer will be bigger than that 0, so I can update my answer for each particular element. Now, okay, what I can do, okay, now what I can do for, I have an element in consideration, which is element in consideration. Let's say it is a of I. Now, what will be my temp answer? That temp answer is basically this answer, which symbolizes that if I take this particular element in consideration, what's the maximum area of rectangle that I can achieve? Okay, let's try to think. Maximum rectangle area that I can achieve for that particular element. Okay, for that, my length will be, height will be this, and what will be my width? I know that if I need to figure out the width, I need to find the nearest smaller element in the right side as well as in the left side. So for this, that's why I just keep the default value as -1 for left hand side and for right hand side, so that it's easy to compute that thing. So let's say for 2, I have my nearest smaller element in the left side will be -1, and in the right side will be 1. So if I take the whole length will be equal to 3. If I take the whole length, my whole length, that is nearest right side minus of particular that element I, and I take the nearest left side, the particular element I plus 1. So this will be the total length. But in that particular length, I just include the nearest smaller element in the right side as well as for the left side. But I don't need to include these two elements, because these two elements shouldn't be included in the rectangle. So I can safely remove -2 to remove these two elements, and I can update my answer as max of my answer and temp answer. If I do in that way, I can easily achieve my answer and I safely return answer in the end. Let's see, are we do the right thing to solve this question or not? Okay, I just initialize my array and I just keep my smaller right side as n. I just add the default value as n. For the smaller left side, I just did in the similar way. I maintain a stack. Okay, we missed one thing. Okay, what we need to do, because there are many elements, after solving it for the right hand side, for that particular elements, we haven't find any elements in the right side which are smaller than that element. So that element still remain into this stack. So I need to remove all that elements from my stack. So I need to remove, let's say I removed that algorithm from my stack. Okay, so now let's look at the complexity part of it. This is running order of n time, this is running order of n time, and also this is running in order of n time. So the overall complexity will be 3n, which I can safely say it as order of n. Okay, nice. So we just solved this question in order of n time. Nice. That sounds like good thing. Now let's test my thing first. Okay. Let's see the errors. We have an error at 51st line. Okay, I guess the error is okay. It's not nearest. It's smaller. Okay, smaller. And is there anything else? Okay. Okay, this is correct. And you need to push. Okay, now let's test it again. Okay, nice. Okay, everything seems correct to me. Let's submit my code. Let's see. Oh, nice. We solved this question. Nice. So now let's look the other question for today. We have solved both this question. Now let's look into this question. What this question is saying, that we have been given an array of integers. This is a sliding window of size b, which is moving from very left of the array to the very right. And you can see that W numbers in the window. Each time the sliding window moves rightwards by one position, and you have to find the maximum for each window. Okay, so the question is, we have been given an array, and in that given array, we have been given a window. We need to figure out the maximum element in that window, and that window is basically a sliding window. So what does it mean? Let me explain you. Let's say in the starting, we just consider that, let's say we have been given a window of size 3. So in the starting, let's say we consider the first 3 elements of the window, and we figure out the maximum, and the maximum value for these particular 3 elements obviously will be equal to 3. As you can see that 1, 3 and -1, the maximum element for this will be 3. Nice. So now let's look at the other thing. Okay, now for if I just take the other next window for this particular case, the next window will be 3 minus 1 and minus 3. Nice. So if I take this window, and then I can see that the maximum for this window will be equal to 3. Nice. If I take the next other window, then I can say that the maximum for this window it's equal to 5. Okay. And for this window, if I go in the similar fashion, I can see that, okay, the maximum is 5. And for other window, I can see that the maximum value is 6. If I go in that way, okay, if I take the last window, the maximum value is 7. Okay, so this is my question. How I can solve this question? Okay, let's think for this question. Okay, let me move to here. Now, how we can solve this question? Let's see. Okay, we have been given as some array. Let's say we have been given array. Let's say we pick a random array now, 4, 7, 8, 3, 2, 5, and we have been given b as 4. Let's say this is given to us, and we need to figure out the maximum element in each window of length 4. So the first window will be 4, 7, 8, 3. So the maximum value for this window will be equal to 8. Nice. Now the next window will be this, and again the maximum value is 8. Okay, the next window is this, and the maximum value is 8 again. Okay, how I can solve this question? Let me first think. Okay, I need to consider all the windows. So the brute force way will be, I maintain a window and I just keep one start and end, which is referencing my current window, and I just figure out the maximum element in that particular window and I will get an answer. That's the thing that I can do, and I will achieve and I can solve it. But now let's look at the time complexity to solve this question. Okay, if I maintain one window, that means, what does it mean? It means if I need to find the maximum, okay, one way is what I can do. I can just find the maximum. I do the iteration from start to end, but this will lead to other order of n time, and how many updation that I need to do for start end, as there are only order of n windows. As we can see that the first window is of 4 element, then the next window of this 4, and the next window of this 4. So there are only 3 windows, and that's of order basically n. So the overall complexity will be order of n square. Can we improve this algorithm? Is there any way to improve this algorithm? Okay, the one way that we can do to improve our algorithm is, okay, what I can do, I can maintain some sort of structure that we know, and that will tell me the maximum element within a given range. I can do something like that, and maybe that will solve my question. But if I need to maintain that structure, we already know that their segment tree provides that sort of flexibility that gives us the maximum value in a particular range. Okay, and this will solve my problem in order of n to order of log n. If you can use something like that, but even then my complexity will be n log n. Can I improve further if I want to solve this? Let's see. Maybe we can improve it further. Okay, let's say we have been given an example 4, 7, 8, 3, 2, 5. Okay, what we can do? Okay, what I can see here that, okay, let's say the window size is 3. Let's say the window size is 3 in this question. But I can say that, first of all, let me consider the first 3 elements of this window, which are 4, 7, 8. Okay, I just figured out one thing, that if I have only one element, I can store this information. Now I encountered an element which is greater than that element. If that particular element is greater than that particular element, so I can say that this element won't be the answer in any of the window. Why? Because this I just found an element which is greater than this element and has a greater index as well. So that means if there is a chance that I will just need to remove an element, that will be the element of lesser index, obviously, for sure. And if I just figure out an element which is greater than this, so that's of greater use than this. So I don't need this information. So I can safely remove this information and I can keep this information only. Now, in the similar way, if I figured out 8, okay, I can remove this information as well in a similar way and I can just store the information 8 only to solve my answer. Okay, if I do in this way, I can solve this question. Okay, let's see. Now my answer is 8 for this. Now, okay, now let's say I now come at 3. If we figure out an element which is lesser than this element, okay, but I can't say anything now. I can't say anything now because there may be a possibility, because it has a larger index, there may be a possibility that for some other window, this will be my answer. So I need to store this data as well. So that means we are coming up with some algorithm. If we are figuring out an element which is greater than any particular element, if that is the case, so we can safely remove the element which is at the end of my some data structure. And if I figure out an element which is smaller than that element, so I just need to append that element in the end. Nice. But one thing we also need to show that if we go in some other window, we need to remove the elements which are not in that window. And as I am just adding all the elements in the increasing order of index in that data structure, in some data structure, so I can just check whether the first element is of previous window or the current window. If it doesn't belong to the current window, I can safely remove that element. So okay, so one thing that I'm sure that I need, if I want to solve this question by using this algorithm, I need a data structure which will help me in adding in the end, also removing in the end, and also allows me the ability to remove from the front. Okay, and all those operations should be as efficient as possible if I want to make my algorithm faster. So what data structure that comes to my mind? Okay, can I use stack? If I use stack, then these two operations will perform in a good way, but not this. Okay, so what sort of data structure I can use now? Okay, can I use queue? If I use queue, I can do this operation and this operation, but I need to sacrifice over here. Okay, then what other data structure that I can use? If I'm using some complex data structure, then the complexity will be log of n. And we already know that we just build a segment rather than that data structure that will already solve us our problem in loader of log n. So we need some sort of data structure. Okay, one thing that comes to my mind, why don't we use the doubly linked list? In the doubly linked list, we can add, and we have both the pointers, head and tail. We can just add the element, and then we can easily remove the element from the end in order of one time, and add that element in order of one time. And similarly, but we can do this thing in the front as well. If we follow this approach, we make our algorithm efficient. Nice. So in C++, we have this doubly linked list in a form of DQ. So we can use DQ in our case and we can solve this question. Nice. So now let's try to look at the example and we'll solve this question again. We have elements 4, 7, 8, 3, 2, 5. Okay, if that is true, now let's try to think. Okay, I have a window of 3 elements. Let's say I maintain a DQ where if I have a first element, I just put it and I figure out the second element. If it is greater, so 4 is of no use, I can remove that element. So I can put 7, and if of no use, I can remove that element. I can put 8. Now I just end up with the window. What will my answer? It will always be the first element in the DQ, isn't it? Because the way we are just storing the data, the first element of that window will always give me the answer. So if we do in that way, we can just get the things done, man. That's cool. We can do in that way. Cool. So now if I want to consider a next window, it will be something this. Okay, now let's see what is the index of 8. Index of 8 is 2, but in the current, it belongs to the current window, so I not need to remove that element. So what I can do, I can just add 3 here, because I need to add 3 because it is lesser than this element, and this element can be the answer for other windows. So I need to add 3. Now I am at, okay, I just add 3 and the answer will be again 8. And similarly, if I do it that way, I will find the answer. Now let's try to write the code for this. Figure out everything, what is required, and we just figure out the algorithm to solve this question. Okay, how we will write the code? One thing is clear to you, one thing is clear to us that, okay, let's say first take the size. We need a data structure like DQ. And let's say it's BQ. Okay, now I need to iterate over my link, over my array. Okay, let's first do the parts. Let's say first cover the edge cases. If my DQ is empty, and or if I have an element in the end of my DQ, which is basically greater than my current element. In that case, what we need to do? We just figured out in that case, we may need this information. So in that case, we can add this element in the end, and that will help me to solve this question. Now, if that is not the case, what we can do, we can check while, okay, my DQ is not empty, and we are getting, okay, we need to add 4 as well. What we can do, if my element in the back, they are lesser or equal to my AI, because I just found an element of greater index and it is greater than the last element of my DQ. So that means I don't need that last element in my data structure. So I can safely remove that element. Okay, I can do in that way. So in the end, I need that ith element. So I need to add this element in the end. So I am done. But I need to remove all the elements which are not belong to my current window. As we can see that, okay, my next window will start when I becomes greater than or equal to B. So what we need to do in that case, if that is the case, okay, let me first initialize my answer as well. Okay, and so that means if I just end up with an index greater than or equal to B, what does it mean? It means that we just completed our one window. So I can add the answer for that window in my answer vector, which will be the front of my DQ, as I already discussed why it is, isn't it? So it will be my front. Okay, now what I can do, if that is the case, now what I need to do, I need to check whether the first element of my data structure is in the current window or not. So for that, first I need to check the base case. If my DQ is not empty, otherwise it will give us the segmentation fault. And if my DQ is not empty, and we can say that the element, okay, the index of the element in the front should be, if it is, okay, if it is the first element, it's the 0th element. If I'm at the first window, no, if I'm at the second window, then the index, if the index is 0, then I can safely remove that element. So the index will be I minus y, because if I at the next window, my I will be b, and b minus b will be 0. If I'm at the next window, my I will be b plus 1. So if in the front I have the element which is having index 1, so I can safely remove that element. So if I do it that way, I can easily solve this problem. So if I do it that way, what I can do, I need to remove my element from the front. Okay, if I do it that way, I'm done. Nice. But okay, but what about the last element? What about the last element? When I'm at the last element, I haven't updated the answer for my last element. So I need to do, update it here. Let's say, okay, that will be, my answer will be pq dot front. Okay, I just don't need to add the answer dot front. It will be the element for that element. So I need A for that case. I need A for that case as well. If I do in that way, I think this should work. I need maintain DQ. I need maintain vector. When I do in that way, I'm pushing my answer. I'm considering every cases. Now let's test. Oh, I need to return answer as well for sure. So in that way, let's see. Okay, nice. Correct answer. Now let's submit the code. Nice, we solved this question. Okay, Akash based as a question. What's the range of windows can be, sir? Okay, what do you think, Malab? The windows can be of size 1 and it can go up to size n. The order can be of the order of the length, kind of the length of the array, isn't it? That's the maximum length it can have.